You are currently the only person in this conference.
Have created it. You guys, I want you guys now and then, because I want to see if people is following. So is people able to get the call up running? Can you guys write down a yes or a no if you're running into problems? All right. Yeah. Thank you, guys. That's good. Perfect. Next things. All right. So usually this is used for, it's mostly used for Python because it's got a Python on the background. But we're going to do a bit of a hack. I like to use this tool on workshops because it's very easy. And I want so what we're gonna do, it's going to be a bit of a hack, because we're going to install stuff on the this runs in the background on Ubuntu machine. So we're gonna install a ROS system, and then we're gonna try to create some stuff with the ROS. So everything is not gonna be 100% smooth. Some things, sometimes the collapse system will bring it down, and then we have to bring them up again. But hopefully we can manage. I've been trying it for quite a while, and it seems to work okay. And I think it's a much better way than having to install the entire system, because to be honest, ROS is not a very simple system. It's a bit heavy. So it might be very overwhelming to cope with the entire install and all that. And different people have different problems, and that can delay a lot of the workshop. So that's why I decided to go with a bit of the hacky version of running everything on Colab. So let's go and see how it is. So Colab, for those of you that don't know it, has two main features. So basically, you can write code on the cells. This is a cell. Like, write down what you see here. It's a cell. So I can just write code here. Like I can say print, and I can say hello, right? So this, and then I can press you can press the play here. It takes a while because it was initializing and all that. And I said print hello, and it's printing hello. And this is Python code, right? So what we're writing here, it's in these cells, it's Python code. But today we're not going to write Python code. We're going to write C++ code. Don't worry if you don't know about it. You're not going to have to write it. You're not going to have to. I'll explain every single line that we go through. So should be quite easy for everyone. So as I said, every single one of these cells will be a piece of code, but you can also add text. So if you click on text, you'll see that the cell that appears is different, and you can say this is some title, right? And then this is something that you can even give it like some title format or whatever. And then once you execute this, you can press Shift Enter, and then you will get some title. So this is very nice for you to give some sections to whatever we're doing here. So just keep in mind that there's a title bar, there's text and code, and you can use the text to intersect between the code, so to make it look nicer or to give sections to whatever we're doing. I'll try to do that myself. Sometimes I forget. I'll try to add some text so you guys can follow up. So for example, this one, I'm gonna call it. We're gonna start with like an installation of ROS of the basic ROS. Install ROS. So this is the first thing that I'm gonna do, and I'm gonna remove this one. I'm gonna start with the. I'm gonna remove the example of printing, and we're gonna start by installing the ROS. Another thing that I wanna explain before we go ahead is that in this workshop we're gonna use ROS 1. But I don't encourage anyone to use ROS 1 because ROS 1 is at the end of its life. So the last version of ROS came out already, and it's going to end up, I think it's around 2025. But ROS 2 is already at a stage that is ready for everyone to be used. The problem is, and that's the reason we're not using ROS 2 today here, is that the version of Ubuntu that runs in behind Colab, it's a specific version that contains a specific version of Python. So installing ROS 2 was a headache, and it took for a long time. I was trying to compile, and I was not even successful. So there was a point that I gave up on that. And I think the concepts that we're going to explain today are quite understandable with the ROS version that comes along with the Ubuntu installation of Colab. So I think it's enough for us to grab the concepts that we're going to try to explain today. But if you want to get into ROS and after this you want to do your own tests, or you want to do your own deployments at home, please, I encourage you to do ROS 2, preferably on the latest version, so you can already start working on the latest stuff. But yeah, as I said today, things are going to be a little bit different. I'll try to explain the differences between what we're doing and ROS 2. So whoever starts with ROS 2 later can go on and learn all that from today. So the first thing that we're going to do is that, because this is an Ubuntu machine, we're going to do, we have to, also one thing that these cells are ready to run certain commands and Python code. So it only supports certain commands and Python code. So when we want to run a Linux command, we have to put an exclamation mark. So I'm going to put an exclamation mark, and I'm going to do apt get update, which is basically to update the repositories. For those of you that know Debian, you already know this one. I'm basically just updating the repos on the system right now, right? So everybody should be able to do this and get all the packages installed, not the packages updated. So now we have all the list of packages updated from the repos. And it already comes with a version of ROS that we're going to install. So we're going to do exclamation mark apt get install ROS base that. So this is ROS base is ROS always comes with different meta packages that will install a certain group of packages that will get you started with ROS. So this basically will install the ROS based part that we need for development. So we're gonna go ahead and execute this cell. And this is gonna take a while. And you'll see like there's a lot of text coming out and all this. So because this is going to take a while, I'm going to go ahead and do a little bit of a presentation on the on what we do and all that, and a bit of the introduction of what we're going to do today, while the whole thing is installing. Anyone having problems? Just write me on the chat so I can have a. All right. Let me know if you guys are running into problems so I can solve them. I can send you some tips. All right, so I'll run into the presentation, and this is a little bit. All right, this is a little bit for those of you that were not here yesterday on my talk, and also to refresh a bit of the concepts that we'll see today, right? So yes, my name is Marco, and I work at Open Robotics, and we have two main softwares. One that is called ROS, and that is the one that we're gonna mainly use today. And I'll do a little bit of a show on Gazebo so people can get an idea of what it is. So ROS is basically to write the software for the robots, and Gazebo it's for simulating robots. So basically, the idea is that you use ROS to write the software, you test it in Gazebo, and then you move the same software into a robot, and it should work the same way. So a little bit about who we are. We are Open Robotics, and we like to create open software and hardware platforms for robotics. And we like to use those platforms to solve important problems and help others do the same. There's three main projects that we are working on. ROS, which is the one that we're seeing today, and ROS 2, which is the current and latest version of ROS. Then we also have the simulation part, where we have Gazebo, and then we also have a rewrite, which is Ignition, which is a bit of a decoupled version of Gazebo with different libraries that you can use. So ROS, despite its name, is not an operating system. It's mostly a set of tools and libraries that makes easier the task of developing robots. So there's 4 pillars of ROS. One of them is the plumbing. So the plumbing, it's a message passing system that allows you to connect different parts of the system and let them pass information to each other. In robotics, the way we develop things in robotics is very distributed, I would say. So you would have different processes doing different tasks, and then you would have message passing between them. So let's say you would have a camera that grabs an image, and then you would send that image to an algorithm that will do some facial recognition, and then you will do the face selection, and you will send that information to some other part of the robot that does something different. So this plumbing is, I would say, is one of the main things that ROS provides, and it's one of the things that we're gonna play around with today.
Marco, could I pause you for just a moment to ask you to stop your screen share and restart your screen share? We're just trying to debug something on our YouTube live stream.
Yeah,
I'm
sure.
sorry to interrupt.
I will do it right away.
Thank you so much.
Share and rerun screen share.
You are currently the only person in this conference.
All right. play it, do different things to it. We're also going to play a little bit with it. There's a few tools that have a GUI. Sadly, because we're using this Google Colab thing, we won't be able today to use the GUI tools, but we'll be using some of the command line versions, and we'll see how those work. And then we have capabilities which are mainly very cool algorithms that very smart people developed and are ready for you to be used. Like, for example, if you're doing navigation, you can run a localization algorithm, obstacle avoidance, or whatever. It's already there, right? And then there's an entire ecosystem, because this is open source. Then you have an entire ecosystem of users, developers, and code that you can build up when you're working on ROS, right? All right, so a little bit of the architecture, and I think this is important. There's differences in ROS and ROS2, mainly because ROS2 is a rewrite of ROS, keeping in mind everything that we learned with ROS, right? So when ROS was born, it was born, I would say, in a very research-oriented environment. Certain things were not a priority, and then as ROS became so popular and ROS became more and more adopted, then some of the drawbacks came to light, and people realized that they should have been done in different ways, or they could have been done in better ways, taking into account other aspects. So one of the key things that you would see when you use ROS versus using ROS2 is that there's a master node. So basically, this master takes care of these communications. So you always need it running. And you will see today that it's a bit of a pain to keep it running, because Colab will shut it down every now and then, because you need to keep it running in the background for your code to work. So every now and then you might have to go back and rerun the master, so your nodes can talk to each other. And then underneath there's this set of libraries, ROS CPP or ROS PI, that allows you to write nodes in different languages, and they can talk to each other even if they're in different languages. And then we have the communication layer, and then we have the Linux system. That is for ROS. But in ROS2, everything is a bit different. We don't have the master. We have RCL, CPP, Python, Java, and some other languages for you to write code in different languages. And then you have the RCL, and then you have an abstraction layer for the communications middleware. And this uses something called DDS, which is a standard. So because it's a standard, there's many vendors that provide an implementation of this standard. And in ROS2, we allow people to use whatever vendor implementation of DDS they want. So you can easily change your implementation of DDS by just installing whatever implementation you want and just changing an environment variable on your system. And we also increase the support into Linux, Mac, and Windows. So that is also an important change that we did in ROS2.
Marco, quick question. Yeah. Before you had shared your screen without your video appearing in the corner, and I think when you added your video in the second time, the bandwidth is maybe too much. I don't know if you're able to go back to the configuration you had the first time around. We're getting kind of blurry slides with your video embedded.
I can remove the camera.
Yeah, let's try that. Hopefully that helps. Folk, Patrick and others in the chat, let us know if you.
Okay.
Thank you.
Thanks for your help. Yeah. So regarding versions of ROS. All right. Nice. Yeah. So regarding versions of ROS, we have melodic and we have noetic, which is, as I said, the last version of ROS 1. So it will have an end of life on 2025. And then, let me move my And then regarding ROS 2, there's much more options. We have dashing that is currently until May. And then we also have Foxy, which is it's an LTS, so it'll be running for 3 years. And then we have Galactic, which is coming next May. Once dashing fades off, then Galactic comes over. And then we have more releases coming. And then we also have the rolling release, which tries to keep the latest code compiled for you guys. So now, we're going to have a look at what we're going to do today. So this is the first example that we're going to run. It's a very simple example, and it's the first tutorial that everyone runs in ROS. And basically, there's this concept of nodes, which are entities that run a certain code. And if you go back to the example that I told you guys of the camera, you could have a camera with a node that picks up the images and send the images to some algorithm that does some processing with that image, like face recognition, for example, right? So you could think of like this publisher up on the right. Let me use this, the pointer. So you can think about this publisher up on the right as the camera node that is sending a message that is the image, and it comes down here to the subscriber. And this is the guy that is reading the images and is using the images to check for people in a scene, right? Or like, let's say this robot is trying to find people. Yeah, it's something similar with to MQTT. It's a message passage system, so basically it's something similar to that. And then we have topic, which is what allows you to name this flow of data. It's basically the name of this flow of data. So you can say this publisher is subscribing is publishing this topic. This subscriber is subscribing this topic. So they basically know what is the data that they're gonna get. Yeah. So today we're gonna focus on this version of publish subscriber, and we're gonna try to make one publisher and one subscriber in our collab. I'm gonna talk a little bit about the other versions. So let me finish with this. Publish subscribe can also be many to many. So you can have many publishers publishing on one topic. You can have like 2 cameras publishing images on the same topic, and then you can have one algorithm getting images for face recognition, and the other one can be just checking for, I don't know, cars in the scene or something else, right? So it can be many to many thing. Publishers and subscribers can work on the same topic without restrictions. But then there's another way of communicating with ROS, and it's through services. So once we do services, we have a service server and a service client. And you can think about this as a remote call to a function. So basically, when you call a function, you basically send a request, and then you get a response, right? And the message basically contains some information that goes into the request, and then some information that goes into a response. Let's say like I wanna add 2 numbers, then you can send 2 numbers this way, and then the server node will actually respond with 1 number in the other direction, right? That is services. But I don't think we're gonna have time to get into this today. So basically, this is for you to know that it exists. For services, there can only be one server, but there can be multiple clients asking, right? So I can have this server doing the summing up 2 numbers, but then I can have as many clients as I want asking for this server to do the math. That is the services version. And the actions is a bit of a more and the actions is a complicated concept, which basically consists of asking for a long-term goal, long-term action you can think of. And basically, the client will send a request to the server that will send a response on that request. And while the node is doing this long-term action, it will keep publishing feedback that other nodes can subscribe to figure out how the task, the action is going. And then once the action is done, there's a result that will come back at the end. As I said, we won't get into this, but it's just for you to know that it's there. So yeah, let's have some fun and try to run some ROS code. All right, so everyone should have everything installed already. Should be installed. All right. So first thing that you do on ROS1 is to run the ROS core. And it's this process that has to run always in the background, and we need it so our process can communicate. Once you do it in ROS2, you'll realize that this ROS core becomes a pain, which is the master node. And sometimes if it's not up, we won't be able to do stuff, right? So the first thing that we're going to do is that we're going to use an IPython function, so we can run the ROS core in the background. So we do get _ IPython open close brackets dot system _ raw, and now we're gonna do ROS core and asterisk sign, right? So it runs in the background. And now we run this one. And you shouldn't see anything because this process will go into the background. But now, let me add some text. I forgot to add some text. Running ROS core. Before this one. There you go. Let me add some title. Yep, this is a title. Running ROS core. Now we run the ROS core. All right, so let me go down and add some code after running the ROS core. So now we have the ROS core running, and there's a few things that we can do. So we can list the number of nodes that it's running. So we can do, because we're gonna run a normal command line, again, we're gonna use the exclamation mark. So we do exclamation mark, ROS node, and let's just run ROS node and see what happens. So as we run ROS node, you'll see that it's a command line tool for printing information about ROS nodes, right? And then we have a bunch of things that we can do and a bunch of options that we can select from. And I'm going to create another cell, and I'm going to do exclamation mark ROS node list. And there we go. We have something called ROS out, which is in charge of the output, and it's created by the ROS core. So that tells us that we have something, the ROS core is running, and we can start doing our own stuff, right? So ROS node is for us to interact. It's one of these tools that ROS provides us to interact with nodes. And then we also have ROS topic. ROS topic, which is, as we run ROS topic, exclamation mark also at the beginning, always. As we run ROS topic, we can see that we can do different things with the topics, right? So topics are being published, and we have we can check the bandwidth of what's going on in that topic. We can check the delay. We can echo the topic, which is very useful because we'll print whatever is being published on that topic. There's find to find topics. There's the earth to get the publishing rate. There's info to get certain info of who is subscribing, who is publishing on that topic. There's list to list all the topics. Pub, you can actually publish directly from the command line. So you can use ROS topic pub to publish directly from the command line. and if you want to test different stuff, and then there's type to figure out what type of data is going through that topic, what type of message, right? So now we have the tool for the topic, and we have the tool for the node. Now we're going to create our own ROS package. And in this ROS package, we're going to try to create a publisher and a subscriber. And then we're going to try to run the publisher, and we're going to try to run the subscriber, and we're going to try to see if they exchange messages. And bear in mind that we're going to have to rerun this ROS core every now and then, because sometimes the runtime will kick it out. I don't know exactly why, but I think it's not very happy with processes running in the background. And when you interact with them and stop your process, then the ROS core also stops. So just keep in mind that if things doesn't work, then you should go and rerun that one. Another thing about Colab that it's important is that we have a files here. So if you click on this folder on the left side, you will see certain files, and you can see the entire operating system if you the entire file system if you click on up one level. And this is the entire file system that we have here. So we're going to be working a bit with files. So this is important that you know where the files are and all that. All right. So let's go ahead and try to create our first package. And we're going to do, we're going to create a working space. So usually when you install ROS on the normal way, it would be installed in OPT. So if you follow the instructions for installing ROS, it will be installed in OPT. Whereas because we installed the version that comes with the operating system, which is a very old one and all that, but we did it just so it's easier for everybody. It's installed in the regular directories of the system. But usually you have it in OPT, and the reason that the ROS guys do this is because it's easier for everybody to install. It allows you to install several different versions of ROS. So usually we found out that people likes to have different versions of ROS. There's many use cases where they have different versions of ROS in the same system. And you have them on OPT, and basically you source them whenever you need them. And we'll see this source because we'll have to source our own workspace. So basically, you source the ROS version that you're using, and you also have to source whatever workspace that you're using. And this sourcing means that it will basically load all the environment variables that are needed, so you can use all the tools and you can run all your packages, right? So let's go ahead and create our own workspace. So let's go and do exclamation mark make dir mkdir -p, and we're gonna do on our home. So we're gonna use the home symbol. Basically, this will go into root because the user has the home on root, the user of Colab. So we'll do catkin workspace src. So we're going to create these two directories. We're going to create catkin workspace, and we're going to create something called src, which is where our source code is going to go, right? So we run this, and
You are currently the only
somewhere
person in this
here,
conference.
if we press this button refresh, we should see the catkin workspace here, and we should see a source directory here. So why did I call it catkin? Is because the tool that we use to compile the software is called catkin. That's another thing that changed between ROS 1 and ROS 2. And the version, the new tool that we use in ROS 2 is called Colcon. And it's much more advanced, much more complete. And that's why there's a rewrite of it. So it's easier for for the developers. Now that we created this, we're gonna cd into it. This command doesn't need the exclamation mark, so keep in mind that you don't need to use the exclamation mark for that. So we're gonna go into, let's run the cell, and we go into the, so now if we run another cell just to make sure, we can do pwd. Let's see if this one is supported. Yeah, so we're already there inside this source, which is where we're gonna create our package, right? So now I'm gonna run a catkin create package. So this is also different in ROS 1 and ROS 2. So we're using a ROS 1 command, which is catkin create create underscore pkg. This basically will create a package, and in ROS 2 is a different way you do ROS 2 package, but the concept is the same. It's just changing the way you do it basically. And then we're gonna give it a name, this package. So let's call it FOSSASIA package. Right, we're gonna call it FOSSASIA package, and we're gonna add a bunch of a little bit of dependencies. So we're gonna use something called std messages, which are the standard messages that we can use to pass between nodes. We're gonna use standard messages, and then we're gonna do let's do ROS CPP, which is the ROS library for C++. Basically for C++ code, right? So we're running this, and nice. We created a file, FOSSASIA package XML, created FOSSASIA CMake list, and then we also created an include directory, and we also created a source directory, right? So it basically creates the basic files that you need. And if you open the FOSSASIA package, you can see the source is created, the include is created, CMake list, and package XML, right? And right now, if you go into, let's go back to cd our Catkin workspace. So we can go back to our Catkin workspace, and we can just compile. So we can try to compile our package, catkin make. Yeah, there you go. There you go. It's running all the CMake and blah, 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 running command, blah, 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 and it finished. So it's been built already. So we created a package. It's an empty package for now. We went into the walk-in space. You always have to go to the root of the Catkin workspace. From the compilation process, right? All right. So we now know how to create a package, and let me explain a bit of the stuff that we have here. So the CMake list uses CMake. For those of you that don't know, it's a tool that is widely used for compiling easy compilation of C++ packages, and it allows you to cross-compile to different operating systems. And as you see, this is a very big CMake file, but everything is commented. There's comments everywhere, but it's basically so you can remove the comments whenever you need it, and it's a placeholder for you to build on whenever you're adding stuff to your package. You can see that we have find package here, required components, because we said that these are dependencies. So as we added the dependencies to the command when we created the package, these had been added here also as a dependency. Then if we create messages, then we'll add them here. If we have services, we'll add them here. And if we have action files, we will add them here, right? And then we will add at the bottom whatever libraries or if we're creating binary files at any point, right? And we'll do that in a moment. All right, so we have the CMake, we have the package XML. I found out that for some reason, Colab doesn't let me edit the package XML. So I have a trick for you guys. And the trick, I know this is very hacky, but I know already running ROS on a Colab, it's hacky. So there's many shortcuts that we have to take. And we have to rename the package so Colab can allow us to edit it. So if you rename it, so if you rename it to a TXT, then you will be able to open it here, which is an easier way to modify it. Just keep in mind that you have to rename it back again later. So basically, the package XML contains the basically information about the package, and here's where you state the name of the package. This here is where you state the version, some description about it. This is a package that we built at FOSSASIA and all that. And there's dependencies that you should write it down here. And basically, these dependencies will tell what is the building tool that is used, what dependencies are this package depends on, and on execution time or on build time, right? So it's very important that this is correct, because then there's tools from ROS, like ROSDEP, that will use this heavily. And ROSDEP is a tool to automatically install all your dependencies. So it's very important that this information is accurate, because otherwise it will become very hard to maintain your code, and it will become almost impossible to keep track of what you're doing. So let me go back and rename it. I don't know if I can keep it there. Let me see. Let me go back and rename it. I think it will create a TXT file, though. I think that happened before. Anyway, so up to now, let's recap. We have our package, FOSSASIA package. We have our package XML with a CMake. We have the source, which is where we will put our CPP files. And then we'll have our include, which is where we'll put our header files, if any, right? Now, we're gonna go into this folder. We want to go into this folder, and we're gonna download. We're gonna download the publisher, and then we're gonna download the subscriber, and then we're gonna put them here, and we're gonna compile them and see what happens. Let me go. Let's check where we are. So let's do a PWD. All right, so we're at Road Cat King. So we're gonna just move us into SRC, FOSSASIA package SRC. So let's go there. All right. And now that we're here, we're gonna download. I'm gonna just paste this because this is a big command. We're gonna download an example from the ROS tutorials page. And let me just copy it, the whole URL. I'll put the entire command so you guys can just copy paste. No, send to the group. All right, so this is the first one, and this is the Docker. So you guys just copy that. So it's doing exclamation mark wget, which is basically this command line tool that downloads files from the web. And we're going to download this CPP file. And we just run it. And we got the Docker now. And now if you check the SRC, remember that you have to press refresh because Colab won't refresh by itself. Now we have the Docker here, right? And if you double click, you should be able to see the Docker on the side, the code of the Docker. And there's a lot of comments. There's a lot of comments here. Oh, this is not the Docker. Yeah. So we got a copyright from Morgan and the guys from Wheel Garage, which is when these were written. And there's a lot of stuff. We got the headers. So we got the ROS header, which is basically the main one that you have to include. And then we got a string, which is the message that we're going to use. This is the standard message. That's why we were depending on standard messages, if you remember. And we're using SStream to, this is the way that C++ uses for managing streams. And then we create a main, which is the main function in C++, for those of you that don't know C++. We do a ROS edit, very simple, with the name of the node. So the name of the node is going to be Docker. So this node is going to be called Docker. And we create a node handle. And then using the node handle here, we create an, we say that we're going to create a publisher. Wait, let me just, I think this is too small, maybe. Let me make it a bit bigger. Yeah, so we got, the node handle here, and from the node handle we create the charter. This is the frequency, which is 1000, and we're gonna make it. We create this advertise function will return a publisher for us, and we save it here, charter pub, and we create an object. We create a loop rate. This loop rate is gonna basically allow us to have a loop and pause it every now and then. And we have a counter here, and then we say while ROS okay. This is pretty standard. And then we create a message. We create a stream. So we pass this hello world to the stream, and then we just get the string from the string, and then put it into the message data field. So there's a data field in the message that contains the string, and then we use the function rosinfo to print it out, and then we do the charter pub, which is the publisher that we created up here. We created a charter pub, if you remember, and we call the function publish with the message, and the message is published right here. And then we do ROS spin once, which basically tells the executor to execute, to give time to execute whatever is on the executor. Then we have a loop rate sleep. We sleep for a while, so it doesn't go crazy. And then we add a count for our message, right? So we have a count that keeps the number here, and it keeps increasing. So we can see hello world 1, hello world 2, hello world 3, right? There's many comments here. So feel free to play around with it, read them, And you can also go to the website if you have some doubts. Well, they explain in more detail everything that is done on the Docker. So now we got a Docker. Let's download the listener. So the Docker is the guy that is publishing, and the listener is the guy that is subscribing. So let me copy this, and let me put it. Right, there we go. There you go. So this is the listener, and this is the subscriber that we're going to use. So if you run this, you should be able to get the file on your, I think, where was it? Did we got it? All right, yeah. So we got it here, right? Should be in SOC. Yeah, listener and Docker, right? I see some guys are still having problems. Remember that if you don't see, let me share this again. Remember that if you don't see my screen or whatever, you can also just access this link, and you should be able to access everything that I'm writing, and you should be able to copy into your own Colab version. All right. So going back to the subscriber, right? So we got the listener here. So let's have a look and open the listener. All right. So we have the listener. Again, including rows and string. And then we have a callback here, which basically gets a message type string that it's the message that we were publishing with the other guy, and we're just printing it using rows info, right? So this macro from rows allows us to print strings. So we're going to print I heard and whatever it's on the message, right? So this is a C string, and we're going to print that in here in this placeholder. Then we have the main function. As I said, we also do rows edit with the name of the node, which is a listener. Then we create a rows node handle, and with the node handle, we create a subscriber. Similar process, but just doing the subscriber version. And we call it, we do a chatter. We subscribe to chatter, and then we tell the subscription to every time there's a topic in chatter, there's a message in chatter, call this chatter callback, right? So every time there's a message in the topic, it will be called this function here, right? And because this is a type of message, it will be called with the type of message that it's being passed in that topic, right? So we got the subscription here, then we do a raw spin, which is standard also, and then we return 0. And that's it. Very simple. All right. So we got our publisher, we got our subscriber, and now what we need to do is that we need to add the specific lines in the CMake list, so the compilation it's aware that we have now a Docker CPP and a listener CPP, and we want to compile them. And these lines are pretty simple, and I should be able to get them for you guys so we don't have to write too much, because that takes time and I'm lazy. Let me just get it from here. All right, so yeah, I'll paste them on the chat so everyone can get them. All right, so there you go. You guys have them in the chat. And now we're gonna paste them at the end. Let's just paste them at the end. They should work, right? So basically, we're telling CMake to add an executable that it's called Docker and has the source that is this CPP. And it links to the normal Catkin libraries and has the dependencies, the normal dependencies, Docker and the generate messages CPP. And the same for the listener. It's the pretty simple way to add executables into the CMake list, right? So when we added this, when you modify that, you should see an asterisk here. So if I do something, you see there's an asterisk here, and after a while it auto saves itself. If you click away, I think it should save itself and it's removed. So then you're safe, and you know that the file is already saved, and you can continue with your work on whatever you continue doing. All right, so almost there. We got the Docker, we got the listener, we got the publisher, the subscriber. So now we're gonna go back to the we want to go back to Catkin workspace so we can compile our two nodes. So we're gonna go without the exclamation mark, because this one works already without it. So we're gonna go to Catkin workspace. So now we're back at root Catkin workspace, and now we're gonna do our Catkin make, exclamation mark Catkin make, and you will see all the output from the all right, and our Docker is built and our listener is built. So now we're gonna try to run our Docker. So let's try just to so to run an executable in ROS, you will use something called ROS run. So let's run ROS run, and this will show you how to use ROS run, and it's basically telling you that you have to tell there's a few options that you can use, but you basically have to use the package name and the executable. So let's go ahead and use the package name, which is FOSSASIA package. And we're going to run the Docker, right? So let's run the Docker. And let's see what happens. And it's saying that the FOSSASIA package is not found. Why is that happening? It's because the environment is not ready to find our package yet. And why is that? It's because you have to run. Let me run. You have to source the install the setup.bash that you have on your devel directory. And as I said, this is very common, and this is a thing that you will have to do whenever you install the ROS from the official repositories, because we want to keep it separate, and we want you to source the different versions that you want to use in whatever way you want to do them. And because we're having a workspace that is specific for us, then we have to source the setup.bash. Because there's Colab doesn't keep the environment variables between cells, we'll have to do it in the same cell, and we're going to do it in the same line. So I'm going to just write between the exclamation mark and the ROS run, and I'm going to just say source devel for the slash here, and I'm going to say setup.bash, and I'm going to do #, right? So basically what we're doing here is that I'm saying, please source this setup.bash file and ROS run me this Docker. ROS run from the package, FOSSASIA package, ROS run the Docker node. And now I'm going to execute this cell. And you can see that now we're publishing this hello world 0, hello world, blah, 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 right? Keeps going on forever. Because we have, if you remember, we had a while ROS OK on old Docker. So if you come to the Docker, there's some while ROS OK. And ROS seems to be OK, so it keeps going, right? So if I click here, I know collab becomes a bit annoying and it takes some time. So you guys can see that it's hard to stop the binary. Let me just clear this. How to clear this? Because it becomes annoying. Yeah, there's a point where Colab will kill it when you click too much. But at the same time, it will also probably kill the ROS core, as I said, that we have here, right? So ROS core is here. We'll have to rerun ROS core. We can just check if we do ROS node list. You will see that it's unable to communicate with the master. So there's no master running. So we have to go back all the way up to the line where we were running the ROS core here. Get IPython system ROS core, and then we run the ROS core again. Right? Now, if we run ROS node list, we'll see that ROS out is already there, right? So we want to run this, but we want to run it in the background. So we're going to do the same thing that we did with the ROS core. We're going to do get IPython, and then we're going to do system raw. And then we're going to put this into the brackets and between single quotes. And remember to add the ampersand at the end. So this runs in the background, right? So we run this. Oh, without the exclamation mark, sorry. No exclamation mark. All right. So now that is running in the background. And we can do ROS node list. And we'll see now that we have a Docker, right? So our Docker is running in the background. What else we can do? We can do ROS topic list. ROS topic list. There you go. We got a chatter now. What is this chatter doing? We can check. Let's go check. So we can do ROS topic echo chat. Oh, we can do some other stuff, right? ROS topic. Let's see what ROS topic allows us to do. So I can do type. Let me do type. ROS topic type of chatter. You guys remember what chatter was doing? What type of message was chatter? Let's see. Oh, it's from the standard messages. Is the message string. So that's the one that we defined, if you remember, right? Remember standard messages string. That's the type of ROS topic. ROS topic. What else can we do? Let's see all the options. We can check. Let's see if we can check this. So we can get the rate that's being published, right? So these are the tools that ROS is providing us to interact with our system and to introspect what is going on. We can also, there's also another tool that it's not, I don't think it's installed with the base one, but it's called ROSback. Let me see if it's installed. I don't think it's installed. Oh yeah, it is. Yeah, so ROSback is another tool that you can use in ROS to basically record information from these topics, and then you can replay it later. And this is a very useful tool because you can basically use it at any point, and you could use it with let's say with a real robot, right? Let's say you have 5 hours with a robot, and then you have to go home and you want to continue and you want to continue later. So basically you would do a ROSback, you will save all the information that you want, and then you can replay it later, and then you will have all the topics ready for you to rerun different algorithms with the same exact information coming out of the robot. So that is very good to get some deterministic input that you can play around with. And also to replay information when you don't actually have the source of that information, right? So if you borrow a camera from a guy one day and then you want to play around with the data for the next week, then you can use a ROSBAC, and it makes things much easier, right? Or setting up a robot, whoever did it ever, it's always a pain. You have to turn on a lot of things. A lot of things can fail. So you can set it up once, get a ROSBAC, and then play around with the ROSBAC for the next week. You don't have to go back and do the whole setup again. Very useful tool. All right, so we should have the ROS node in the background, right? ROS node list again. Oh, the master is gone again. I told you guys the master goes off every now and then. When we so we go back, rerun the master. Remember, this is very important. Every now and then the collab will kill our master. And now we can do ROS node list. And we only have ROS out because the master died. So also our Docker died. So we rerun the Docker. I know this is a lot of reruns, but that's how collab works. It's killing our background processes. So we got the Docker now, and we got the list. Let's run the subscriber. Let's go run the subscriber. So we're gonna do the ROS run. Let me find my mouse here. All right, there. So we're gonna do ROS run FOSSASIA package, right? So from the FOSSASIA package, we're gonna run the listener, right? And again, one thing that I'm missing here is to source the setup bash. As I said, this is only specific to Collab. You only need to do it once per terminal on your computer. But because Collab doesn't keep the environment variables between cells, then you have to do it in every cell. Maybe there's a way to keep the environment variables, but I'm just not aware of it. I didn't found it. Devil setup bash. All right, so we're sourcing the bash and // ROS run FOSSASIA package listener, right? So this listener should basically what was the name? Should subscribe to Chatter and should be publishing printing whatever the Chatter is publishing. So if we go to the listener here, the ROS info that we had, right? So it would call this callback here, and it will say I heard, and whatever is heard, it will be placed in this placeholder here, right? Let's see if it's true. Let's run it. And there you go. It's saying I heard, hello world, and a very big number because this Docker has been talking for quite a while now. And yep, a bunch of hello world messages. So congratulations, everybody. You wrote your first publish subscribe demo with ROS. Now you're able to create your own robots. Please go ahead and go get more tutorials. Let me just talk a bit about like other command line tools. They need to stop this one. All right. Now we stopped it, and let me clear the output because it's very long. All right, so we're almost done with the ROS part. Just a couple of things. There's a ROS service list. ROS service will allow you to play around with services. So as I said, publish subscribe is not the only way to communicate nodes in ROS. You also have services. There's different arguments. You can call services from the command line. You can list them. You can check the type in a similar way that we did with the topics, but with the services. And then you can call, get the result, and all that. There's also definitions of, you have to define messages. So in this case, we use the standard messages, but you can define your own messages with different fields. So a way to check that is to use the ROS MSG tool. And with that tool, it allows you to list the messages, check the MD5 sum, check information about the messages. And you can also do the same for SRV, ROS SRV, which is the message for services. So basically, these ones are a bit different. They have, as we said, there's a type of information going to the server, and there's a type of information coming back to the client. And you can introspect this in the system using this command. There's a bunch of other commands, but I think we don't have much time. So for now, I'm going to stop the ROS part here. So Colab, it's done. Remember that you guys can access my Colab if you guys want to copy anything. Apologies for not adding the text. I told you guys I would forget. I always forget. But feel free to add it on your version, make it pretty and all that. Just a quick review of Gazebo. Because this requires you to install Gazebo, this is not hands-on workshop, so I'll just showcase whatever it's there very quickly, and you guys can have a look. So the basic idea is that once we done our ROS, once we wrote our ROS code, we have something called Gazebo that allows us to have simulated robots, and then you can use our topics to talk to these simulated robots, right? And the main idea of Gazebo is to make it as close as a real robot as it can be. So as you have your nodes of ROS running, talking to the simulated robot in Gazebo, and you get your real robot, then you can just switch your code. And instead of publishing and subscribing to Gazebo, you can publish and subscribe to the real robot, and it should just work. So Gazebo tries to provide physics, sensors, a GUI. It provides the interfaces, so you can connect with ROS, which is what we recommend, and it's what we do. But you can also connect with everything, anything else that you want. You can create your own interfaces and connect to Gazebo. There's a CPP library that allows you to connect directly from. I'm trying to simulate navigation system with the GPS and it's possible to simulate. I'm trying to simulate navigation system with it. So Gazebo allows you to. I haven't used Gazebo that much to say if there's a GPS. I'm pretty sure that you can simulate. I'm 100% sure that you can do it because Gazebo has something called plugins. So you can write down your own plugins, and if there's no is that device that you find missing in Gazebo, you can just write your own and then load the plugin, and that will do it for you. So it's modular, not as modular as the new rewrite as Ignition, but you can run your own plugins and create your own devices on Gazebo. There's a couple of versions that are running these days. Gazebo 11 and Gazebo 9 are the main ones that are currently alive. And as I said, the main point is to have the simulated world as close as the real world, so we can use the same code. And in our case, as I said, we use ROS, but you can use whatever code you want. There's TCP/IP sockets, so it doesn't have to be ROS. It can be different ways of connecting, but we provide the Gazebo ROS packages, so you can connect your topics directly into Gazebo. All right, so let me just run Gazebo a bit. So Gazebo uses world files. All right, 5 minutes. So Gazebo uses walk files. So here let me just close this. Let me just I'm gonna share a different screen now because I'm gonna try to focal. I'm trying to figure out what is the screen. Let's see if this is screen. No, this doesn't seem to be the screen. Okay. Okay, let me just run the Gazebo so we don't run into. All right, then I'll share just the Gazebo screen. It's not asking now.
Marco, you want to try to stop sharing your camera first and then share your screen.
I think I found it. It should be working now. Let me just try. Yeah, that should be fine. All right, so you guys should be seeing Gazebo now. Yeah, so this is the simulator environment. I'm just running one of the models that was available there, and it's basically just moving around. So the purpose of this was to, yeah, hopefully you guys can see it in a bit. I think it takes a while. All right, yeah. Yeah, so Gazebo provides a lot of tools. There's a hidden, it's very hard to open. There's a bunch of stuff that you can do around with it. There's a world where you have the models. So I have an actor here. This is my actor. You have Gazebo worlds are saved in world files, and you have different tools. You can move your guys from one place. You can move your models. You can play around with them. There's different ways of moving your models here. You can add basic stuff. This is at the bottom. You can see the simulation parameters. So basically, you can stop the simulation. You can play it. You can jump steps on the simulation, and then you also have a real-time factor that indicates what is compare simulation time compared to the real time. What is the difference? So right now we're at 0.95, so it's a bit below real time, and we have a start time, simulation time, and a real time, which won't be different, right? Because we're not running the real time factor 1. So if we're running a real time factor 1, simulation time and real time will be the same. Then you have the steps and iterations that are going on, and FPS, the frames per second, and you can reset time here. There's many options here, basically to move your models. This is to align your models, play around with the lights. You can set up lights. You can do all the tools, basic tools that you want to move your models. And there's on the world you can play around with the GUI. You can play around with the you can play around with the spherical coordinates. We can play around with physics. This is one of the most important ones. You can select the physics engine that it's running. So it's running ODE, which is the default one, but you can change this and compilation time. This is a bit easier with Ignition because that doesn't have to be compiled and all that. So this becomes much easier. You can change the real time, maximum real time. So if you wanted to run, this is 10 seconds real time. You can select the steps of which the physics are running. And there's a gravity that is 9.8, as everyone knows, but you can change it and you can make it a different gravity. There's magnetic field on the physics. You get your solvers, there's the constraints, you get wind, you get pressure. You get different values that you can adjust on your simulation to make it more accurate to whatever model you want to change. And then you can insert different models. So there's a bunch of models that you can select from. So I have my models here, and these are the models that we've been using for our projects.
Hello, everyone. Yes, so we're getting started with the next section very soon. We have the exhibition showcase where we're gonna hear from open source projects and community, open source communities in Asia. The workshop, the robotics workshop is still going on in the workshop room. They are finishing in a few minutes. In the meantime, I would like to get us ready for the exhibition show. Yes, so a few things. Just a quick reminder, when the session starts, please mute yourself. A few things that I want to share with you, self-service. If there is a video playing, you can actually play it yourself on your own device, and you can also control the slide and the presentation. We use the public chat for informal conversation and the share notes for questions. We also have a discussion room where you can speak to the speakers at the end. Okay, so let's see, we are 2 minutes away. May I ask if Deb, are you here? Deb, if you are around, please turn on your camera and activate your audio.
Okay, can you hear me?
Yes, I can hear you,
Okay.
but I cannot see you yet.
So I have access to, here, I've set up my webcam really quick. There I am. Can you, oh, no, you can't see me yet. There we go. Hello.
Hello, Deb, great, we can see you.
Okay.
I'm very glad to have you here.
Thank you. Well, it's nice to be here. Will I be able to share slides?
Yes, you will be able to share a slide. Let me give you the presentation. Right. I can hear you well, see you well, and yeah, so we can start. No, you can upload your slide, or you can share the screen. I give you the option already.
Okay, I'll go ahead and share the screen.
Yeah, so in the meantime, I will do a quick introduction. So everyone, we're now starting with the exhibition show. The FreeBSD Foundation has been a supporter of the FOSSASIA for many years, and we are very glad to have Deb Goldkin here as the Executive Director of the FreeBSD Foundation. They're having a virtual booth as well with a lot more information that you can check it out later on. So Deb actually been with the FreeBSD Foundation for a while already. She joined as the first employee back in August 2005. And before she get into the world of open source and operating systems, she spent 2 decades working as an embedded firmware engineer, technical marketer, and technical sales engineer in data storage industry. This is I also did not know that you was a firmware engineer. That later on we're gonna have a firmware talk here. Besides running the foundation, Deb also dedicates time learning more about operating system while advocating for giving presentations on FreeBSD at open source conferences, university, and in women in computing events around the world. We are very excited to have you here. I'm gonna give the stage to you, and are you able to set your screen ready, Deb? I still haven't seen the slide from you.
Oh, should I? Here, let me go ahead and do this. And so I have 5 minutes. Is that what?
Yes.
Okay. So go until 7 after. So can you see my slide okay?
Yes, we can see your slide.
Okay, I'm going to set a timer here. So I'll go ahead and get started. Thank you for the introduction. I'm Deb Goodkin, and I am the Executive Director of the FreeBSD Foundation. And I have 5 minutes to give you an update of what's going on. And really what I'm going to do here is tell you a little bit about the foundation, but mostly about FreeBSD, and encourage you to come to our table that we have here. Our hours were not posted on our the web page here, and so we just want to make sure that you know the hours that people will be there, because it is pretty limited, and hopefully maybe someone from the organizing committee can add these hours to our web page, because we were just there, and so we're hoping to get more people at our table, well, virtual table. So anyway, so the FreeBSD Foundation is the separate nonprofit that actually supports the FreeBSD project. And we are a 501c3. We're based in the US, actually in Boulder, Colorado, where we have a major snowstorm going on right now. We've been around for 20 years, and our whole purpose is to support the project. And so what is FreeBSD? FreeBSD is a free and open source computer operating system. It's a Unix-like operating system, and it descended from Berkeley Unix, which descended from the original Unix. And one thing about this operating system, it is a complete operating system. So it includes the kernel, userland, documentation, and so on. And I think I'm going to go ahead and skip this. But this is sort of a high-level view of where FreeBSD came from. A lot of companies actually use FreeBSD. This is a list of companies that you may recognize, but there's a lot of companies out there that we don't even know of that use FreeBSD. This is free, and most likely use FreeBSD. And I mean, if you have an iPhone, iOS is based on FreeBSD. Netflix is all streaming on FreeBSD systems. And the new Sony PlayStation 5 is also based on FreeBSD. So why use FreeBSD? It's a friendly and approachable community. Documentation is excellent. A big reason why a lot of companies use FreeBSD is because of the BSD license. And so it's a permissive license, and it doesn't restrict what you can do with the code. And so I'm just going to keep rushing through this because like time just is flying by. But I want to talk about how you can contribute to FreeBSD. This is a list of many different ways you can do it. If you're not a coder, even if you are a coder, writing documentation is a great way to get started, and because it just really helps you understand what's going on. And so I will upload these slides, and so you should be able to get them on our site, or maybe under this talk. And some of the big reasons to contribute to FreeBSD really is we're a small project, but we've been around for a long time. And so first we have this mentoring culture, and so it's a great way to learn and be brought on board by more experienced people. But Also, if you want to learn systems programming, because of the code base is smaller than other operating systems out there, it is a great way to actually be able to look at the source code and learn about operating systems, as well as learning or working on systems programming. And you know, and because it's a small project, you also can make a more notable you know, difference, and there's aren't as many people working on it. And we do have some of the original BSD and FreeBSD founders within the project, and they're very approachable, which is awesome. We have exciting things that are coming out at the end of this month in our new 13.0 release, but I don't have time to go over them here. But what's really important is just really, if you're interested in learning about FreeBSD or getting involved, is to, I have this list of resources that you can just find out. You can ask questions on mailing lists. You can learn how to contribute to FreeBSD by going to this URL. The handbook is excellent for learning about FreeBSD, the history. And on the foundation site, we do have a resources page too, where we have how-to guides and videos and all sorts of information to help you get involved. But what I would ask is to come to our table during the hours that people will be there, and we can talk to you more about just answering your questions about FreeBSD, or just helping convince you to contribute to the project. And my 5 minutes is up, and so I will go ahead and stop sharing my screen.
Thank you, Deb. So I just updated the office hours in your booth, in your virtual booth. Before before we going to invite the next exhibitor, the Ubuntu community in South Korea, I want to show the audience quickly how they can get to your booth. We have a video yesterday, but I want to share my screen and see how people can get there. Please stay on live for a moment. I will just share my screen. Okay. So I'm now in the main hall. If you look on the left-hand side, you will see the side panel. From this side panel, you can get to the exhibition page. Click on the exhibition tab, and then it will bring you to this page. So on this page, so let's say if you want to look for FreeBSD, look for that. You can choose FreeBSD Foundation, and here you get more information about FreeBSD, and there is the video option, join exhibitor video, where you can talk to Deb and her team members about FreeBSD. So this is how you get to the exhibition page, and from there you can easily go back to the main home. Yeah. Okay. Yeah. So I hope that you get the impression where you can find yourself around. And one thing that would be nice to share, you can move back and forth from the exhibition, go next to the next exhibitor, and then or you go backward, and you will find it. So if you have any question, I think the time is updated on the website. They will be around until, is it the time? Which they will be around here. If you have any question, please go there.
Well, we'll actually be there Monday through Thursday, those times. Maybe
okay, so could you put it in the chat so the team can update for you?
I will do that. Thank you.
Thank you, Deb.
Okay, well, thanks.
Okay, so next stop, I would like to invite Ubuntu community from South Korea. Gan Yung, are you gonna present, or somebody else from Ubuntu Korea? If you are here, please turn on your camera and activate your audio. Hi, can you hear me? Gan Yung? So after South Korea Ubuntu community, we have FOSS community from the Philippines, Mozilla Philippines. I don't. So if Bob, are you around? Great. So perhaps Bob, would you like to start first while Gun Yong getting himself ready?
Hi,
Okay.
good afternoon.
Hi,
Can you hear
great.
me?
Yes, I can hear you. So wonderful. So Gun Yong, we will come back to you after Mozilla Philippines. We are happy Bob here. He's also a speaker. When is your talk, Bob?
Okay, so my talk will be on Thursday, March 18 at 6 p.m. So I'll be talking about get the web back on track. So it will be exciting.
Okay, wonderful. So yes, so just a quick introduction about Bob. He is the Mozilla Reps mentor and also the tech speaker for Mozilla. He's been to the FOSSASIA Summit many times, and we've been working very closely together on UNESCO Techco project as well. So Bob, would you like to share something, Bob, or you just gonna speak?
Okay, I'll just pick, just not to take much time. Okay, thank you for having us here. My name is Bob Reyes. I'm from the Mozilla Philippines community, and we are also at the forefront of promoting openness and open source in the Philippines. So for our community, we are more into localizing Mozilla products and helping organizations build their open source and open tech communities. And as much as you know, the Philippines is an archipelago. So right now, we are basically mostly online, but it's also another challenge. The Philippines has been struggling when it comes to internet connectivity for the past few decades. And part of that commitment to our community is that we are going to organize a series of talks, workshops, and maybe it's still in the pipeline, an open source conference later this year. The last open source conference happened in the country quite long time ago, more than a decade ago. So we invite everyone from the community of FOSS Asia, not just those who are in the Philippines, to join us. If you are willing to give talks, share technology insights, and mentor students, we are more than willing to accommodate you. So our touch points would be our website, mozillaphilippines.org. The email is info@mozillaphilippines.org. We are on social media as Mozilla PH, or you can get in touch with me directly. Everywhere you see Bob Reyes, that would be me there. Thank you.
Excellent. Thank you, Bob. That was very quick but very informative. Perhaps you can also put the links that you just mentioned to the chat so people
Yes,
can
I
follow.
will. Thank
Thank
you.
you
I
very
will.
much.
And for the booth, we'll have someone at the booth every day starting today from 3 p.m. to 5 p.m. daily.
Perfect. Thank you. So once again, if you want to visit Mozilla Philippines, go to the exhibition hall and navigate yourself to Mozilla Philippines. Okay, it seems that Gan Yung is ready now. Gan Yung, would you like to turn on your camera?
Okay.
Okay, perfect. So I can also hear you. Okay, excellent. So this is the first time we have a community from South Korea joining us, and Run Yung is. You did not put in the bio, but I can say, are you a member or a chair of Ubuntu community South Korea? I'll let you introduce yourself so people can get to know you better.
Okay.
Okay, the floor is yours.
Before I start, can I use the screen sharing feature?
Yes,
Is
one
possible?
second. Okay, here you can share your screen.
I will just upload가 아니라.
Okay, while we are waiting for Gun Yong, I would like to ask our exhibitors if you have not submit your availabilities for the booth, the office hour, please write to the organizer or put on the chat so we can help you to update your office hours.
Could you give me the permission one more time?
Okay, it's here. Is it working for you?
Okay, got it. Okay, so hello everyone. I'm from Ubuntu Korea community, and I'm here to introduce you about our community and what we do as our community activity. Briefly summarizing our community, the Ubuntu Korea community is a verified local community team and verified by the Ubuntu Community Council. And our main goal is to help the Ubuntu and Linux users in the South Korea. It includes the technical stuff and the localization stuff and the language. And we have the translation team, so we continue to contribute to the localization of the Ubuntu project. Okay, yes, so I'm gonna introduce our main activities. Due to the COVID virus, last year we only held an online seminar with the YouTube Live, along with the other communities in the South Korea area, includes the OpenStack, Azure, and stuff. Okay. Before COVID, we also held collaboration seminars with the IT community in South Korea. It includes the Linux, DevOps, cloud, languages, and everything. So basically, Ubuntu Korea community in the South Korea not only focuses on the Ubuntu, but everything about the IT related stuff. And we also have the project driven by the community. It's called the HanJP. It's typing Japanese characters with the Korean letters. So it can be very useful for the Korean and the Japanese users who use the Ubuntu and the Ubuntu-based Linux distributions. You can check this in the GitHub repository of our community. And it's as for last, we had the contribution workshops. We called it the contribution. It's basically we have the 90 days to contribute to a specific project, and there's a mentor and a mentee. Mentors teach the mentees to how to contribute the project. And our project was basically about the Ubuntu's localization. You can simply call it the translation. So for 90 days, we contributed to the upstream Ubuntu with like thousands of the translations, and it was good, I guess, thing to do as a contribution to the open source. For 2021, we are planning the Ubuntu Conference Asia 2021. Basically, the people from all the world and Asia gather, and we will talk about the Ubuntu and Linux. We are planning it as a virtual conference, and it's gonna be held in September 21st. And you can check more about it in the Ubuntu Wiki in the presentation URL. Okay, that's all for now, and thank you very much.
Thank you, Ganjung. Yeah, I'm really glad to have someone from South Korea here, and I hope we stay connected. It's great to see what you are doing in South Korea. The call for speaker of the OpenCon Asia actually on event Yay, so people can go there and check it out. Thank you. Once again, if you want to learn more about community in South Korea, please visit their booth. You can find them on the exhibition page. Thank you. Okay, so I would like to invite the next exhibitor. Do we have Troy Leo from Building Blocks?
Hello, hi. I'm actually the one who's going to be sharing.
Rayan, are you gonna talk on behalf of Building Blocks?
Yes.
Ray, do you want to turn on your camera?
Yeah. Okay. Wait. Hold on. Can I have the screen share feature?
Yes. Let
All
me
right, thank you.
give you the. Okay. So, you got the right, Rayan.
Okay. Is it upload the presentation of this?
Yeah, okay. So please go ahead while I introduce you. So Rayan actually come from the Building Blocks community, a group of young student, computer science students who get together, learn about free software. They do a lot of workshop, participate in events. They've been engaged with the FOSSASIA Summit for several years, not only as offering training to young developers. Also, they conduct a number of workshops here on site at the Lifelong Learning Institute, and Rayan was several years also supporting the FOSSASIA Summit. I saw that you are ready, right?
Yep.
Okay, please go ahead.
All right. Okay. So good afternoon, everyone. I'm Ray Young. I am a Year 5 or Grade 11 student from Diamond High School, and today I'll be sharing on behalf of Building Blocks. So Building Blocks is Singapore's annual computing education outreach program, and it's organized by students for students. So a little bit about our history. Building Blocks started in 2017 as a ground-up initiative. This is by A-level computing students and integrated program computing students. We organize this. We organize computing-related activities for O-level computing students when the O-level computing syllabus first launched in 2017. So actually pictured here, this is the our first ever Building Blocks conference. This was at Nanyang Poly, and this was quite small back then. So in 2019, we actually held our biggest yet in-person event. This was at the School of Computing, NUS School of Computing. We had about more than 20 different schools with about 200 over students participating in this event. And about half of these were A-level computing students, where about another half were like O-level computing students. And this was truly a great milestone for us, holding such a big event. Then, of course, in 2020, COVID-19 came and the pandemic hit, and we pivoted online for our conference. We held Building Blocks in June with over about 100 over students participating, which was honestly quite difficult for us because shifting directly from in-person to online was kind of a big change for us. Yeah. So over the past 5 years, we actually gained a lot of valuable partners. All right, so in the industry, such as Google, AI Singapore, MOE, NUS, and of course FOSSASIA, right? As Wong Fook mentioned, just to name a few. So this is just a bit of our history. All right, so let me share with you a bit about what we are doing this year at Building Blocks 2021. So this year, our theme is computational thinking and AI education. All right, and hopefully, when we are holding this in June, and hopefully, by then we are looking at something like a hybrid approach, kind of something like what's happening with FOSSASIA right now. Some people on site and some people online, some of it online. So for Building Blocks 2021, we are actually partnering with CTE STEM, all right, and we are assuming the role of their student branch, their student forum actually, which targets the student population, because actually CTE STEM is a forum that targets teachers, and the aim of this is that we want to bring across like combinational thinking concepts and how it can be brought into the daily lives of students, right? This year we are also hosting our a national Code Combat tournament. Code Combat is an online gamified platform that teaches programming, and the winners of this Code Combat tournament will be officially nominated to compete in the global tournament in August. And in the bid to spark interest in computing for students who want to take up computing as a subject, we also conduct a series of workshops covering all sorts of topics, from things like computational thinking, competitive programming, artificial intelligence, as game development, as well as introductory, beginner-friendly workshops such as introduction to Python and web development. So who can register? And so who can register, right? So we are calling for actually anyone who's interested in computing, students alike, to you guys are able to sign up. Just go to our website, buildingblocks.github.io. I believe Joel will help me send this into the chat sometime soon. All right. Our target audience mainly is pre-uni students, actually, but we actually welcome all students of all ages to come and take part in our adventure. We will also welcome any representatives from organizations or anyone in the public in the IT sector who want to share and connect with the computing youth of Singapore. So if you'd like to give a talk on behalf of your organization, we will also like you to if you're interested to, we will also like you to sign up. We are looking for presenters and facilitators for workshops, lightning talks, keynote speeches for main conference in June, as well as preceding pre-events. For more roles and responsibilities, if you want to read up more, we have a tiny URL here for you to take a look at. And for organizers, you can take a look at the sign up form at tinyurl.com/VBCS21 organizer apply. So if you're interested to help an organizer, you can. We basically have 3 events. The main event in June, all right, and also the aforementioned Code Combat tournament, as well as some ad hoc mini events and pre-conference events, to kind of hype up the main June conference. Yeah. So I think that's all from me. Thank you very much. For more, if you have any inquiries, you can feel free to email hello@buildingblocks.sg. And you can also visit our website at buildingblocks.github.io. Thank you very much.
Okay, great. Thank you. So I'm glad to see so many activities going on. Please visit Building Blocks virtual booth. You can find it on the website or look at the side panel. It will bring you directly to our exhibition page. Thank you. Okay, so up next we have Seth Chinoy from the Classroom Misinformation Edition. If you are here, Seth.
Yep.
Perfect.
Yeah.
Are you gonna share a video, right, Seth?
Yeah, I'd like to share my screen since it's an exhibition and it's entirely web-based, so it'll be nice.
So I give you the presenter, right? You can get yourself ready.
All right.
So just a quick introduction about Seth. I assume that many people here already know you. So Seth is a professional geek with a passion for coffee, technology, and open source approach to do things. Yes, and he is the chief geek at Sputnik Lab. So where is that
Sputnik Lab.
lab?
Singapore.
Maybe
Yes.
you want to tell a little bit about the lab before you start.
Sure. Sputnik Lab is it's a sort of a portmanteau of a Spud and Sputnik. And what we work on, and we're based in Singapore, a small little company. We're working on like frugal innovation, low cost ways to get connected to the internet and bridge the digital divide. But you know, that's the boring day job.
And where are you at the moment? Are you in the hackerspace or somewhere?
No, I'm actually at Engineering Good. It's a little makerspace that focuses on assistive technology. I volunteer here on weekends.
Wow, very nice background. So just a quick question to the audience. Can you all hear Sad? Because the audio seems a little bit low for me. I want to check. Yes, so it seems that everyone can hear you.
Yes, we can hear.
Okay, perfect. Then I leave the stage to you.
All right, thank you. I must say, you know, it's really weird being online with an exhibition, but this is, I think, a unique opportunity to bring people into what we do and what we like to talk about from places that would otherwise not be able to travel long distances. So it's really nice, and I want to appreciate the efforts of FOSSASIA to, you know, make this happen in spite of all the challenges. Which actually brings me to the thing that I wanted to share. I should disclaimer this: I'm not part of Tactical Tech. I just attended their exhibition, and I was blown away with what they were presenting, and I thought that it would be perfect to share with as many like-minded individuals as possible. And I think the people who are speakers at FOSSASIA will resonate with some of the artifacts and infographics and posters and things that are being presented as part of the Glassroom exhibition. So it's not, I'm not actually, you know, promoting anything. I just would like to share the exhibition experience with you. And since it's all online and people are connecting in from various places, I mean, the previous presentation was from South Korea, which is really nice to hear, that there is a Ubuntu community there that is able to share and willing to share. So it's really nice to have that visibility. So I'd like to just, you know, show you the, walk you through this exhibition. There's nothing that you have to really pay attention to. The link I will share on the chat, and you can take a look at it at your own leisure. You can, you know, not walk around, click around the page, and the different elements will, I mean, you take your own time to sort of experience these bits and pieces that are being presented. So I strongly recommend setting aside a little bit of time without distractions, because, you know, the advantage of being in a physical space is that you can go inside a room and you don't have lots of things shouting at you all the time, or pop-up windows and WhatsApp messages and like YouTube playing in the background, none of that. So it's difficult to do that with a virtual exhibition. So my request is, when you later on, after I'm done talking, do take some time out and just click through all of the different things that are being displayed on the screen. And it doesn't look like much, and there is not much, but if you think about how you feel about each of the things that you're seeing and why you're responding that way, I think you're along the right lines. There's no right or wrong answer here. So I'll walk you through the different artifacts that are being displayed, and then later on, you can take your time and just look around. So the way it's being presented right now is just as a single web page, and each one of these red highlights is a clickable sort of a hotspot, and it just like an overview, sort of a closer look at what's being displayed on the wall. So to start with, this is an exhibition that has made its way around the world. Started off in a large scale in major museums and art galleries around all the big names, London, New York, Paris, all of those things. But the misinformation edition, the one that I'm talking about today, is sort of like a small, easily shared, easily online experienced version of it. And it's put together by Tactical Tech, which is an art collective. It's a collective of artists that work with data and present it in a way that is compelling and gets you to ask questions about our personal data, how we visualize or don't visualize our association with big data technology, devices, companies that have models and systems that rely on data. So it's beautiful work, and there's a lot that's being presented in very small packages. So later on, I invite you to take a look at this at your own time. So what's being presented here is specific to smartphone technologies and videos, and how we are experiencing this sort of relevant to how we are now using our devices on a day-to-day basis. So it's really interesting to look at all of these things, but I don't have much time, so I'd like to focus in on this one aspect here. These things on the tables are interactive. They would normally be like a little tablet type thing where you can click on questions and answers and you would get a result. So I'm just going to click in on the Deepfake Lab, which I think is like really compelling. It sort of walks you through the various aspects of video, which we're now sort of really dependent on, and we get most of our news and information from, and they get rapidly shared through WhatsApp messaging and things like that. And it's important to be aware that they are subject to manipulation. A lot of people tend to use this to their own advantage. I mean, a meme like this, for example, where you have a baby whose face has been replaced by some famous person. It's obvious that it is a joke, but in cases where it's being used to suggest that something happened when it didn't, it misleads people in ways that they don't normally expect. So I think being aware of these sort of technologies and techniques and drawing visibility into how and why these things are possible and doable makes us more prepared and more informed as an audience to be able to tell when something is fake or not. Because there's no real other way to do this apart from being aware and informing yourself about what things are and what to look for.
Are you an angel?
So take a look at the Deepfake Lab thing. If I could, I'm going to try and just play a short 30-second video, which I think drives the point home very quickly. Let me share that over here. Oop.
Hello, welcome to our website. My name is Arthur, and we are going to have a look at deepfakes. Deepfakes are artificial intelligent computer models that are able to recognize facial features to be able to either replace faces, or be able to manipulate them.
Seth, please unmute yourself. I
Sorry,
muted
yes.
you because there was an echo.
A feedback loop. Yes, thank you. I got it. All right. I don't want to take up too much time here. I let you go in and play by yourself. The other aspects that are on display are interactive elements. One of them is this the double check thing, which basically gives you these little question and answers where you can choose whether something that's being presented to you is misleading or not, which is a fun game to play, and I recommend you play it yourself and try it with other people. It's a lot of fun. Then there's fake or real, which is again similar. It presents you with a thing, and you have to decide whether it's fake or real. And it tells, and it basically gives you a score at the end to say how many you got right and how many you were misled by. And the more jaded and experienced of us who think that we know better in technology are also quite surprised when they're presented with things that are quite close. And we don't usually see what's being presented to other people. And that lack of visibility comes as surprising, because when we talk to people and they say, look, I was taken in by a scam, you're wondering how that happened, because you are already prepared on how to do it. And so not being able to see what other people see really does help understand how this manipulation takes place. So that exchange of information really makes a huge difference. There is a slightly more complex tool that is also available as part of the exhibition towards the end, which is, let me see here, all right, right at the end here, a drop in the ocean. So this one gives you sort of a simulation of how politically targeted ads figure out what your personality is, just based on asking you a series of what seems like harmless questions. And so you can look at some of these questions here in this interactive page, and based on the answers that you give, you will see a result that is narrowing you down based on your preferences or choices. And so it sort of interprets these things, and then once you answer enough questions, you'll get a sample of an ad that is a real ad that was displayed to somebody. And so you can play around with the demographics here and see what that looks like. I thought that was really informative as well. So that's pretty much it. There's a lot of content in here. Take your time, set aside a little bit of headspace, and then carefully think about how you're feeling. And it's okay to make mistakes, and it's okay to experience this. And it's also okay to share it with other people. So you can just share the URL, other people can click through and experience this in their own way. So last thing I want to mention is that, we introduced the Glassroom exhibition last year at FOSSASIA, when the lockdown measures, the circuit breaker measures were just being introduced. So ideally, this would happen in a physical space. I'm hoping that maybe next year we'll be able to go back to doing that, where you can interact not only with the exhibits, but also each other and exchange ideas over something that's being presented. So with that, I'm pretty much done. I'm going to hand it back to Hong Phuc.
Thank you, Seth. Yes, I hope that we can be back to Singapore next year as well. And thank you very much. So you've been with us for a couple of years already. Every time you come in, you share something new, and it's always interesting to hear from you. I can see that people talk about it on the chat already. Thank you again, Seth. So if you want to find more information, please visit the booth. So what is the name of the booth? The Glassroom, right?
Yeah, it's the Glassroom.
The misinformation edition. Yeah, so check them out on the exhibition page. Thank you.
Thank you.
Sammy, do I have Sammy here? Sammy, if you're here, please turn on your camera. I also give you now the presenter, right?
Yeah.
You can also upload your slides, Sammy. While Sammy is getting started, I will just do a quick introduction. So Sammy Phong, also a very regular face at FOSSASIA. He is the founder of Open Source Hong Kong. When did you start Open Source Hong Kong? Which year?
2008.
2008? Yes, very long time ago. And he also lead. Sammy, let's do a quick check on the audio. It seems that the sound a little bit breaking. Could you say a few words so I can see if we can hear you?
Oh, hello, testing. Testing. Okay, testing.
I just feel a little bit breaking for me. I'm checking with the audience to see if they can hear you.
Hello.
On and off, choppy. That's what they said. Sammy, can we do something about it?
Okay. Maybe I try to switch off my video. Yeah. So how about now? Yeah.
Okay, so I think it's a little bit better. Yes, Sammy. So let's hear from you.
Okay. Hi, everyone. I am Sammy from Open Source Hong Kong. I'm president. I'm of this committee. So we are aiming to share and learn open source technology and also other open technology, other open technology as well. And we are always recommend peers to contribute and collaborate in the different open source projects. Therefore, we are building a community in 2008. Name the community the open source because we own a main open source chain. So last month, the business insider interviews about has become one of the fastest growing hub for open source software according to the GitHub report last year. So I found that over 11,000 GitHub users from Hong Kong last month. And so our Facebook page have over 2,100 likes as well. So in our community, let me check about that. Okay, I will try to help. Yeah. So in our community, so we have we have open source developers. We also have some marketing professionals who help us to do some marketing as well. Initially, to help us do graphic, and we have some admission option helper as well.
Sammy, it seems that the audio still doesn't getting better. Do you have a headphone or something? So they have a little bit difficult hearing you. Are you using Firefox or Google or Chrome?
Based is something. So I would like to test this. Yeah.
Sammy, we cannot hear you anymore. Would you like to test again first, and then we come back to you in a moment when the audio is better? Okay, so Sammy, what I would suggest is.
Hello.
Yeah.
Because I have another half slide, so I go try to quick first. Yeah.
Okay.
Yeah. So okay. So what brings to open source communities in Hong Kong? We collect Genome and Mozilla and Python and other overseas open source contributors. And also we have some of our members working on local projects to like respond with with the education department standard. And also have we do some of my members do
for the local citizens as well. And most of the business and opportunity to the open source company in Hong Kong. So we work with some sponsors to our conference events, and we contribute back to open source community well, Zilla, Python, and obviously open source project conference.
So thank you, Sammy. So it's good that we have the slide as lead. People can. Sammy, could you please mute yourself? I think there's a lot of background noise coming from you.
Okay. You like contact us, so you can for us give her Facebook link Twitter as well.
Yes. So okay. So this is so below you see the Twitter handle of Sammy and also information to get to Open Source Hong Kong. There at the exhibition, you can find more information there. Sammy, unfortunately that the audio wasn't good enough. Perhaps that you could record the 5 minutes introduction so we can share it at the end of the event. That would be good also to promote Open Source Hong Kong. So I would suggest that you can send us a record later on for this 5 minutes presentation. Thank you very much. Yeah. Okay, Andrew, thank you for the motivation. Yes, so it was good that we have the slides so we all can follow the slides. Very nice. Okay, so moving on, I would like to invite Li Qi from Open Vista, China. Li Qi, are you here? Li Qi, if you are here, please turn on your camera and your audio. Perfect. Li Qi, are you gonna share a slide, or are you sharing a slide, Li Qi? Li Qi, perhaps I think that you cannot hear me, right? I did not see your audio activated. I think that you need to click on the headphone icon and give the browser the right access. It's not. It still show that it show that you don't have. Eden, perhaps you could type something on the chat. He probably cannot hear me. So the team, if you're there, please have to Li Qi to configure. So why I'm calling up the next exhibitor. Okay, so do I have Alex? Alex, are you here? Okay, so I think that you get that. I think a moment. So okay, so yeah, so we get Alex start first, and then Li Qi will come back after you, as we also running out of time. So Alex, welcome. This is about Wiki TCMS, and Alex is the project lead of the project. So I leave it to you.
Okay, thank you. Hello, everyone. Nice to see you virtually. I am hoping that you can hear me without too much issues, because I am having issues on my side. Please write in the chat if this is the case. So I'm not going to share slides. I want to tell you the history behind KVT-CMS, how it came to be, and what it stands for, what's happening in the project, and we can talk later in the exhibition booth if you are interested. So that is a very old project. The first version was released in early 2009, early February 2009. So we celebrate our birthday usually around the time of FOSS. That's much closer to us. We are not the original team behind the project, so we are a fork. As a matter of fact, it's the third fork that came to be KVT-CMS later down the line. So project was developed a specialized system that is used for testers to model their test strategies, to record results from either from manual or from automated test execution. And later you can see in the system what has been tested. For the first 5 years of the life of the original project, it has been developed internally. It is published under GPL, but the source code was never made available on GitHub. And then in late 2014, everything was pushed together in one big commit. So I came in a little bit after that, working for a customer. We wanted to use a similar type of system, and naturally we took what was available from GitHub, started using it, started modifying it a little bit. And over time, I just remained working on this project more and more every single day. And the upstream developers that were left at the time, they were very unresponsive. Up until a couple of years ago, I still had pull requests which haven't been merged. Nobody was replying to my pull requests. Nobody was giving me any kind of feedback that's actionable, so we can move forward in a better direction. I moved away from my customer a long time ago, forked a few times down the road, and at one point, in the summer of 2017, I received an advice to start turning this personal project into an organization, something that has its own life. And this is how KVT-CMS was born. So from that point onwards, we have a new website, we have a new name, we have new GitHub organization, and the project is taking life on its own. At the same time, we're building both the community of developers, the core team that works on the project, people who contribute from time to time, people who maintain the documentation, people who maintain translations into different languages, more than 20 different languages, and also community of users. So we started pushing Docker images, we started hosting public demo website for the system, and then everything exploded afterwards by itself. Up to now, we have a lot of people contributing. We are running a bug bounty program. If you're interested in hacking open source, we have more than 400,000 downloads from Docker Hub. And the funny thing is, most of them have happened in the last 3 months. So it took us 3 years to reach to 100,000, and then almost every single month is 100,000 more, and that's just amazing. I'm very happy with how the community is growing. We have a lot of new people coming to contribute. Last year, our own project. That's been turning into a very good relationship. We go to different open source conference, having fun. And last year was the first year that we wanted to visit FOSSASIA. We had our tickets, we had bought our merchandise to give away to all the attendants, but unfortunately our travel plans changed. We couldn't come. So this is about the project. if you're into testing, we work with several different open source projects, and we have a lot more down the line, which we're having negotiations. We're trying to help them organize their testing with our help and with the software that we develop. Unfortunately, I cannot give you the names at the moment because nothing is public yet. Hopefully very, very soon. The sad news just from a couple of days ago is we applied to Google Summer of Code program, but we were not accepted, unfortunately. But all the tasks are still open for anyone that wishes to contribute to and to build up their profile in open source. So I think, yeah, this is it from me. We are available
Thank you, Alex.
all weekends.
Yeah, thank you, Alex. So we also a little bit behind, but excellent. Thank you very much, Alex. So you will be around. I saw that you already put up the time you are available on your virtual booth. Thank you very much for that. And please, if you want to find out more about Kiwi TCMS, please visit the booth. Click on the exhibition page. Thank you very much.
Thank you. Bye.
Thank you. Okay, so next, I think I would like to ask the panelists for the firmware panel. If you are here, please turn on your camera and activate your audio. So the moderator for this panel is Mario Belling, and I would let him introduce the panelists. But I So yes, so Mario will be ready in a moment. There is some technical issue, but no problem. I will just go ahead and introduce the panelists here on behalf of Mario. Yeah, I know most of them already, but we have excellent people here in this session. So the session is what next in open source firmware and open hardware. We have here Ron Minish is the original author of Coreboot. He has been writing firmware for over 40 years, and he is a long-time contributor to Unix, BSD, Plan 9, and the Linux community. We are very happy to have Ron here with us today. So next, I have Jean-Marie Verdun. He is the Senior Strategic Open Platform at HP Enterprise. He spent a lot of time designing working on computer, but designing them on a hardware level. Participated in many crazy projects. He will share with us more later. And he also involved in building up the biggest European supercomputer back in the 90s. He loved to share his knowledge and enable people to design better computers. He focused on open technology recently with tools like FreeCAD, KitKat, and open firmware projects like Linux Boot or the Open BMC. Yeah, and of course we have Daniel Malowski here, software engineer. He is a contributor of Pocket Science Lab, but beside that he worked on many open source hardware projects. He's giving a talk here at the summit later today as well. And Bunny Huang. So right after this panel, actually Bunny Huang gonna give a keynote. He is like a well-known hacker to our community. The best known of his work probably the Microsoft Xbox, but he will talk about another project today in his keynote. Yeah, so I'm very glad to have everyone here. Thank you for joining us. And there, Mario is back. Sorry, we had some technical issue.
Uh-oh. No, we've lost all of them. We're disappearing. We're disappearing one by one. Who's next? Internet.
We'll see.
Let's see.
Okay, so okay, now I got it. Excellent.
Mario, I think we can hear you now.
We can hear you.
Awesome. So thank you very much for joining, everyone. Yeah, it's great to see you guys.
Good to see you.
Good to see you.
So,
good morning, evening, and afternoon.
Yeah.
Exactly, that's what I wanted to say. So we're covering the entire world now. Expanding a bit, and thank you very much, Hong Fook, for introducing our panel. And basically, this panel is a follow-up also on a panel that we had a few months ago at State of the Source, but the questions always remain the same. And I would like to invite you guys at first to share a bit like what is the current state of open source firmware and open hardware then from your perspective. And as we hadn't heard like at our last panel from Bunny, I would like to have like an opening statement of Bunny. Bunny, like, how are things developing with open source firmware and hardware? Do you feel things are opening up entirely, or is it maybe different?
Well, I mean, there's a constant tension of a lot of players in the market and a lot of motivations, right? So I think the open source technology continues to make really strong strides, and I think there are people who are listening to our message and taking it seriously, and then there's people who I think have a motivation to keep it closed, right? But I think overall the general state of things is pretty good. I'm seeing a lot of progress on a lot of fronts. I'm more on the hardware side, so I've been pretty pleased with the sort of incredible momentum that's developing on open source silicon, actually. So people are now actually battling down and getting the actual transistor level stuff opened up on chips, and the physical design kits are getting opened up, and people are really excited in that area. So I'm looking forward to seeing a lot of action along that front, which is sort of the final frontier, on the hardware side of things. We always argue about what's inside of our SoCs, and we can't see what's on the inside, and hopefully that problem will get solved in the next decade or so.
So I think there's some controversial statement maybe behind that, but because things are opening up, but I think we will talk a little bit later, how are they opening up and who are maybe the actors in this activity. And so then thank you very much. And I would like then go to Jean-Marie Verdun. Jean-Marie, so you also had some news in the last few months where you also had some experience. Would you like to share what has been happening on your side?
Yeah, since we spoke last time, so we made some tremendous progress at supporting open source firmware on ProLiant family. So, which is the HP x86 server line. So we started to ship servers to customers with open source firmware capabilities, running OpenBMC and Linux boot. So which means that we are getting closer and closer to support open source firmware. We are doing that currently on private offering, but our intent is to expand as much as we can this product portfolio. And we do support systems running Intel chips and AMD chips, so which was also critical to us. And we open up an integrated continuous integration platform, which is an online tool that anybody around the world can use to validate open source firmware on ProLiant. We faced a couple of challenges that we try to address on a daily basis, and that's also why this is not available on a worldwide basis. So we need to readapt our support process and enhance the hardware just to be able to switch back and forward between proprietary firmware and open source firmware. So we do not want to have a black and white world where a customer is locked with open source firmware or locked with proprietary firmware. We just want to be able to offer the widest choice. And this is where it is becoming tricky, and the path to success might be taking, let's say, a couple of months or a couple of years, additional years of work, just to be sure that everything is set up properly. But we're quite happy about what happened, despite the pandemic, which slowed down a lot of our effort during the past few months.
And Jean-Marie, because you're also like talking from the perspective of we, right? But so you have been active on different fronts, let's say. So when you're talking about we, like which groups do you, for example, feel you can represent, and like how do the different perspectives?
Right now, when I'm saying we, this is mostly the HPE engineering team. So, and the people who are designing open source firmware at HPE, but also the open source communities from OpenBMC. So we officially committed code to the OpenBMC stream to support the HPE GXP ASIC. So HPE is still designing its own BMC chip, and with the security stack associated to it, and we upstream that. It's now officially available into the public GitHub repo from OpenBMC. We do have also introduced some support for the DL360 within the Linux boot repo. We still have a lot of work ahead, but I'm pretty happy about the shift that we are currently operating regarding this. We are still facing, as HPE, some challenges around the support of PCI Express devices. So as you might be aware, that there is firmware everywhere now. And most of the communities are focused around the BMC and the system BIOS. But what about the NIC drivers and the NIC firmwares, or the storage controllers and all these kind of devices which are running proprietary firmware, which are getting more and more complex? And I must admit, in some cases, or not, yeah, they are pretty buggy. So, it's pretty tough just to try to fix them. And we still need to rely on our suppliers just to be able to fix that.
Okay, wow, quite a lot of news, quite a lot of details, and so I understand you're also working a lot from the industry side. And yeah, before I come to Ron, then I would like to ask Daniel. So Daniel, we see like a lot of progress has been going on the industry side, but you are also more on the, like, let's say, the developer side, engaging with like different people also in the community a lot. So what is your impression?
Yes, I have, I would say, quite diverse view on things. So I'm not just involved in communities, but I'm also tracking lots of different communities. And one of them is at-large researchers. So you might have seen during the last years now in the news. There was every now and then something like data breaches. There was progress in attacking hardware on different layers and different ways, right? So basically when people discovered, hey, your RAM that's clocked at 2.4 gigahertz now, that's also true for Wi-Fi. So can we do something to transmit data over that? That's one thing I'm looking at. And on the other hand, we have such a huge market, especially for consumers, which is a very heterogeneous market. So that's both very, very hard for vendors, right? They would need to support lots of different devices, which is really kind of the toughest job you can do. And on the other hand, for consumers, it's very, very hard to navigate through that market and, you know, understand what you can buy. So if you want to have a contemporary computer and you want to assemble it yourself, just finding parts that match together is already quite hard. And then still comes the software side, right? And that starts with the firmware, and you want to install an operating system to your likings. And yeah, sometimes you might run into surprises like missing drivers, or maybe you cannot boot at all because the hardware and firmware is actually locked down in some ways. So yeah, I've been diving through this and trying to find devices that we can actually repurpose or, you know, just use as development platforms for people who are not working in one of these large companies providing us with the devices, so that we can become a bit more independent. And I'm seeing that in some very specialized communities as well. There is, for example, one which is especially looking at cameras, the so-called IP cameras, which are attached to networks, very often the internet already. And there are actually just a very few vendors behind them. But some people figured out what platforms they are running on, and they're now building open firmware for it. And that's the Open IPC project, if you've heard about that one, which I find very, very interesting. And just by coincidence, I actually discovered that because I, just found some cheap cameras. I wanted to look into them. So I took a little tool called uRoot, put it onto them, and ran it successfully. And then I thought, well, other people might have tried that as well. And it turns out there were lots. And I assume that's also true for many, many other devices that you can find nowadays, or already have even attached to your body, maybe.
Thank you. And that was like a perspective, I think, from the community side. And Ron, you are based in this so-called Silicon Valley as well. How have you seen like changes in the last few months? And I want to come back a bit to what Bunny said already. Maybe you already have a comment that we see some changes with big actors getting in. So I think we could, like, for example, mention that there's some support, for example, by Google for like developers who are interested to create chips. For example, do you have an opinion on that? How are things developing recently from your point of view?
So I've been thinking as I've been listening to the other three panelists, because I learned some things too. So there are two trends I can see where people are trying to open up firmware to the extent possible on systems like x86. And so what we've done at Google, we've taken Linux boot, which means Linux in your firmware, and we use uRoot, which Daniel mentioned, which is Go, programs written in Go that kind of replace standard Unix commands, and embedded Linux boot and uRoot in firmware. And that is essentially integrated into UEFI, which is the proprietary for BIOS we can't get rid of yet. And Google has deployed that at scale in their data centers. And I'm not allowed to say what at scale means, but people have a rough idea how many computers Google has and should be able to maybe guess what that turns into the number of computers in our data centers that today now run Linux boot and uroot. And that's worked out really, really well. So what we're doing as part of that project, which originally we called NERF, and now I forget what we call it, we are peeling away as much as we can of UEFI. We're bit by bit just pulling it out of there and replacing its function with the Linux kernel and Go programs. And my goal is to drive that as close to zero UEFI as I can. That's kind of tough. And we know that on many systems, let's just say those, well, from Intel and AMD, let's just say that's going to be a long, long thing, and I don't ever even expect to get there. Context here, 20 years ago, you could have a full GPL firmware stack on an x86 from AMD or Intel, and you can no longer do that today. So there's context. So there's another effort called Orboot, and that's firmware in Rust. And we have a number of targets. Daniel is actually involved in these. The first target is in AMD Rome. And on AMD Rome, because the memory turn-on is done in a little ARM processor, you can imagine having the x86 running completely, again, GPL firmware written in Rust now. So, we're moving now toward Rust because of all the good arguments for Rust, and we're trying to get 100% GPL code on at least the x86 CPU. Longer term, I don't think the x86 will ever again be as open as it was 20 years ago. It's just, I don't think that's going to happen. And so people who really want a completely, free and open source software stack need to look at things like the RISC-V and possibly the ARM. But I think the ARM possibly could be more problematical because a lot of the people who create ARM SoCs and sell them come with blobs. And there's no way around that. And my belief is if you really want to trust the system you're on, you're going to want that to be, RISC-V isn't open source, by the way. RISC-V is unlicensed. So you have to take an extra step with a RISC-V and go to a company that offers it in open source if you really want that. So if you want a complete open source stack all the way from the transistors up, like Bunny has been pushing, which I think is fantastic, it's going to have to be a RISC-V because it doesn't come with legal encumbrance. And then it ought to be, I think, a GPL thing written in Rust, because why would you write in C in the third millennium anyway, right? You're crazy if you're still writing in C, in my opinion. And then we go up from there. So that's kind of my picture of where we should be going. And, but we have to bow to the realities of the world, which are that we've all got a gazillion x86 systems, and that's going to kind of change for a long time. And those systems are never going to be open again the way they were 20 years ago. So you have to accommodate yourself to binary blobs in that world. So it's kind of a nuanced picture, right? We're moving away. We'd like to move away from systems that require binary blobs. We'd like to move away from C. We'd like to move toward not only unlicensed architectures or architectures free of that kind of licensing. We'd like to be on open source processors. So that's the work of, a couple of years coming up. But we can kind of see all the pieces that we need to implement to make that happen.
Thank you very much, Ron. And you are raising a lot of questions, and I also have this tendency to often say we, and then people always say, who are you talking about? Yeah, and it's well, because every time I talk about is another we. Sometimes it's from project perspective, sometimes it's with other team, because actually it's very truthful that we are not operating in a small console where we just work on our own, right? We are always embedded in teams, in projects, in societies, in our company. So I find both truthful, and I don't know, some people criticize it, but I think it's good, but sometimes need to be defined. Who am I talking, or where, or from what perspective am I talking currently? And I see Bunny is smiling already. I want to go in a moment to Bunny because I saw he's nodding and smiling, and already speaking with his face. And this is what I love about this interaction and video, at least what we have. But I see a number of questions, and they're technical questions. There are questions in regard to society, in my view. Like we have big companies, they're pouring in a lot of money. But there are a lot of questions involved, questions that we also have with open source free software today, where we have companies dominating some parts of this ecosystem. And we have the question of like one company that hasn't been named yet here, but when you talk about ARM, we also, of course, think of Google and of Apple now, right? So Apple brought out this chip M1, and in this panel, everyone said, oh yeah, we're going in the right direction. Things are opening up, GPL, free and open programming language, and so on. Before I go back to Bunny, Ron, is there any comment that you would like to make in regards to Apple?
No.
Okay, so I think that's also a comment. And so then Bunny, what do you think so far from listening to this panel, listening to Ron, listening to Jean-Marie and Daniel? Do you have anything to share?
So, when I made my initial statement, I said that there are actors that have incentives to keep things closed despite things moving in the right direction. I think, I think Apple is one of the people who like to keep things closed. They want to keep people in their ecosystem. They want you to go to the Genius Bar. They want you to buy things for the App Store. They want to make a nickel every time you play, a nickel every time you work. That's their business model. How do you become, one of the most valuable companies on earth and keep your position when you've kind of run out of ground to keep running on? You got to create a profit line somewhere, right? So there are incentives that run against sort of creating a competitive landscape, an open landscape, right? I think openness is about choice, but it's also about competition, and there's a certain non-profitability in that, I think, from not having a monopoly position. So, all that being said, Apple's just behaving as you expected would as a public company, right? That's run by formerly the COO of the company, right? Now, they're an operations-driven organization trying to do what they all do, right? I think I have a friend who's working, on porting Linux to the Apple, the Asahi Linux project. I think it's pretty interesting to watch it coming along and sort of read his exploits and the crazy sort of like WTF moments he has, like realizing the kinds of things they did in their boot process and their and their SOC and whatnot. But the other thing is like I feel like there's also a bit of I have a thesis that when you sort of peel back, the number of reasons why things stay closed, it's not just also sort of the big corporate profit driven thing. There's also just a lot of embarrassing mistakes inside hardware, and it's really hard to, as a organization that has to support customers and have a reputation for quality hardware, it's hard to admit that you have erratum in your hardware, right? If you actually see the list of erratum that come on like really well documented chips, if you printed it, it's a sheath of documentation this thick, like thousands and thousands of tiny bugs, things you're working around. Like a chip isn't so much designed from spec. It's you get a chip back and you discover what the spec is after validation. You're like, okay, how fast does the NIC run? I don't know. Let's benchmark it. Okay, that's the number we put in the marketing thing, right? We wanted 2x that performance, but we actually shipped that, right? And that's just how it is, because you're not going to spend $2 million on a mass set to fix a tiny bug in an arbitration issue somewhere deep in the AXC bus or something like this. It's just not going to happen. So there's also a bit of, I guess, engineering hubris, around sort of not wanting to admit that we have mistakes. And I think that almost falls a little bit on the community expectations that we place on ourselves and our inability to sort of admit that we have problems. But we're getting better about it. I think as people get more educated about the reality of hardware and the reality of these situations, people, customers are becoming a little more sophisticated. They want to sort of see that texture, that granularity, the sort of all those interesting things that are coming along. So that's the hopeful side, I would say, of things going the right direction. But like part of the reason we're never going to see like UEFI and that sort of stuff ever go away is just so many the vendors don't want to publish why they have that little sort of bit of firmware, is because actually if they didn't publish, have it there, the chip would burn itself out in 3 seconds because of a problem in the PLL somewhere. Right? This is just too embarrassing. The stock value of several companies would plummet immediately if they knew that, if you just did the right bits on boot or something like that, you could melt down $500 million worth of servers or something like that. It's just not something they want people to know.
Wow, that is quite a scary idea that you are putting out here, I wonder, how much people are really getting into this topic. That actually, the possibility of hacking these things is it growing or not? I don't know. So you're mentioning expectations and community. So. A lot of people say that the open hardware community is still relatively small. Of course, also if you compare it to the software community of people who are really focused on the software layer. And so let's talk about the open hardware and open firmware community. Who would you count into this? What's your idea about this community? Is it growing? Is it like a specific set of people? Could you describe it a little bit, Bunny?
Oh, me? Okay, back to me again.
You mentioned it.
I mean, I personally, I mean, I don't know. I don't feel any how do you say, entitlement to be able to describe the community. It's a big tent, right? Whoever wants to come in, come with a soldering iron, a screwdriver, and open mind, and now you're part of the community. And if you want to take your stuff and close it, you're not part of the community anymore, right? And so long as I can discover your stuff and I can fork it and I can use it, then I'm a very I guess traditional open source idealist in that sense, right? I think realistically speaking, though, people have to have day jobs and they have motivations and stuff. So generally, we get more community as more commercial interest starts to sponsor people to make it their day job to be in the community. There's very few people who are lucky enough to just, as a matter of their choice, without any constraint, just do what they want to do. That's pretty rare from a community standpoint. And so we have a lot of conflict, with, I don't know, everyone's like, GitHub's on Microsoft. Oh my God, it's terrible. Microsoft is taking over open source. And then, Google's doing this Open Titan thing. Oh my God, can we trust it? They're getting into open secure enclaves and stuff. I mean, it's a mixed bag, right? You need finances to make things happen. You need resources to do it, and nothing comes for free. So there's a bit of we have to, as a community, the people. This is where you end up with people. You talk about people who are more radicalized than others, people who push harder for one thing or the other, right? It's you have to have people who set an aggressive set of goalposts around the idealism type of thing. And hold to it and remind us where we come from so we don't lose our bearings. But then you also need to, throw gasoline on the fire and get things moving. And so there's constant tension that always happens in any of our communities on this front. It's between progress and scale and motivations and these types of things. And I tend to find it's, as long as we keep a pretty big tent and we have open conversations like this about it and we're frank about it and we sort of play the game, we know what we're playing, I think we'll sort of keep moving through it.
I wanted to surprise you a little about this too, about everyone here. If you really want to talk about a company that's in the open source firmware game in a big way and in the right way, you want to look at IBM. And that should surprise people. But if you look at the Power 9, all the source code you need to build their firmware has been out there for years. And it actually includes Linux. And actually, I ported Linux in URoot to the Power 9. And the amount of openness of that Power 10 predates in a lot of ways the openness of the RISC-V. And I think they don't get the credit they deserve for what they've accomplished there, because it's actually, as Bunny points out, this is a really big deal. You're not opening up your firmware, you're opening up all your hardware bugs to people when you release this stuff. And some very brilliant people at IBM. I know one, I just forgot her last name, Elaine. Someone remember her last name for me?
Palmer?
Yeah, Palmer. She is just utterly fantastic. Just look her up. She's worked very hard on how you do the security side of a system where all the firmware is open source, and a lot of lessons. And I'm kind of sorry that, you know, let's be blunt, it's hard to afford a Power 9 system, right? You're probably going to spend 100 times, you know, as to get a working Power 9 system as you would to get a RISC-V board, you know, cheap. So that I kind of regret that, because IBM has done the right thing here from my point of view. So that tent should include IBM, believe it or not, and the tent and OpenTitan should be in that tent. Actually, I actually, disclaimer, I'm on the board of lowrisk.org, and I've kind of had an involvement in OpenTitan, but I know the people, and yep, they work for, let's just be blunt, people consider Google a giant heartless international corporation. I don't know if that's fair or not, but the people I know doing OpenTitan are working very, very hard to do the right thing.
Yeah.
And, you know, so you kind of gotta look a little bit beyond, you know, obviously you have to be a little bit, you can't just trust, but you can trust and not trust and verify, but you have to look a little bit beyond just the surface appearance. Oh, that person's at Google or an OpenTitan. I don't know if I can trust OpenTitan. You know, that's okay, maybe, maybe not, but the RTL's on GitHub. Go to GitHub and get all the RTL for OpenTitan. See if you trust it. Right. Anyway, I interrupted Bunny. I'll stop.
No. That was great. I mean, actually, like I know a lot of the guys in the OpenTitan project too, and I echo your sentiment. I think they're great, and this, despite sort of the reputation that big companies have. I didn't mean to sort of imply I was disparaging the project. I'm just saying that generally there's a community sentiment of distrusting these things. Yeah. And you know, but that it doesn't mean that it's all bad or all good. We have to sort of get into the nuance instead of just putting labels on things and binning them. But one thing I want to add, you said that, you know, Power 9s are expensive, and you said, you know, unfortunately, you know, there's an observation I generally have is that projects that don't subsidize the cost of making something open, because open is actually there's sort of anyone who's ever worked on. Okay, let me reset the story here. So people often ask me, like, why is it that I can't get documentation for this leading mobile phone SoC, right? Like, you know, but I can get documentation for the IMX6 or something like this from Freescale. It's really well documented open source chip, right? It turns out that if you know, I had a conversation with a Freescale engineer about it. They said it costs them by far more to develop this open software stack and document it than it does to make the chip, which is why their chips are always like a generation behind and a process too old, but everything's in the main line of Linux, right? The thing that actually gates that chip is that, and their chips are more expensive and all this sort of stuff. It's because they didn't externalize the cost of open source. It's actually built into that hardware. And what you find is that a lot of times, a lot of these cheaper platforms, right, they're either subsidized by other things, and so they can't be open, or what actually is more likely that happens on a lot of these chips is a vendor will say, okay, I've got this leading mobile phone SoC. They'll put the spec sheet out, but it's also NDA in itself because they don't want to admit they haven't tested all the features yet. And then they have a million unit order from somebody. They start fleshing out. They figure out what actually works, and then finally they only write the drivers for the things that actually end up being used in the final phone. So you'll actually find on the chip a whole bunch of dark silicon for things that didn't actually make it into the final product. They didn't have to burn engineered time to support a real-time clock in this mode that no one ever bothered using. That's too expensive to just write these features to be feature complete according to documentation, right? So what you find is that on the fastest way to get a product out is actually to build the hardware, make sure it doesn't catch fire, throw it at someone who develops a product that can ship 1 million units of it and gets just enough of the features working and qualified for that specific product, and leave the rest turned off, right? Just don't even admit that you have it at the end of the day. And that's because the problem, if you want to open source that thing, then all of a sudden some random guy, you know, somewhere out in the middle of the, you know, is going to post in the forum, like, why is it that when I turn on the real-time clock, the system catches fire? Right, and then it's a big problem all of a sudden, right? You should even know that this thing even exists, right? So, you know, but you know, when you say the Power 9 or Power 8, Power 9 is expensive, it's because I think in part because, you know, IBM is they're making you pay in the cost of the hardware for all that openness and all that documentation. That's actually the price of an engineer, built into the cost of a chip, versus like sort of this Ford subsidized system.
And that's a really good point too, because we've hit this in the Coreboot project since inception, which is somebody says, man, I really care about free and open source software. I really, really, really want Coreboot on my machine. Oh, and by the way, I don't want to pay any penalty in cost, performance, weight, power consumption, battery life. So I want the high-end features that I associate with the latest bleeding-edge laptop. Oh, and by the way, I want Coreboot.
Yeah.
Well, and anytime you kind of come back and say you cannot have those things at the same time, they say, okay, well, the one thing I'm willing to throw away is free and open source software.
Yep.
So every time.
Yep. That's true.
It's kind of makes me sad, but look, I do it too. You're gonna all kill me, but I'm sitting and talking to a Mac right now. So there we are.
Yeah. Well, I don't think we have many options. Aside, I mean, the other thing is that I'm using like a Lenovo or something. Like, is that would that have made it better?
Okay, so I thought you're using a Novena laptop. Okay, so
yeah, sure, yeah. Like, the Novena can't keep up with this video. It would collapse.
Okay, so I want to single out a point that I'm afraid people get a bit the wrong idea that Bunny acted like a little bit in the way that people really have to look for economic opportunities and find a way. Whereas I think the one person in the world who knows how to make business around open hardware is Bunny, and we will hear later more about this in your keynote about Precursor, which was a very successful crowdfunding campaign. But like in regards to the community aspect, Daniel, what would you like to add here? So we hear like different angles, and generally I think everyone is happy that things are opening up. But what is your perspective on the engagement with companies?
Well, that's also a bit of a mixed bag. So you can't even talk about a company at large even. So, there are usually lots of different departments in a single company. And that's also true for companies who sell any sorts of technical products. Let's say HP, for example, right? They sell servers, they sell their business laptops, they sell the ordinary laptops for regular people, of which you will find hundreds just somewhere, I don't know, at Walmart or wherever you go. They also have printers, right? It's a huge amount of different things. And it's always a bit of, I would say, first of all, a bit of a matter of luck. If you just approach a company and you ask them for some information, you might just get it right away. For example, what Ron was mentioning, the Orbit project, where we have a target currently, which we are focusing a bit on. We were very, very lucky in the choice that we made. And we found a chip on a board that we picked for development, for which we couldn't find open documentation. But it turned out that the company was very approachable who made that chip. And they said, yeah, sure, here, you can have that data sheet. And well, we asked again to be sure, can we also publish that? So, it's an open project and so on. Yes, of course, go ahead. That happens. And at the same time, there are also others where you might write an email, you get a response like a week later. That might be along the lines of, yeah, we would support like custom development if you want to produce or buy lots of devices or chips or whatever. And we're talking about numbers that ordinary people, cannot calculate in their regular thinking, right? So it's not like your grocery list. It's more like, if you have been in a very large company in a somewhat higher position, that's the numbers we're talking about here. And if we as a community of regular people. So that's the thing. There are different sorts of communities. Mostly when we talk about communities in the open, the impression is that we are talking about, the no ones that are just walking around everywhere, right? So like you or me, we just want to buy a laptop and we would like to have something which performs well enough. Well, it turns out that actually nowadays you can take a laptop from 10 years ago. You can still use Big Blue Button from it. I'm doing that right now. This year is a Lenovo X230. Old enough, but it still works fine. But there are also communities of people who would like to collaborate a bit more, which are actually employees at some of those larger companies. And that's especially true for people who are working, for example, on the Linux kernel. So there are many people who are contributing to that kernel. But, they're also their own community, and they also have their own conferences and so on, where they meet together. And that's kind of an interesting mixture. So on the one hand side, you have vendors who would actually prefer to keep things closed a bit, but they need to also support the market. So, they make blobs and header files. There is this Linux firmware repository where, you find a bunch of blobs and lots of headers for it. But there are also some which are, just as open and willing to collaborate. And then again, what Bunny was just saying, there is also this weird spot where you run into all of these hardware issues, and guess where you will find documentation on those issues? In a large and well-known kernel, of course. So if you just look through the Linux kernel source code, you will find thousands of issues documented in there, where there is code which you would never assume to find there, because you would say, no, this must be wrong. But the documentation then actually says, well, this is a workaround for that, and so on. And if things twist around in the right way, it works. Otherwise, it might catch fire. Yeah.
Thank you, Daniel. And I want to bring this to Jean-Marie. So we have this topic of community, of openness, and companies that have their own commercial interest. And you are working for HPE. And on your side, you shipped your first systems with open source firmware recently. They are available to private customers who are making a request. And you have extended your CI to integrate remote API as to ease the validation of end users built on HPE ProLiant. And the big topic for you is that you're willing to expand security features. So do you see that security features make a difference? And do you think that open source firmware and open hardware will really make a difference for customers because of security features, or what are your ideas?
Okay, I think the complexity of a company like HPE is that we are selling systems on a worldwide basis. And we see a split regarding the customer demand between North America and Europe, for example. So in North America, people do not want to take care about their security. So they are trusting their suppliers, and they want their suppliers to be liable for the security. If you go to Europe, so that's a totally different story. They do not trust their suppliers, and they want to take care about their security. And they are building up a security stack through transparency. So which means that when you work at HPE, so you are designing a systems that you try to ship worldwide with two totally different targets, and that is the challenge that we are facing currently. Open source firmware currently fit better probably in Europe than in North America, because people can have a look to the code, can adapt it, and there is far much more transparency by releasing the source code. I am optimistic for the future of open hardware for many different reasons. The main reason why people might be thinking it is slow regarding the adoption and the shift from companies like HPE is The first one that I just did explain. The market is not the same everywhere, so it makes more difficult to take the right decision. And then we have to keep in mind that a company like HPE have a legacy. So our engineering team designed proprietary firmware for the past 20 years. So you cannot shift all of these people in a day. So this is like a big boat. So when you say we have to turn left, so it's not going to happen super fast. So this is not a speedboat. This is like a big long haul turn, and we are working on this. But from what I have seen during the past year, a crazy amount of people inside the company were becoming more and more interested about what's going on into the open source firmware communities. And as I said, we started to commit code. It could look like something super basic, but within a company like HPE, it does require a crazy amount of process. So we need to get approval from many different business units or IP attorneys or all this kind of stuff that people do not imagine when they are working into an open source community, which are happening into a big corporation like HPE. But all of that has happened during 2020. So which makes me optimistic for 2021, 2022, and 2023. So we are going to move forward. I'm believing that the market is going to stay split between North America and Europe. I'm always surprised about that because I'm living in North America and I am a European citizen. So this is really weird for me just to have a look at how North American companies react to open source firmware compared to what's going on in Europe. But this is also super interesting because I'm discussing on a daily basis with engineers which are American people. And I'm trying to explain them if we do not do that we are going to struggle in this European market. And this is still super important for a company like HPE because we are doing 40% of our revenue in Europe. And that is critical just to be successful to follow what our customer demand is.
And so, Jean-Marie, I have a question to you because there was a very interesting talk of Lime Proven at FOSSASIA recently, and Lime is also from like talking about HP, right? Like so, he has this perspective where until today, or like today, all computers have used hard disks and at least 2 storage levels, yeah. The future might look different. He says the future might look more like the past again, where yeah, this kind of difference could become obsolete. This kind of separation, and a computer's permanent storage could be all right there in the processor's memory map. And he says there could be that there is no need for disk controllers or file systems. It could all just be RAM. So if we talk about the future, could we imagine also like a future where the software and hardware stack could look different? What's your idea?
Oh, that's it's not that easy to answer to that question because I know the path we are trying to follow, but I don't know what I can disclose publicly. So that's the complexity of that question. What I think is short term, the future is going to be more modular, and we are currently focused at just trying to break down the servers just to offer more opportunities for innovation around how a server works. That is true that there may be needs for revisiting the way the storage subsystem works. And that's also why I'm pushing extremely hard the PCI Express card vendor just to carefully review what they are doing, because they are adding a ton of complexity into their ASICs and firmware. And I don't think this is the right path to follow. So, and they are also our suppliers, and they probably have to listen a little bit more to their customers, and to what we might be expecting from them just to enhance their product. So my believing is when a system is becoming too complex, it's probably not the right path to follow, or at least just to stay independent from what's going on and being sure that you have a B plan.
Yeah, I'm always happy when people tell me we are approaching difficult questions. So this means we come back to this later, definitely in detail. And I would like to ask Ron, because Ron, you work on Harvey OS. You have all this background with core boot and all boot. What's your take on this? I don't know if you have heard about this talk. So that basically the path could be also the future. I remember years ago, BOS, for example, they had a huge they had a very good marketing, and everyone was so excited, but it never took off. What do you see as the technology stack of the future?
I don't think I'm smart enough to have the faintest idea, but the one thing I have been noticing, it takes me about 9 months, the last time I put a patch in the Linux kernel, for that patch to come out the other end of the process of managing a patch. And I hope there's a feeling in the community that maybe unending growth of the Linux kernel is not really the right future. And it's time to start rethinking the architecture such that when I make a 2-line change to something that manages memory technology device driver, it doesn't take 9 months for that to get through whatever processes exist, and that we aren't on the right track when our path is to basically suck every new bit of functionality into the Linux kernel itself. And so I wish it were 2 weeks from now. There's going to be some pretty neat news about Plan 9 in about 2 weeks at last, let's just say, becoming free of the restraints. Now, that's an obsolete piece of code as kernels go. It's C, but it's a good lesson maybe in how you can structure things so that they aren't so massive and monolithic and yet still might have power. I actually think if we look at open source processors, you kind of think of, okay, that moves me about a decade and a half in the performance, and maybe I want to look at an operating system that doesn't quite consume so many resources as it uses the machine. So I feel like I like the move and the work going on in open source processors, and I think now we need to think about how would the world look different? Yeah, if we have so much memory and it's persistent memory, how do we rethink doing file systems? I don't think though that you can just say, well, we don't have file systems anymore because we have this persistent memory that lasts forever. You still need some sort of structure. You still need a way to say, I have a view of the memory, but it's not the view of the memory you have because my view goes back 2 weeks ago and your view is from yesterday. So you don't just simply, throw out everything that's ever come with file system lessons from the last 50 years just because you don't have a rotational media anymore. So I think this is a really complicated question, and I think this is actually a really good time in that way because there aren't any ideas that we shouldn't be trying, and we might as well try them in an open source community. And I don't think we need to worry about whether it's the way things are done today, because open source all on its own is the way you break away from the way things are done today, especially in processors. And the fact that we'll be resource constrained because we'll have an open source processor that's slower and not as dense and not as capable as the bleeding edge of the nice processors we get from Intel AMD, I think that's a good thing. Unix originally grew up out of a resource-constrained machine. You had to think a lot, and the reward was for code you didn't write, not for code you did write. And we need to, this is a chance to kind of get back to that, to where we've got to really think a little, and emitting code is not the virtue. The virtue is showing how you don't need to write code. And I'd love it to see people from this community kind of try and look at that model. So how much code can you get rid of and how much code can you not write? Because you came up with a good abstraction. And then Plan 9, it's an old code base, but Plan 9, they really nailed the abstractions. They really got them right. And there's just lessons and lessons and lessons in there. And my biggest regret, I'll stop in a second, but my biggest regret when I see a new operating system written in Rust is that people implement the Unix or the Linux ABI. If you're going to begin anew, for God's sakes, don't begin anew with a 50-year-old design. Think a little. Look at your abstractions. That's how Unix got where it was. They got the abstractions right, and we've really forgotten that lesson. Now I'm done.
Yeah, I really love the way you talk, and it's something that's very difficult to say. As a German, it always sounds like a command. Look a little, yeah, like commanding people. But actually, I totally understand where you're coming from, and you say it in a very good and understanding way. So thank you very much, Ron. And we are really getting to the end of this panel again, and I found it super interesting. And before we close, I would like to make a final round where we have a short outlook, a short comments, what we should take away from this panel and what you are taking away from this panel. And I would like to start again with the first person here on my screen, Bunny. And I think Bunny always looks surprised when I address him. But Bunny, please, what would you like to take us, and what would you like to take away yourself from this panel?
It was interesting. I have a lot to think about, I guess. To hear people's different comments and different perspectives on it. It was actually really good to hear Ron's comments about his opinions on sort of, giving credit for reducing the complexity of things and rethinking things from a very low level. One of the things we're doing in precursors, we're trying to really run in a very minimal environment, and we get a lot of flack for not just running Linux on it and calling it a day. I'm gonna try a stab later this year at writing even like a file system layer that gets rid of the idea of files, but just as a key value store or something like this for a number of reasons, like just reasons, right? Just don't even try to argue with me as to why I should or should not. I've had people try to discourage me from doing this, say, why are you crazy? Just file systems are hard, don't do it. I'm like, yeah, but
You're not
why
crazy.
Not? You're like one of the few people who said that to me. But it's interesting just to sort of, I think one of the, honestly, just, and this is more a criticism of myself, just because of the whole pandemic and everything, this is my world. Like literally you're looking at where I sit, 18 hours a day or something like that. I haven't gone 5 kilometers in a year or something like that. Right. So honestly, I don't get my head out very much. And, unfortunately, the internet's been really bad about delivering me content because everything is now filtered and targeted towards me. So it's hard to discover new ideas and to hear fresh opinions and this sort of thing. So it's actually really nice to just be put in a panel with a bunch of people who I otherwise wouldn't have had a chance to hear their perspective on, and to get some clarification, get myself out of my little shell, and give me a little bit of things to think about. So thanks, guys.
Thank you very much. And going over to Daniel, what's the takeaway?
I would actually like to open up another perspective right now. So I've been attending many different events and conferences over the last years, until COVID started. And at one of these, I met someone who recommended me to read a book. It's called Culture and Empire by Peter Hintels. And in that book, I was reading that, technology over time was always becoming something which was more and more accessible to everyone, after people who were just rich or large companies got their hands on them. And that's what I'm seeing now on the hardware side as well. So if you just think about it, you can already make your own whatever stuff with 3D printers. People are doing that a lot. They're sharing all of their designs and so on. There are large platforms for it. You can take programs like FreeCAD or KiCad and design your own PCBs. Just order them in, I don't know, if you're well trained, a few minutes, I guess. And likewise with many, many other different things. And I've seen some people also talking about designing their own chips now. Of course, they will not start right away with a 7 or 5 nanometer process, right? But that's not the point. The point is getting started with that. And if the law is true, and so far it holds on, you know, all layers, then this will be a thing in just a few years, actually. So that's another perspective on looking at RISC-V or ARM more than x86 now. But there is so much more, and I am very, very sure there will be another architecture coming up as well. So that's my perspective on the future here.
Thank you very much. And Jean-Marie, what's the takeaway from your side?
I think the good news first is that we are still speaking about open hardware a year later. So it means that there is still some interest for that. And I do see that the interest is growing because I am also a big contributor to the FreeCAD project. And during the past year, we have seen our end user base just growing like crazy. I don't know if it was the pandemic effect or if the open hardware communities are growing or not, but we are seeing more and more end users and more contributors to that project. And we have new ideas about how to expand this. And I do envision that there is more and more people who are collaborating around the world. And that is the positive impact of the pandemic. So we try to keep working with others. And the only one way was to use properly the internet. As I am always saying inside HPE, the world is not changing in a day. But I am super optimistic that within the next couple of years, we will see more and more great open hardware ideas and designs coming up, and they will be implemented into a big corporation. I'm optimistic regarding this, even if I know all the pain that we will have to go through just to make it a success. But I do believe this is doable now.
Thank you very much. And Ron, the final words are on to you.
So I was thinking that I was at a US DARPA sponsored project in 1988 where the head of the computing division announced that they were no longer going to fund any operating system work unless it was Windows NT, because Windows NT had clearly won, right? So by the mid to late 90s, a lot of organizations had given up and were ready to surrender to Windows NT. And we all know the story. Linux had already won by the time DARPA thought that Unix had lost. In 2010, a lot of us in the open source community had just basically given up on coreboot. I'll be blunt. A lot of us had decided we'd lost. We have a lot of big companies going after us and trying to kill us, and we thought they'd succeeded. Every Chromebook sold today runs coreboot. There are more Chromebooks than there are MacBooks today. And I think the lesson from all this, I used to say it and I lost faith in it for a while, and I now believe it again. Open source is always going to win. And there are a lot of reasons for that. One of the reasons is nobody is smarter than the rest of the world. So I can have a smart person at a company that's doing a closed source thing. They're not smarter than the rest of the world. So in the end, open source wins because nobody's smarter than the rest of the world. It's just the way it works. So if you ever get discouraged, don't. Open source always wins.
Thank you very much. This is a wonderful closing word. I see everyone is nodding. And yeah, I also want to add a small, like a few small sentences here, which is like, we talked about Linux a lot. Greg Hartman, he will be here on Tuesday giving a keynote. I would like to invite you for questions or any comments that you would like to make. It's exactly at the same time that we're ending now this session, so in 2 days. Yeah, it would be nice to have a real like on-site event, because we could go right over and talk to him. And yeah, at an online event, this is not possible in the same way, but like, let's try. So the other thing is like that there are still a lot of topics that we didn't address, and Daniel already opened up a new topic, and I think we have like the huge topic of analog computers that some people see as a huge business opportunity now even. And for example, in Germany, there's quite some investment in this area that we could address maybe in a future discussion as well. And of course, like I think like the topic of the technology stack, that's definitely not finished, and we probably have yeah, we need more chances to go into detail here. So thank you very much for this like really interesting panel. I appreciate that you all took the time at very different times. I know for Daniel it was very early. Bunny was in a good time zone. It's often not the experience for people in Singapore, who always like have to arrange with others. And yeah, and Ron and Jean-Marie, so thank you very much for making time at this challenging time. So there's a nice picture of the previous year.
I'm going to step up for just 1 second and get some water and coffee, and I'll be ready to give the next talk. So I'll give me like 30 seconds.
Of course,
quite an injury.
Thanks, everybody.
Thank you.
A couple of minutes more. So thank you very much, everyone, and thank you for this wonderful panel. We are documenting this, and we'll be releasing that. It was also live on YouTube. So I say goodbye, and I hope to see you soon again. Thank you, everyone.
Thank you.
Bye.
Thanks a lot for having us. Take care.
I just want to tell Ron that I'm taking his sentence to be the tagline of this conference. Open source wins.
Thanks. It works too. Take care.
So thank you very much. And yeah, for the audience, we will continue here in a few minutes with the talk of Bunny's keynote. Yeah, and a lot about his project Precursor, that was a hugely successful Kickstarter campaign. We heard about this project last year, where he outlined the technology behind it and his idea. And then we will continue in 2 minutes and let Bunny get ready quietly. So thank you very much. We continue in 2 minutes. We continue.
Hello, Bunny. Are you
Hey.
ready?
Almost. I'm trying to find the spot to start screen sharing. I can't remember where that was in all this
I
UI.
need to give it to you, but then we don't see that beautiful picture anymore.
Oh, okay. Did my slides get uploaded okay? I uploaded them about...
Okay, so now this is I give you the presentation, right? We just test
Okay,
a little bit the system, so it took us a few minutes, but everything is ready now.
Okay.
So I just want to so that picture I just say that we really appreciate that even in any situation you were here and share the knowledge with us. So thank you very much. Now we cannot meet in person, but we're very glad to have you here on the call.
Yeah.
Today. So Bunny, I think that a few people joined in just now, so I'm gonna do a quick intro again, if that's okay with you.
Sure.
The technical team, I guess we are ready, right? So from the video team, if you can give me a hint in the chat. Okay, great. So I saw on the team chat that everything is ready. Good. So Bunny today gonna talk about a precursor. This is a hardware project that he started. So Bunny is the creator of Precursor. He best known for his work hacking the Microsoft Xbox. I think that we all read about him. He giving a keynote at many conferences. We also met a few years ago at the CCC. He worked a lot in designing and manufacturing open source hardware. One of his very famous projects is the open source laptop, do-it-yourself laptop, Novena. Yes, so this is about Bunny, and as we are all ready, Bunny, I will hand it over to you now.
Okay, great. Thanks. I guess we're... sorry. I had uploaded them earlier today. I don't know where I would find them.
You need to click on the plus icon again, and then you will see the list of presentations.
Okay, so I have to turn on the screen share here or no? Yes? No.
You can use the share screen, or you can use the upload the presentation. Which one do you want to use? You said that you upload before.
Yeah, I had uploaded it already. So where is the button for upload?
The same button again, and then you will see it on the list of the presentations. The same button to that you upload before, right? There is a plus icon.
Up left, upper left?
Yes, on the left.
All right, I'm looking for it. Oh my God.
Lower left.
Lower left. Oh, okay, the little plus icon. Right. Actions. Upload a presentation. There it is. Let's see. Did that? Interesting. So I had uploaded on EventYay website, but I guess it didn't show up here.
You uploaded on EventYay. So it's not going to be here Monday. So.
All right. Let me copy it over. So I thought that when it was copied into the UI there, it would show up here, but so it has to be uploaded here as well. Got it. Give me 1 second. Sorry.
Actually, I can upload it here for you. I have it here already.
I've got it also here. It's just a different computer. Sneaker it over.
I think it's 58 pages, right?
Shouldn't be that long. Let me just try one more time. Here we go. I think I have it. Where is the plus sign? The plus sign has disappeared from me now.
It's uploading at the moment, Bunny.
Oh, really?
Yeah, it's uploading. This very moment.
Oh, did you upload the one that I uploaded to EventYay? That's the most recent version. Okay, great.
Yes,
great.
Yes.
Okay. Okay, now the plus sign has disappeared from my UI.
It will appear again after this.
Oh, after the upload's done. Got it.
Yeah.
Okay. Sorry. Hey, look at that. That looks almost correct. Thanks. Sorry about that. I didn't realize I had to upload it also into this UI. I thought the website was where it went. So I just don't have a plus sign yet. Oh, there it is. Okay, now I go. Oh, and now I'm the presenter. I've got control of this whole thing.
Yes.
Oh, look at that. I've got control. All right. Hi, everybody. Sorry for the small technical difficulties. I thought I was following directions, but I wasn't. And I guess we're running a little bit behind schedule, so I'll probably be a little quick through some of the sections of this presentation. But thanks, everyone, for tuning in, spending some time with us, you know, to hear about my keynote here about Precursor. Mario asked me to talk a bit about sort of how this device I'm making was made for sort of more everyday use. So we're going to be talking a bit more about some of the mechanical design aspects and the user-facing features of it. So here's my talk. It's about trustable open hardware for everyday use, and it's about a product that I'm making called Precursor. So let's start the talk very briefly to review. Ask the question about trust. You know, where does trust actually come from? It's kind of an epistemological question, but basically the root of the question is, how do I know I'm running the code I think I'm running? And it's not just my computer showing me a screen that looks very similar to the code that I think I'm running. And a lot of the trust models today come from the idea that you have a root of trust. It's a piece of hardware that contains an unalterable, trusted piece of ground truth from which you derive all other truths through cryptographic mechanisms typically. So the problem with that model, though, is that hardware itself is not infallible, right? So there are some well-documented examples now, thanks to a bunch of incidents that have happened, for example, of the NSA intercepting Cisco routers and inserting beacons on the inside of them, to a reporter, Andy Muller-Magen, who had reported that he had a listening device inserted in his cryptophone. So there's actually a picture here in the middle of a small microphone amplifier that was soldered onto the codec wires, and it goes to a transmitter board that was elsewhere inside the device. So, and then also there's JTAG implants that are just, you can buy off the shelf in government programs to insert inside Dell PowerEdge servers and that sort of thing. So it's established now that hardware is not infallible. Of course, a lot of people say, but Bunny, I'm just a regular boring person. No one's going to hack me, right? I'm not worth the effort to hack. The flip side of that is that there's actually, thanks to modern supply chains and the way that things work with Bug Online, there's everyday hacks now for everyday targets. So the typical DIY supply chain attack, which doesn't require you to be a government agency to intercept the package and on the way to someone's door, is to just buy an item online, modify it, pack it back into the box, and return it to the warehouse. And then do whatever you're going to do and profit, right? So there's some documented examples here of someone who, this is from the Wallet.fail talk a couple years ago at CCC at the Congress, where someone had taken a Tracer box and they managed to open it and basically close it again without modifying the box too much. And it demonstrates the idea that you can get something online, but you can't necessarily know what's on the inside of it, and it's not actually hard to execute the attack. In fact, actually, it's almost zero cost to the attacker. They get their money back for the thing they returned at the end of the day. You just have to be physically close to your targets that you're looking for. You can't specifically target it with a supply chain attack, but you can get within a geographical vicinity towards targets of interest. So what it turns out in general is that the roots of trust and practice is that within your own environment, everything looks solid, but just don't look down what's beneath your castle in the sky, right? Just don't try to go too far deep into what your roots of trust are. And the big problem at the end of the day is that, and the reason why we have the situation, why we have castle in the sky, we can't look down too far, is that we can't hash hardware. So in software, we have a hash function. It's a cryptographic function we can use to sort of very quickly inspect every single last bit inside a binary and confirm that nothing has been modified en route to our computer, en route to our execution point. The problem is in hardware, there's no way for us to go ahead and just do a hash of all the atoms in a particular piece of device. And so we have what's called a time of check to time of use problem. So the time at which you inspect your hardware piece may be different from the time at which you would use it. So perhaps the reporter who had his cryptophone hacked, at one point had confidence in the device, but later on someone had tampered with it, installed the microphone, and so now you have a time of check to time of use problem inside a piece of hardware. And I'll be the first one to sort of call myself out to say that I've always said there's always a bigger microscope. I'm a big fan of reverse engineering and finding out how things work and that sort of stuff. And so it's true, yes, there are like very sophisticated technologies that can use to image hardware down to the transistor level, even the most recent process nodes, right? You can read some papers on it online. The problem is that the size of the microscope that was used to do that paper is literally the size of a building. This round thing here is the light source that was used for the technographic X-ray imaging that allowed people to view those transistors at such a fine level. So it's not something you're going to park in the back of your house and use it to inspect everything that comes in from Amazon or something like that. Second problem is that verifying one chip only verifies one chip, right? It's not the case that you can just selectively say, I'm going to just check one of my RAM chips out of the dozen in my system and I'm going to be okay. You have to check every single one of them. Just one compromised component is all you need to go ahead and install an implant. We wouldn't random sample signature checks on our updates from they would download online. We do 100% check on all of our software, so why wouldn't you want to do that for your hardware as well? And so then, this leads us to the question of, can we build an evidence-based case to trust our computers? Right now, we feel that we can trust our computers because there's a brand on it. People say, oh, Apple is, invests all this money. They're all about privacy. And, I like the Pixel phone because it's Google or whatever it is. But, do people have evidence-based reasons to trust the specific piece of hardware they have in front of them at this point in time? And in order to sort of build that case, I've come up with sort of 3 principles I think that the hardware designers need to obey to be able to get to the point of an evidence-based argument for trust in hardware. The first one is that complexity is the enemy of verification. The second is that we have to verify entire systems, and the third is that we need to empower end users to verify and seal their hardware. So very briefly, and I know many of you probably have heard these arguments from me over and over again, but for the benefit of people who haven't heard it yet, I'm going to go very quickly over it. When systems today are so complicated that even if you could take them apart and verify them, like this is a picture of your typical smartphone over here, you would destroy it, right? Like people who have tried to replace the battery in a smartphone themselves have noticed that they have adhesives on the back panel that are so aggressive that you essentially have to throw away the back panel and put a new back panel on, right? So people don't even want to take off their panel to even check if they have the gigabytes of memory that they were promised originally inside the system, right? They're really just sealed objects at this point in time. So that's one problem. And there's also, they're just too complicated. By the time you take it apart, you don't even know what to look for on the inside. You could spend a lifetime trying to figure out if your phone's built correctly and still not find the needle in the haystack. And so there's a trade-off now that you encounter, sort of like their verification, the ease of verification versus features and usability. So the example I like to use is you have these AirPods, which are magical. They stick in your ears. They don't have any wires in them. They probably have 100 million plus transistors on the inside. So good luck trying to find any sort of firmware bugs on the inside that could exfiltrate your conversation to someone else, versus a very classic sort of headset that you would use with a boom mic on the inside. It has exactly one transistor, which is the FET that's used to amplify the microphone itself, and everything else you can verify using, it's a coil of wire, Maxwell's law, physics, these types of things. These two objects actually perform nominally almost the same thing. They're headphones, right? But one of them is incredibly much more complicated to verify, has a lot more opportunities for things to go wrong. The other one's very easy. But the trade-off is that you now have, a wire that you have to have hanging off your head, which I have no problem with, but a lot of people seem to think that is like the worst thing ever, and it's completely worth all of the trade-offs engendered in using it. So the second principle is that we need to verify entire systems and not just the subcomponents on the inside. Very quickly, a lot of phones already contain a secure element on the inside, security enclave or whatever you want to call it, wherever the brand is, and they're meant to keep your private keys private. So in the case of an OS exploit or something, even if the CPU is hacked, your keys are still safe. So therefore, you should be you should be good, all right, because like your trust root is not compromised. The problem is that, and I used to call this the I/O problem. I think more directly, we can call it the input method editor problem, the IME problem, is that even if your security enclave is locking down all of your messages and using Signal and everything's end-to-end encrypted, people feel very safe on all this. There's a thing that you did probably when you first booted your phone where you installed an IME and it popped up a little note, very much similar to the one on the right-hand side, which says, this input method can collect all the text that you type, including personal data, passwords, and credit card numbers. Would you like to use it? And people go, okay. And then they're done, right? And so at this point in time, you've basically taken this entire, tree of security that you've done and just uprooted it and floated in the sky and just gave all the permission to whoever you're using for the IME at the end of the day. And everyone does this, right? So this is why you have to verify the entire system and not just one particular component of it. And at the end, and then the third principle is that we need to make sure that end users are able to actually do the verification themselves and ultimately seal the hardware. When I say verification, it means like verification at multiple levels. So circuit boards, design level, chip level, right? Like we have to go down, all the way to the bottom, because the problem is that when you talk about these epistemological problems of trust and where does the trust lie, you really have to go pretty much down to the bottom level, because there's another turtle underneath that will cause a problem for you if you don't. So Precursor itself is, and this is the project that I had referred to earlier. It's a case study in verifiable hardware. So I wanted to put together a system that could sort of try to meet these goals. I think they're hard goals to meet, but we're trying to move to the point where we can sort of facilitate an evidence-based trust relationship with our hardware, right? So, I want to build something that was simple in construction, open in design, yet sufficient in function at the end of the day. So, Precursor itself, what are the functions that I envision it could be used for? There's a picture of it here on the right. It kind of looks like a mobile phone-ish. It's not a phone. It doesn't have the ability to, put it in a LTE card or something like this. It connects by Wi-Fi. It's designed for secure text messaging. It's designed for voice chat. We give it multilingual capability from day one, which is very important because actually it turns out one of the hardest, anyone here who's sort of programmed in Rust and dug into the bottom of it, what is the hardest data type in Rust to deal with? It's not, the U32 or the U64 or whatever it is. It's the char, right? Because a char is a UTF-8 thing which has a variable length size. You don't know how big is your char. You don't know how big a char is, right? So human language itself is actually, we take it for granted. In C, we always think of it as, oh, it's obviously a byte, right? It's not. It's actually encapsulating human language in a small form factor design is one of the hardest things to do. So we focused on that from day one because not the entire world doesn't speak English. And we want to be able to do things like password management or maybe a crypto wallet, whatever you want. It's open source, right? So there's a bunch of things you can do with it. But things we want to explicitly throw out from the design envelope from day one were things like web browsing. Because I kind of feel like you could do all this effort and then you throw a web browser on it and you just immediately undo it. I don't think the web browser itself, I think, is an unprovably difficult surface to trust, right? I don't think we're going to get to the point of a fully trustable web browser just because it has to do so much. Video games, you can probably play Tetris on this, but I don't think you're not going to play a 3D, shoot 'em up game on it. And it's not designed for doing photos and videos. I think that's still a bit too high of a bar for today's open hardware capabilities. Maybe in the future. You can play Minesweeper on it. So Precursor is simple in construction. So this here is actually a picture of actually all the parts that go into it. You can sort of see from the left. There's a case, there's a motherboard, there's a screen, backlight, sort of some shields for anti-tamper and RF management, keyboard, and a front bezel and a battery. It's really, if you think it's minimalist, that's the whole idea. It is. The idea is we tried to design out too much complexity so it could be something that we could verify at the end of the day. So for example, we went with the physical keyboard. it's a controversial decision. Virtual keyboards are fast. You can swipe on them. They're really responsive. But the problem is that virtual keyboards have to interpret through your CPU at the end of the day. Our physical keyboard, is just bare wires, physically inspectable as switches, right? There's no silicon chips, and we solved the multilingual issue by having this overlay that we put on the top. So there's like a little printed film that we put on top of these key switches, and you actually just take some screws and you take out your language, you put your new language in, you do a setting, and you're inside your new language, right? That's the input method editor switching mechanism, is a screwdriver, right? So it's a very physical, simple mechanism, but it's very easy to verify. At the end of the day, you can you verify it by just holding up to the light. So this is a picture of what the keyboard looks like. You can see the darkish areas where the switches are. You can see the wires and the connector. That's it. If there's anything else on it, then there's a problem at the end of the day. On the flip side, if you want to do a touch keyboard, verification is very hard. Cap touch requires not only the whole input method editor problem, but it requires proprietary chips with a microcontroller firmware blob. We were talking in the earlier session about how firmware is inside everything. If you look up the data sheets for sort of touchscreen controllers, you'll see like the saying, the firmware revision of your touchscreen controller and the data sheet have to be in sync. It's crazy how much code is inside of these things, and we didn't want to add another code blob where we didn't have to. The screen is also very important because not only do you have the input method or editor problem, you have the screen scraping problem. I mean, one of the things that sort of blows my mind about web browsers today, and I learned this during the pandemic, is that you can now share your screen with a web browser, which is, I'm like, why did we even add this feature? Who thought it was a good idea to have my web browser read my screen, right? Like to me, that just sounds like, 2 years from now, we're going to see some person be like, oh my God, like people have been reading, scraping my screen and getting all my other things I type. How is this possible? And we're like, well, because we let them in. We added the feature. We wanted it for some reason or the other, right? So I don't want stuff going to my screen. I don't trust it, right? So we decided to build in a black and white screen. It's high DPI, has a good resolution to it for the size of it. And we want it to be verifiable at the end of the day. We want to sort of have the screen also meet the same bar of verification. So we actually picked a screen where all of the drive electronics are built on the glass as transistors that are big enough that you can see them with an optical microscope. So this is a picture here. If you were to peel off the backlight and look at the screen, you can actually see the individual transistors that form the construction of the pixel drivers. And the reason why we don't use a color LCD is that all of the color LCDs, they incorporate a driver IC. It's a little fleck of silicon. If you ever get a chance to tear apart a screen that you broke or something like that, you'll think, oh, there's nothing on it. There's no silicon. You actually see it's a long, thin bar. It doesn't look like your normal chip that's square. It's actually a long, thin bar along one of the edges. And it's implemented in some pretty high node process, has a frame buffer, has a command interface, has everything you need to sort of sock out a couple lines and put them someplace else. So this is actually what we sort of designed at the end of the day for the circuit board. And one of the things we also want to do is we want to help people validate their circuit boards. It's not just a matter of making it simple and single-sided and whatnot, but we actually will continue to publish diagrams like this as our hardware goes through revisions, so people can look at it and say, okay, these are the parts. This is what these things do, and this is what we should look for. And if I see something off on it, is that just a manufacturing mistake, or is that regular variance, or is that something to be worried about? So part of the process is also not just being open about it and making it simple to inspect, but also teaching people how to do this themselves. I don't want to, sort of be in a situation where people are relying upon us to render opinions about the trustability of their own hardware. The PCB itself, just a quick note on that. We actually designed the whole circuit along attack surfaces. So we want to also think from the hardware, from the standpoint of if you had physical possession of the hardware, how might I go ahead and attack it? So we have a trusted domain and an untrusted domain, and we sort of divide them between each other. And the circuit board itself is laid out, so there's actually there's a metal shield that will go over a region here. I think you can see where I'm sort of outlining with the mouse cursor, that will actually cover all of the trusted domain items. And then there's a set of attack surfaces on it that you have to really pay attention to, and that's where you would want to look at. So if you don't have infinite time, you don't want to spend days learning about this. Here's like 6 things you should look at before you use your device, and if they all look fine, fine. Like it's a 5-second check. You've got time of check to time of use. And so finally, we get to the hardest problem, which is sort of the silicon, the system on chip, the SoC. How do we get evidence-based trust in CPU? Like, it's very difficult to check and use a specific chip. So, IBM has published wonderful pictures of like this, where they show how a chip looks. You can see all the transistors, but how they did this is they actually cut the chip. This is a cross section of a chip. You're not going to use that chip anymore, so it's not useful, from the standpoint of usage. So instead of and also this trying to topside imaging is hard because you have to remove all the dielectric. Backside imaging is incomplete. Blah blah blah. Instead of trying to rely on imaging for this generation, we're using the field programmable gate array. So an FPGA is a large array of logic and wires that are user configured to implement a hardware design. So it comes as a generic array. It doesn't actually do anything out of the box without a configuration that you put into it. It's an array of gates, as the name implies. And the whole concept is that we actually ship you the source code for your CPU. We give it to you. It's written in Python of all languages, called a language called LiteX, and it compiles down to Verilog, and then it gets mapped into a set of gates, which then are loadable into your device itself. And the idea is that since you can now compile your design from source, you can transfer trust, quote unquote, like software. So there is a question, of course, can the gate array itself have like some evil backdoor on the inside or wherever it is? And there's a number of mitigating factors like you can do. People who are familiar with the security lingo, you do address space layout randomization on kernels to prevent exploits. You can sort of do some random mapping of the hardware to frustrate people's attempts to backdoor your devices. But at the end of the day, the whole idea is to narrow that time of check to time of use by allowing you to compile your own CPU from source. You don't have to. We'll ship you a reference CPU compiled. But if you want to go ahead and install the tool chain, it's not small, but you can go ahead and compile your own CPU from source. There's a very quick look on the inside of it. We actually have, like I said, putting a lot of effort into documenting as well, not just trying to push code and hope people can understand it. But if you look at some of our collateral, you'll see diagrams like this, which sort of you can use to explore all the items on the inside of our system on chip. And the biggest potential at the end of the day is that by using an FPGA, we can move the point of check closer to the end of the user. So the vision, ideally, is we want to have someday a one-click tool to verify a bit stream, so people can say, I've got a bit stream, does this do the right thing? And it's all open source and you can do it. We're not there yet today. And to be clear, that's a hard problem because there's a lot of tool chain that has to be done to get there. But there's a path to it, at least. We see it. And I think it's doable, it's just a matter of time. So I think we'll get there. So this is the point at the talk where I kind of sort of pivot more into the main theme. Now that we've kind of gone over the background of what P-Cursor is and why we're doing it, what we hope to accomplish. Or we talk a bit more about sort of like the human-computer interaction aspect of it, right? So I feel like the final frontier in security is HCI, human-computer interface factors, right? Because if you build something that is perfectly secure, at the end of the day, what you find is that people hack the people. Humans are the weak link at the end of the day in any type of security. Phishing attacks, impersonation attacks, ID theft, these are all types of problems that we're going to experience actually more and more, unfortunately, as the security gets better and better and we invest more and more in putting our stuff online. So some of you may be familiar with these bank tokens that the banks give out. This is sort of an example of a minimal attack surface, a simple, inflexible interface device. But the whole idea of it, they call it a second factor of authentication. It's another device that is very difficult to hack, at least remotely. I mean, in person, you can do whatever you want with it. But at least remotely, it doesn't have a network interface. And you can use it to prove that, you have like this shared secret with the bank. On the other end of it, we have things like browsers. They're featureable. They're feature-filled, they're flexible. They're basically operating systems in and of itself. They have an intractable attack surface, and ironically, people are pushing people towards logging into banks using their mobile phone apps with browsers that are basically, Node packaged into some Electron framework with whatever else going on, and they call it a second factor. I mean, it's, when you put everything into one device and you give it a huge attack surface, I'm sorry, you have one factor again, right? So it's not really, we've sort of taken 2 steps forward, 1 step back, in this escalation of human-computer interaction form factors. So Precursor tries to hit this balance of being right in the middle. We want to be just enough and no more, and we want to have a sort of a securable attack surface on the device itself, which means that, sorry, next slide here. So to try and illustrate what we're trying to do a little more clearly, I have this sort of Venn diagram chart. I like to do these sorts of things in my talk to sort of talk about the 3 domains that we're thinking about. So there are things that are hackable, so they're unlocked, and the design source is mostly available. It'd be like Arduinos and Raspberry Pis, these types of things. They're hackable, right? They're not pocket ready. You can't stick, Raspberry Pi immediately in your pocket. If you did, it would poke you in the leg because it has a header sticking off of it, right? And it doesn't have evidence-based trust because it has that Broadcom SoC on the inside. You don't know what's inside that Broadcom SoC. It still could have a backdoor. It could have other issues going on the inside. It has lots of firmware blobs at the end of the day. Then you have things on the right-hand side that are pocket-ready. They're like your iPhone, most Android phones. Like, they're really beautiful. They stick in your pocket, but you can't hack them in the sense that, they're not unlocked. Their design source is definitely not mostly available. And there's no evidence-based trust at all. You may trust them, but it's not because there's an evidence that this hardware does what it says it does. It's because you trust the vendor. It's a social reputation contract with the vendor is why you have trust, and it's not an evidence-based relationship. It's a faith-based relationship with your mobile phone vendor. And then you have some devices that allow for evidence-based trust. Like there's some of these devices here where you can actually compile your CPU from source, run it on the hardware, and say this is actually executing the instructions I think it's going to execute. And amongst these 3 domains, Precursor is sort of like one of the few devices that gives you all 3 of these properties in a single device. And pocket readiness is sort of one of the big differentiating points on that. Sort of belaboring that point a little bit more. So here's like a functionally equivalent piece of open hardware to what we're shipping in Precursor. It's the ULX3S. It's this wonderful lattice-based FPGA system. It's easy to verify and trust. You can compile your CPU core for it. It's totally open. It's affordable. The bad side of it is that it's got no screen or keyboard, right? So it uses a HCI problem obviously to it, and you can't carry it in your pocket. It does have some buttons though, which is good, and it has like a little thing for a screen that you can plug in and carry around. So it could get there, right? On the other side, we have some everyday use, kind of open phones, open hardware phones like the Librem 5. The good news is they're pocket ready. This is definitely a very pocketable phone. It runs an open source software stack. It has a browser, so it's usable. The bad side is that it also inherits all the attack surfaces of Linux and browsers and SoCs at the end of the day. And the ugly is that you may just end up having to carry 2 devices anyways in practice because the Librem 5 may not get you all the way to being everything you need in terms of an app store and running all the native apps that you have to do to interact with everyone on a daily basis. And so you'll have this phone plus another device anyways, and so now you have like, still carrying 2 devices, but you haven't gotten there in terms of the evidence-based trust. That was the thing that you cared about. So our point of differentiation is that we wanted to take open hardware, which is particularly stuff on this circle here, sort of things from the lineage of Arduinos and Raspberry Pis and Snickerdoodles and these types of things, and move them towards the pocket-ready side. That's sort of one of the major thrusts that we had in the concept and design of this. We want to have a thing that looks and feels like a gadget, fits into your everyday life, so you wouldn't feel weird bringing it out at a dinner party and checking a message on it. It wouldn't be like, I'm going to pull out a pile of wires and like an HDMI display and set my Raspberry Pi and start typing, in the hawker stall or something like this. It would look a little weird, right? This one you would be, it would not be out of place, but still is also trustable. It has no compromises on simplicity, verification, or openness. Which means that in terms of making our case, it was much more than just having a pretty face to it. We want it, and I want to talk a little bit about what went into designing the actual hardware the actual mechanical stuff around precursor itself. So it was actually a multidisciplinary exercise in design, material science, mechanical engineering, and electrical engineering. So, you know, when we started the design, we thought about a lot of different concepts. We actually started from a place where we looked at a paper from Microsoft, of all the places, where they did this phone cover. It was actually, you know, for the whatever the Microsoft phone was at the time. It was like a little cover that was e-ink, and you could close it on top. And the idea is that you would have like the static e-ink display that could display other content next to your phone. And the idea is you could sling your boarding pass over there. Remember back when you get on an airplane? You could sling your boarding pass over there, and if your phone was dead, the e-ink display would preserve your boarding pass, and it would actually scan because it's e-ink. It's not like a reflective display also. So it had all these kind of nifty little features. It had all these nifty little features for you know, from the human computer interaction standpoint that I really liked. It was a really good way of having a secondary device next to your phone that I thought was very clean. So we started playing around with the ink. We actually got some e-ink samples. This here is an example of a UI mock we did on a piece of e-ink that actually had both red, black, and white colors on it. And we realized actually there's actually a security problem with using e-ink in that, like, we removed power and it's still showing the last message. So there's actually a little bit of volatility is a good thing, because you want to be able to, you know, erase messages and not have them sort of just persist there, I thought. So then we went towards this smart memory LCD displays, which we're using the final case. We sort of prototyped it, hanging off here off a Raspberry Pi. This is an early dev board we're using to sort of test keyboard concepts, random noise generators. Also, like, basically we just did a trash tape out of a circuit board just to see if we get anything to work. And we did some tests, put some incredibly small fonts, put some black and white stuff on, took an XKCD comment, stuck it on comic and stuck it on there, just to sort of see if we're even in the right zone in terms of UI standpoint. It seemed to be okay. And so then got to sketching, just drawing a lot of sketches of what the hardware might look like. After doing that, we had to do a lot of learning. You know, I hadn't really done a mobile phone before. It's not a thing that you know, you're trained to do in college. And so we went to a bunch of factories and looked at how they made keyboards for them, took apart existing keyboards, and did teardown analysis to figure out sort of what were the tricks and what were the strengths and weaknesses of a variety of keyboards from a variety of keyboard-based devices. And finally sort of synthesize that all together into sort of some realistic-ish 3D renderings that we could use to sort of talk about, are we getting there? Is this device thin enough? Is it going to be, is it the right size? You know, there's this sort of, a lot of people comment on this awkward bezel, you know, of availability on it, because we're so used to sort of bezel-less phones today. It's like a big thing in smartphones. It's like a fad, I guess. I don't know. But, you know, we don't have enough money to make a custom LCD display. And if we made the keyboard as narrow as this screen, you wouldn't be able to type on it. So there you go. That was like one of the design trade-offs we had to deal with. And so we played around with a lot of different renderings, to try and figure out what would go on. And then, you know, we went and made some hand feel prototypes. Once you've gone and thought about the design on the screen, there's no substitute when you're building consumer hardware to just, you know, build the real thing, hold it and use it, see how it feels, right? And that really helped inform a lot more of our, like, before we even got to the refinement stage of how everything packs in, we had these sort of hand feel prototypes and play around with different materials for the bezel and the design. And so the material science itself actually was a really difficult challenge in itself, because picking the right materials is very important. If you remember, this is a picture of an iPhone 6. If you guys remember the bend gate thing, where, you know, you could sit on an iPhone 6 and it would like bend and snap. They were using a certain alloy of aluminum, a 6000 series alloy of aluminum that had sort of some weak spots. And, you know, as now having designed phones and understanding design, you can see actually the weak point, and I can understand a bit, like, you know, the trade-offs they made and how this ended up being a thing, but, you know, people weren't happy with it. So you have to sort of go through now this material science exercise of sampling steel, brass, different alloys of aluminum, and comparing their strength, their finish, their durability, their availability, and price. So we sort of started this sort of continuous integration of materials into our design by essentially getting different swatches of material, hand them off to a really good CNC provider, and then creating versions of our case with various types of material. We could pick them up, feel them, abuse them, scratch them, test them for conductivity, throw them in ocean water, take them out, dry them off, do all these types of things, try and understand the material properties, because there's one thing to read a book, it's another thing to sort of just experience them. And so we iterated a lot until we finally arrived at a couple of materials that we think that meet our sort of requirements in terms of durability, good look and feel, and cost, most importantly. I mean, a lot of people ask me, like, why don't you use titanium? It's an obvious, great material to use. It costs like $1,000 for us to mill a case out because we'd scrap so many of them on the way to making a single one that would work or something like that. It's, there's some great materials out there, but they're just too hard to work with. And then we have to pick colors, which is really hard because everyone has a different opinion as to what looks good. And unfortunately, we don't have the budget. We don't have the budget to market to you like Apple does to make you think that this is the best color, because they're smart and they had good designers and they picked the right color, and you're dumb and therefore you should like what they did. And everyone has a different taste for what they want to do. We also don't have the budget to make 100 different colors and put them in the supply chain. I think we're going to have 2 types of colors, one for the omakase version and one for the regular version on this particular come out. So we're basically going with black because it's or a darkest shade of gray, which is it's a safe color. Most people are okay with it, but we're playing around with some things like different bezel formats or whatever it is. Like this sort of firm pattern on the bezel has been a little controversial. It's only one of those things where people either hate it. I'd say like 90% of people hate it, or you really love it. Like there's a certain group of people who are just, oh my god, I have to have that, right? So it's like it's very difficult to sort of get that line right. But at the end of the day, gadgets have transcended functionality. They really are a fashion statement these days. People buy things a lot in part because of the color they have and the feel they have and what they can show other people that they have about it. And so this is part of the process that we have to deal with now as hardware designers. We have to sort of acknowledge that the part of the HCI experience is the color and the feel and the look of a device. And so, yes, okay, I see that we're starting to run out of time already. I'll sort of push through this quickly. Then we get into sort of the mechanical engineering of the device itself. So this is the point at which we really start to get into the details, make sure we've got a budget for all the height of the components and that everything is put together correctly. We're starting to invest a lot more in terms of the drawings and delineating all the points. So there's sort of figuring out where to pack all the components into something that's only a few millimeters tall is a bit of a game of Tetris. A lot of trade-offs on the inside in terms of durability, assemblability. And one thing we didn't want to give up was the ability for this thing to be easily inspected. So we couldn't do that cheat of let's just use glue and hold it down, right? Because that's the thing that happens a lot in mobile phones today. We can lose a millimeter by just using glue because we don't have a screw anymore, or something like that. So we really had to sort of figure out how to pack everything in and still make it easy to take apart. And then from the electrical engineering side, we had to, put a lot of rules upon ourselves. Like, we wanted no component thicker than 1.5 millimeters, general component on the circuit board thicker than that, which means, the good news is from the mobile phone ecosystem, there's a lot of things that are already quite thin and small that meets our requirements, but we also had to think about the openness of the component. Was it easy enough to get? Was it easy enough to get the data sheets of it? Did it meet the functionality? Is this cost reasonable? Can we actually buy it? Is it unobtainium? Is it a thing that Apple's purchased only and will not sell to anyone else? Like this, these are all things that we had to deal with in terms of getting stuff to fit. And then finally, we had to bring it all together. There's a lot of attention to the details of the finishing touches. We have custom finish on our Torx screws, so I didn't want to use a hex head or a cross head Phillips because those things suck. They strip. They don't work well, in my opinion. We've had Torx screws for decades now. I don't understand we don't have them on everything. But they're hard to get, actually. The Torx screws are not common, so we had to find a vendor that would make them for us in the right size and get the right color on them so that we could go ahead and put them in the design instead of just using off-the-shelf crosshead screws. And then the edges of the case itself are done with what's called a diamond beveling. And so what we do is we actually, instead of machining and polishing it, we use a diamond bit that is so sharp that the cut of it is mirror finish in and of itself. So you get this nice sort of, you can see this sort of shine on the edge. It's a very subtle touch, but I kind of like these sorts of accents that don't stand in your face, but sort of give it a little bit of refinement, a little bit of something that's a little bit nicer to look at the end of the day. And we are going to ship a Torx screwdriver in the case with every single device because they are hard to find. So at the end of the day, we have a pocketable device with. I didn't read your mind. I read the comments. We have a pocketable device with no compromise on ease of inspection. So at the end of the day, we build a device that you can go in your pocket and you can actually take apart and inspect with the screwdriver. We put the screws in the front, and we've made it so that the cables come out in a reasonable fashion. You're not going to break anything. You take it apart and say, "Look, this is everything." Put it back together again, and then use it. So the idea is you can have a time of check to time of use loop that's very small. You don't have to always do it, but it's available to you. That's the idea. So precursor, that we try to embody those three principles I talked about earlier in our talk. We want to make it simple so you can verify it, a full system, so you're verifying the whole system, not just components, and we're empowering end users to verify and seal their hardware by publishing documentation, educating users, and giving them the source code to do these types of things. The current development status is that the hardware is production ready. We're ramping the supply chain as much as you can in a pandemic. It turns out that a confluence of things like huge amounts of economic stimulus going to people are buying a lot of chips now in the supply chain, plus the factories haven't really fully opened, plus Bitcoin is through the roof, so all the Bitcoiners are buying all the silicon. We're going to be a little behind schedule in terms of our ramp because we can't get the parts because there's so much competition right now for electronics in the supply chain. But that's my headache, not yours. I'm worrying. That's what keeps me up at night these days. The good news is from the software side, our OS, our full custom OS that we're working on it, which is written by Sean Zobs Cross, is coming together. We now have a minimum viable product shell chat app running on it. And just giving a quick shout out to the NLNet Foundation for giving us a grant, which allowed us to get to this point, quite far actually, to get us to the point of the crowdfunding without having to rely on all that continuous integration you saw of all the cases and all that design, all that stuff. That was pre-crowdfunding. We didn't do that after crowdfunding. That was before crowdfunding, and that was done in part thanks to this grant. And you can go to this website here, precursor.dev, to learn more about it. That's our crowdfunding site. We also have a GitHub repo, which I think, you can see down here. If you want to actually look at the application and the OS for it, Sean was actually really insistent, and I think he's very right in doing this, in creating his operating system to be multi-platform. So Zeus actually can run on your desktop in this environment. It doesn't have all the security properties of it, but it has all the API calls, and you can start coding for your precursor today, even without having one. So you can go to our wiki, BeTrusted.io, which is our GitHub.com, our GitHub site. And you can visit the wiki and you can see the instructions for how to run our app. And this is an example of sort of our initial shell test. The idea is you type actually to your shell as you're chatting to it, and it comes back to you with what commands you have available, and it shows that we have emoji and Hansa already live inside of our OS, and those are things that we're working on. So these are things you can start playing with today, even before you get the hardware in your hand. And that's it. For the talk. I know that we were running a little behind schedule, so I tried to push things ahead a little bit. There was originally time for questions, but I'll leave it to Homfuk to see if we want to do that, or we just want to cut to the next talk and stay in schedule. So thanks everyone for tuning in, and yeah, I mean it was nice actually to have the comments on the side. It felt a little more interactive than just screaming into the void as I usually feel in the pandemic.
Okay, excellent. Thank you, Bunny. I'm taking over from here, and yeah, I'm happy to say that we have a few minutes for questions also, and we can just later on make up for it as we have some breaks. And I see the first question is from Roland. Roland, would you like to ask your question directly?
Yes, certainly. Apologies for the background noise. I'm sort of fascinated by the inspection of the screen in particular, but I know very little about chip layout. How much do I need to understand about chip layout to convince myself that the screen only contains what it's supposed to contain?
Okay, so the idea behind the screen, let me see if I can just very quickly get to, I think the slide should be easy to find. I'm almost there, am I? Oh no, it was later. I give up on the slide. Oh, here it is. The idea, actually, you don't have to understand anything about chip layout to understand what's in the screen, because what you're looking for is the lack of presence of the silicon chip, right? So the idea is that when you look at your screen, you could look at the transistors one by one. It's going to take a long time, and I don't think it's a very productive exercise because the transistors are so large. They're big enough that you can't really do anything with them other than drive the screen. It's packed full already. There's no place to you can hide another flip flop in there maybe. What are you going to do with one bit of information? Okay, maybe something, but it's not a lot. You're not. So and also there's another complication that we have a backlight on it, which keeps you from being able to put a high power light on the backside to look at it. So what you're really looking for is you're looking for the lack of this fleck of silicon on it. So if someone went ahead and put another extra piece of silicon on the glass, a little chip on glass thing like they do in most other LCDs, then you know that this is not the LCD you want to use, right? That's all you're looking for at the end of the day. It's a very binary 1 or 0 thing.
Got it. Thank you. Thank you.
Yep.
Thank you very much. And there's another question from Mr. Marco. Marco, would you like to ask your question?
Sure. Hello, Manny.
Hey.
So my question goes more like the target audience of this device. Do you think like the general public would and should be interested in something like this? And then do you think it makes sense to have a device like this when the general public will have other phone and will do the connections to the different banks and all those through a normal browser? Because this doesn't cover like everyone's day-to-day needs in terms of technology, right?
Right. Yeah. Would or should are different, very different answers. I don't think, I'm realistic. I don't think everyone's going to be clamoring for one of these from day one. I mean, obviously, this is a bit of an academic exercise almost in trying to figure out how do we build a device that even looks normal-ish and starts to satisfy some of these requirements. So I look at it more as a starting point. That's why it's called precursor. We're definitely not there yet. This is not going to be it. But I think it hopefully moves the goalpost many forward enough that we as a community can start figuring out how do we use this and how do we make it more mainstream? How do we get it into people's lives? I do think that, and also to be clear, I don't intend this device to replace your phone. There's a place for that complexity. That complexity gets us wonderful things like browsers and cats on the internet and these things that we just don't want to get rid of for the sake of security. And it doesn't matter if you look at cats on the internet because you usually get cats on the internet. But when we're going to do banking, you still also want to have the app on your phone to do banking, but you want a true second factor, right? You want to. I think what we're getting at, and unfortunately, this is the case for most security products, is that the general public feels they don't need it until it's too late, right? So the thing that will catalyze the popularity of devices like this is unfortunately going to be an incident that will affect a lot of people. And when they say, oh crap, like I thought my phone was trustable, but in fact, we all had some terrible situation happen and people clamor about it and why hasn't the industry solved this and why don't we get these types of things? And then finally, based on that demand, people may be more willing to have a second factor, or they may be looking for second factor situations. So, no, I don't think it's a thing that everyone's going to need from day one, but there are definitely people today who are not developers, but more users who have come to me and says, I definitely want one of these. Journalists who want to keep in touch with contacts. They want to keep very confidential, and they have state-level adversaries against them. Obviously, is a very small market, but I think is a very important market because it's important to get the truth out there. But then a slightly larger market that I am not terribly closely connected to myself, but I acknowledge it's a very lucrative market, is the crypto guys. Those guys, rely a lot on digital technology to hold increasingly large amounts of wealth, and so they have concerns about phishing and reliability and storage. And these people are willing, the types who are willing to carry a second device around, to have a wallet that secures some portion of their assets, right? Those types of people are not necessarily developers, but they are actually users who understand and would be willing to do it. And I think that as time goes on, we'll sort of gradually shift towards a slightly more mainstream application of this. And hopefully as time goes on, and if this project is successful, we'll have a V2 that's a little more powerful, that's a little more mainstream, has a little more connectivity on it, without compromising on simplicity, without compromising on trustability. Those are the big caveats, right? Because we don't want to just reinvent another mobile phone. I'm not going to just throw a bunch of crap on the inside and make it hard to verify and say, yep, we won. That's the really hard battle, is making sure that we hold true to our mission without while still serving the general public.
And there's a final question from Juan. Juan, would you like to ask your question? I activated your microphone.
All right. So how do you plan to, hi Bonin, how do you plan to develop and get the people in the software community involved in the software firmware apps development? And do you think the phone should have some sort of capability to auto update? And why do you decide to start OS from scratch? In other words, what's your strongest argument for writing the OS from scratch?
Okay.
How do you make the trade-off?
Yeah, it's those are a series of hard questions there. I'll start with the last one. There's the honest answer and there's the technical answer. The honest answer is we wanted to write an OS from scratch, right? Fundamentally it was an itch to scratch. But the more technical answer to it is that we wanted to build. The problem is a lot of the OSs today are too complicated and too hard to validate from the bottom up. And we also wanted to take advantage of the opportunity to rethink a lot of traditional things like POSIX file systems and ABIs and all these interfaces. That we carry a lot of legacy garbage along with us that actually inflates the size of our OSs and makes them more complex. And so we have an opportunity to build a file system that is well suited towards systems with virtual memory and flash and these types of things. It gets rid of a lot of legacy stuff. And so we're looking at, taking advantage of the fact that we're writing the OS from the bottom, picking up every piece we put in, thinking about it, and being like, do we really need that? Can we shave off this piece, do that? Can we fit it in? Can we keep it in a small code size, right? And so one of the debates we have routinely inside is like, we say we could solve that problem with a new syscall. We're like, do we really need a new syscall? Do we really have to add this? Can we remove a syscall if we add one? Like for me, it's actually a big win when we manage to remove lines of code from the OS because it makes it more inspectable and more maintainable. And so I hope we can keep that spirit alive as we grow the OS and grow the community and get people more involved in it. But that's a very big priority, is to make it so that an average person, an average coder, I should say, could pick up the OS, read our documentation within a day, this is the boot instruction, and this is the path that it takes to get to running my application, and I believe it. Right? I have confidence that I haven't there was like a little weird scene change that happened that I didn't quite get, that went through a blob. Like that's kind of what it is today on OS, even if you spend like a month looking at these things. In terms of engaging the developer community, I'll be the first to admit I'm actually not great at community management. I'm more of a technical person, but I hope that we can do better at this. And we of course we publish everything on GitHub. We're trying really hard to add a lot of documentation out there. So I think I put on the wiki let's see, a link to our documentation here. If you actually visit that, we're really as on the fly as we go through every component. What I do after we get to a release, I go back and I write all the docs and I fix the docs. I'm trying not to like do all the docs at the end. We're trying to dynamically keep generating, keeping them up to date so people can follow on. And then we're doing this thing where you can, in hosted mode, start developing apps today. So you could go here, you could go to Zeus Core, and if you have Rust installed in your system, you can do cargo x task run, and it should just pop up this UI, and you should be able to be running our basic shell chat application. So developers today can start looking at it, poking at it, and getting a feel for it. It's different on hardware, obviously, because the performance is very different. And the hardware actually does, memory protection, and this doesn't do memory protection, all this sort of stuff. And a lot of the hardware features are only emulated with like fixed numbers, like the battery life is always going to be 50% because that's all we report, right? So it doesn't emulate a battery. But we're trying to find ways to improve and engage the community from an early basis. So it's early days from that standpoint. I think we're still about, unfortunately, several months away from shipping any hardware, so we have some time to figure this out. So if you have any ideas or feedback or people want to contribute, we're very open to the idea. We have an IRC channel which is listed somewhere in one of these slides here. You can pop in there. We're mostly there. I mean, you have to be looking at the screen to see the message. It doesn't come up on my phone or anything like that. Or you can open issues on GitHub. We try to be pretty responsive there. And so we really want to engage with people who are genuinely interested in developing and doing things. Doesn't mean we're always going to take your commits. We're going to be curative. We're going to be try to keep focused. And the answer a lot of times is if you want to do, like there's a big group of people who want SCL4 in it. Great. Love it. I want to see that on it, but that's not going to be our core effort. I think SCL4 is a potentially really interesting, powerful OS, has capabilities built into it. It has a lot of good ideas. It's mathematically provable, whatever it is, right? These are all wonderful properties, and I really hope, if the community ends up forking and doing their own thing, if everyone just really wants to run Linux on it, all right, whatever, you guys do it, right? It's open.
How about the auto update though? How do you really plan to fix something that is?
Yeah. Okay. Update. I personally dislike auto updates because you're just forcing code down someone's mouth, and I don't know what's in it. Half the time the auto updates interact with something and break something. So this might be more of a philosophical issue. I guess number one, I hope we have a code release standard that's high enough. We don't have to we don't rely on updates as like the way to be lazy. So I want updates to be rare. I want users to be in charge of accepting the update. And in terms of doing updates themselves, we do have, basically the entire kernel, the FPGA image itself, and the embedded controller image, all of these things run out of a flash ROM, which can be updated. So for example, the FPGA firmware itself, once it's loaded into the FPGA, sorry, my phone ringing, stop that. Once the FPGA has loaded its firmware itself, you can actually replace the FPGA image, and the next time you reboot it, you better have done it right, because otherwise you have a brick. But you can actually completely rewire FPGA. You can actually change, you can add instructions to your CPU on the fly in your device if you're careful about it, right? And so the process there would be, you would have an FPGA, it's running live in your system. You would download the FPGA binary, it's about 2 megabytes into RAM, validate it, make sure it's right, and you would then encrypt it to the keys on your device, which are unique to your device, and then write it into the slot of memory where the FPGA goes, right? And then at that point you can reboot it, and then the FPGA will decrypt itself from your root keys there inside of your device, right? So that would be the general path, but that would be a user thing. You would actually type, git update, do update, that type of thing. That would be my idea. I don't know if that answered your question, but it's not the most ergonomic update experience, but that's also partially my prejudice in that I don't like ergonomic update experiences. I want updates. I actually want them to be hard. They should be hard. And I find that developers who rely on auto updates tend to use it as a crutch to be like, just push it out, we'll update it later, right? Just whatever, right? Your release standard goes down as updates become easier inevitably inside projects, and it's almost like going to the gym. It's like I'm going to make it hard for us to do an update, which means that it's going to make it hard to push code, which means you have to do a better job. I don't know if it's the right idea to do it, but that's where we're initially angling towards. We'll see where we end up. I think I've burned a lot of time for someone else at this point in time. I'm sorry.
Okay, so we have planned with some breaks in between where we can make up with it. Yeah, but of course, like, thank you very much, Bunny. It's been a pleasure as always. And I always have the feeling that you say, "Oh, I don't know what to talk about," and so on. And at the end of your sessions, I just feel there's so much more we can talk about, and so much people want to know. And for the next time, maybe we should also think about an Ask Me Anything question. You just could give a short presentation, and I like people just asking more and more and really want to get into detail. So that would be a possibility, maybe.
Sure. Yeah. No, I mean, you're the one who suggested the topic for this, so it's good. I mean, like, it's the problem for me is I live in this little hole, like you're here in Singapore, and I don't know what people care about anymore, right? I'm just like, like today I'm going to go solder 5 circuit boards. That's what I'm excited about, right? And no one wants to know about that, right? That's boring.
Why not? And I always like your examples. I think at one point you gave the example, if we go out in a hawker stall and we eat something and we take out our device, right? So I really miss Singapore.
Well, I've been there and done that. I've been that guy in the hawker stall with like the wires, and everyone's walking by, and the uncles, like, you know, like the aunties looking at kind of a little scoldingly, what's this guy doing in the hawker stall? I don't want other people to have to do that.
Yeah, so thank you very much for this session and for sharing these nice examples. And of course, thank you very much for your work. It's very important, and we all appreciate it really very much and very deeply. So I hope you find some other interesting talks here at the event. We have OpenTap coming up. We have Eric Pan from Seed Studio coming up. A lot of interesting sessions. And awesome. On Tuesday, Greg Kroer-Hartman, the Linux kernel maintainer.
Oh, awesome. Nice.
Thank you very much for joining us. Have a good afternoon. And
you too.
Keep in touch. Thank
See
you.
you around. Yep, bye.
Bye-bye. Okay, so this was really inspiring, and we will gonna have to have a short break. But I see Jeff is already again getting started, so we will have to restart this room for technical reasons, and that means some of you might have to refresh the browser in a moment. And Jeff, I hope it's okay with you. We 2 to 3 minutes. We'll just have to restart the room in a moment, and then we are back here in this session. So thank you very much, everyone.
I think we end the class or whatever lah.
Good, excellent. So, yeah, I think you might have to upload your presentation again. I'm sorry about this.
No problem. I think, is it possible Brennan was going to upload it and we're just going to use it off one? Is that an issue?
Yeah, yeah. Because I think, Brennan, you just uploaded it, but we restarted the room, so, yeah.
Yeah, I think you need to give me a presenter, maybe?
You take presenter, I just made you a moderator. You have to just take the plus button and take it. But let me check, like, Brennan.
It's not there.
Well, I can also make a presenter. I just made a presenter.
Yeah,
Okay.
now I got it.
Excellent. So, so that's very good. Okay, please, yeah, let me know when you're ready.
All right, I think we're ready when you are, Mario.
Okay, excellent. So, hello everyone, and welcome to our next session. The title of the session is Going Open and in brackets source. So going open source in test and measurement, the future of TNM automation with OpenTap. So yeah, I'm very honored to have Brennan DiRenzo and Jeff Dreller here at the session, and I would like to introduce our speakers. So hello guys, where are you at the moment?
11 p.m. Saturday night here in California. So it's 11 p.m. somewhere for a beer, and I guess that's where I am.
Nice. Brennan?
I'm in Colorado, so it's Sunday morning for me now, 12:30 a.m.
Okay, excellent. So I would like to introduce you before we can hear about your insights. So Brennan DiRenzo, he's a software application engineer at Keysight Technology. And Brennan, you started your career as an intern at Agilent Technologies, which is now Keysight Technologies, and that was back in 2012. So you're serving in various roles in the test and measurement space over your career. Brennan is currently the automation product manager focusing on both Keysight's commercial automation tools, which is called Pathwave Test Automation, as well as the open source test sequencer OpenTap and the associated community and ecosystem. The OpenTap project is the first known open source project stewarded by Keysight, Agilent, Hewlett-Packard in the TNM lineage. And Brennan graduated from University of Colorado with a Bachelor in Science in Electrical, Computer, and Energy Engineering with a minor in Computer Science. And yeah, still living in Colorado, and that's where you are today. You enjoy hiking, camping, and fishing with his wife and dog. Very nice. Thank you very much for joining us. And then we have Jeff Dreller. Jeff is a biz development and planning responsible software. He's responsible for software programs at Keysight Technologies as well. And Jeff has been with Keysight and former Agilent for over 15 years, focusing in a number of different roles on test and measurement. And yeah, he is a director of Keysight Software Acceleration Team, focused on enabling customers and internal business units with valuable software infrastructure in the spaces of automation and here OpenTAP. And of course, also in cloud and analytics. So these topics are all connected. In addition, Jeff oversees the commercial automation program planning and business activities, and he was part of the team that took OpenTAP to open source in 2019, the first known open source project, as we heard already here by Keysight. And Jeff is passionate about both open source as well as inner source software, and has been an advocate of both internal and external to Keysight. Jeff graduated with an MSEE and a BSEE, focusing on computer architecture and robotics from the University of Southern California, where he also played for their ACH D2 ice hockey team. He's currently based in Santa Clara, California. Jeff, I'm sorry, I don't always know the abbreviations because I'm not a native speaker, but like I was thinking, but then there was no time to actually check with you. And what does it mean, MSEE? Is it like Master of Science in Electrical Engineering? I was thinking, but I wasn't sure. And what is ACHAD2, ice hockey team? What does these abbreviations stand for?
So MSEE, as you got it, is a Master's of Science in Electrical Engineering. So I did both my degrees at USC, and I happen to be a lifelong ice hockey player and got to play through university. I actually then coached the team, and I'm still general managing it in my spare time. So a lifelong hockey fan. ACHA is the American Collegiate Club Hockey Association. So it's not the NCAA level. It's one below that.
Okay, thank you very much for clearing that up. And now we can get into the topic, and I will hand over to you. Thank you very much for joining us.
Excellent. Well, thank you, Mario, and thanks everyone for attending today. We were really looking forward to the potential of doing the face-to-face, and so we have a large contingent of our team in Singapore, and in the future we'll be looking forward to the next ones where we actually are there in person. But today we're just going to talk a little bit about the transformation that we've gone through, and as the title says, going open source in test and measurement automation with our OpenTAP project. And as you've heard now twice in the intro bios, it's the first known open source project that we're aware of in the entire test and measurement lineage of HP through Agilent all the way into Keysight, and I'll explain what that means if you're not really familiar with the test and measurement industry. Obviously, it being our first project, probably not as much awareness in the space. Although for the PS Lab crew, I think you're going to find some really interesting stuff in here. For those who have heard PS Lab, there's a session that we have following that you should definitely stick around for, showing the two working together. So as mentioned, Brendan and I are really passionate about the project on the community evangelism side, awareness building. That's really what we're trying to push here and get more visibility to the project itself. And again, we have a vibrant and growing tech community around this in test and measurement, and look forward to more people joining. So why don't you go to the next slide there, Brendan? So a little bit of history. So if you're not familiar, many of you have probably heard the name Hewlett-Packard, or HP, obviously. But sometimes people haven't realized or understood that the original HP, Hewlett-Packard, back in 1939, founded in the garage on Addison Avenue in Palo Alto. It was really a test and measurement company. And that is effectively known as the birthplace of Silicon Valley. If you visit us today in the region, you can still drive over to Palo Alto. There's a nice plaque outside over on Addison Avenue in front of the garage, which still stands to this day. So it's a very cool historical aspect of technology in general around the world, spark of inspiration from Bill and Dave. And so for many, many years, definitely very much in a leadership position in the test and measurement space. It evolved, and in 1999, the T&M arm actually was spun off from HP, or Hewlett-Packard, into what was then known as Agilent Technologies. And over the years, Agilent, and that's at the time when I joined, and Brennan as well, over the years, we acquired other companies, including life sciences, and then it was determined in 2014 to spin off once again, and we formed as Keysight. So we keep getting punted out. I don't know why that keeps happening, but it's okay. We're doing very well right now, and it's again a pleasure to be kind of in the leadership position and fully focused on the test and measurement market. No distractions outside of T&M like life sciences or chemical analysis. Those were good businesses as well, but we're really focused directly on the test and measurement market. And in 2019, we continue to celebrate that. That's 80 years now of leadership in the test and measurement space. So we've been around for a while as a company. Our DNA is long and deep. And why is that important? Well, as we go into the next slide here, Brennan, in 80 years, as you've heard before, we've never launched an open source project. And so I'm going to walk you through a little bit of the journey of OpenTap and how that came about. And Brendan's going to take it on and show you where it's going. And again, we're just trying to really reach out to the vibrant open source communities around us. We've been at FOSSDEM now a couple times, first time at FOSSASIA, and we're seeing some really good opportunities for connection and collaboration. And so back in 2011, we had lots of internal needs, and this will come up again as to why we're doing this, what problem are we trying to solve. We had lots of internal needs for test automation. This was a core part of our various businesses, and the business I happened to be in was the wireless business. And we have a very cutting edge software research team located in northern Denmark in a city called Aalborg, and asked them to do a little bit of a project, see if they could optimize and simplify and really make it very scalable to do automation in the wireless market segment specifically. And that's market segment is testing handsets. So going back to Bunny's presentation just a few minutes ago, testing those kind of devices as they roll off the production line, doing the RF calibration and RF verification. So as we progress forward, we continue to use it with more and more chipset vendors. We created a whole program around it called our Silicon Vendor Program, and we were really engaged in kind of a very narrow slice. As we transformed into Keysight in 2014, that really took off. We had a summit actually in Singapore, and at our site there, and we decided, you know what, this was going to be the automation core for the rest of Keysight, for the rest of the company. Again, as Keysight spun out of Agilent, really focused in on test and measurement, it was really decided we need to transform from being a hardware-centric company toward a software-centric solutions company. And TAP at the time was very much a piece of helping create many unique and cool and valuable solutions to our customers. And so we continue to push that forward. And ultimately, through kind of a big meeting in a boardroom, battle royale of different options, we ultimately came about to decide on TAP being the platform going forward. So 2016, we launched it as a commercial product, started getting a lot of traction with customers because we had already been using it for many years and kind of in bespoke commercial deals. And then like into the 2016 later era, we got a unique question. We got a unique question from Nokia. Many of you know them as the handset vendor. That's really no longer, I think maybe they licensed it out and it still exists, but the true essence of the original Nokia, the handset team is no more. But the base station team is a market leader in network infrastructure. And that team had a lot of pedigree and DNA and history from both automation, factory production, but really also open source. Nokia is definitely known as being very pro open source and driving certain communities forward. And so they pushed us, to take TAP at the time open source. And our first question was, as you would expect, a big company, it's $4 billion in revenue and like 20,000 people. Everybody's going to say, wait, you're crazy. You're giving away your valuable IP and software for free. And that's what we thought, honestly. So it was a scary moment for us when our customer at the time asked us, hey, give us all your stuff open. And we really didn't know what that we didn't know what that meant. So we went back and we started asking questions, reaching out, connected in with the Linux forum, tried to learn as much as we could about open source and the ways and the models that a commercial company could be engaged in it successfully and continue to invest. Attended the Linux Foundation Open Source Leadership Summit, met a lot of great contacts, and really started thinking, wow, there is an opportunity here. You know, the core sequencer that we're talking about so much here, and you'll see in the architecture, it's valuable, but it is commodity in a way. And we checked internally, and we had 15 years before, our own manufacturing team, one manufacturing team in one company had multiples of tens of various sequencers in one production center. And how does that come about? Well, it comes about because everybody creates their own. There's not invented here. There's the fact that sequencers are quite simple when you start, and so somebody can create one over the course of a weekend. A really good programmer can, or maybe even not a good programmer. And so as these proliferate and teams don't talk, then this causes such a problem. And it wasn't just our problem, but we saw this in every one of our customers and community members and engaged parties around the world. And so we realized that there was a problem here, and even one inside our own company. And so continued forward, worked with Nokia to understand really what value we could provide them, and ultimately decided that yes, we would take this forward. On that journey there in 2017, they brought us into the InterSource Commons event. Actually, they hosted in Naperville, Illinois, at one of the Nokia original Bell Labs sites, and really continued on that journey of driving things forward, even understanding the term InterSource, which we just thought meant sharing code internally, be inside open source, and that was just a thing everybody did. Turns out nobody was doing that in our company. Everything was siloed. People were hiding their code and not sharing it, and innovation was stifled. And when we started doing that, the traction just picked up by orders of magnitude inside Keysight at the time. And we realized, wow, there's real power and potential here. We can provide our own unique value in other ways, but let's take this forward and let's open this up. So in 2019, we took it open source. That was a scary and exciting moment all at the same time. It takes a lot of convincing, again, in a commercial company of our size that hasn't done this before, but we started gaining momentum. People started seeing the value, and even some of our executives started coming in from outside companies that had experience in open source, and that paves a lot of the way for you. That really does help. And so we were at FOSSDEM in 2020. Later in 2020, we launched a forum, which was one of the mistakes, I'll say, that we didn't do it sooner. You're always going to learn things, and we're still learning things today. That was the way to engage the community. And if you're interested, please join and engage us. That's where you see the activity now. But that was something that we just launched back in December, and it's really starting to move forward. And then obviously we're here today at FOSSASIA, and there's much more to come. Brennan will talk about that shortly. But just really quickly to cue him up, kind of what were the things driving us to get here? What were the trends that we were seeing in the industry? And I'll highlight on three. And if you're familiar with TNM, you'll probably agree with these. There's probably more, but these are the big ones that are driving us these days. So one is, as I said before, we're seeing lots of internal tools proliferate and just drag teams down, slow them down to a crawl in their ability to innovate. They really want to create value to their companies, whether they're a big commercial company, whether they're a small startup, whether they're a hobbyist. People don't want to create the commodity. It's what we found is that when you do that, then it just drags you down like a boat anchor, because you've got to support it. If you're in a big company, you've got to maintain it. You've got to add basic features and capability that everybody else already has. So there's no value in that. So in the automation space, we really see OpenTap as being the core that everybody can use and leverage going forward, whether it's a Keysight or even one of Keysight's competitors, whether it's a hobbyist, whether it's a small startup company. There's really no need in the TNM space to create your own automation anymore. If it was commercial, that would be a problem, and that was a driving factor behind us deciding to open source that core up and just putting it out there, and we want the community to use it and leverage it. The other trend we're seeing, or the second one we're seeing, is being open and extensible. From the core, TAP was very scalable, so OpenTAP by default is going to be scalable. Just what you need, not taking the whole kitchen sink basically and shoving it down everybody's throat, but really allowing people to take the modules that they need and orchestrate them in a way. Being our team is from Denmark, we always like to think of the Lego metaphor, and we continue to use that to date. On the openness side, again, as we mentioned, open.
Sorry, Jeff.
Yep. Just unmuted there. Let me know if you can hear me again, Mario.
Yes, sorry, there was some background noise, so we had to mute everyone. And yeah, please go ahead. So thank you very much.
No worries. So again, scalable and extensible, but also again open, and that's not just the open source in the core, but the fact that the APIs are documented and open, and everybody can use and access them, so they can build unique value around them. They could choose. We're licensed under an MPL v2 license, so people can choose if they want to open their plugins or peripheral code or not. We're not going to infect people with the GPL, just because in an industry like the test and measurement industry, you're going to find a lot of players would be really nervous with that. A lot of IP lawyers would kind of shut that down pretty quickly, including our own if we were ever taking it. So we want both commercial and non-commercial entities to utilize the same capability. So that was the reason behind that. Finally, on the hardware differentiation front, and obviously we will continue to differentiate our own commercial hardware for its value and its uniqueness, again, with our deep DNA and lineage from the HP days. And that will continue, but hardware will always get squeezed for margin from a commercial perspective. And we're seeing software continue to differentiate. Right now, we're talking about automation. We're also seeing different areas on the cloud fronts, et cetera, where anybody can really create a lot of new value. And that's again, something we're really starting to transform and shift our company toward that software centricity. So this was really well aligned with that and with the markets going in that direction. So that's kind of the backstory. That's how we got to this point. Again, that sounded really, really easy, right? We just decided we wanted to go open source and everybody supported us. We just did it. Obviously not the case. And if anybody's trying to go open source, I mean, we're fresh kind of across that threshold. People like everybody at FOSSASIA, like at FOSSDEM, like at the Open Source Leadership Summit, they helped support us and give us the inspiration and the confidence to move forward. And we're happy to continue to pass that on to the open source and inner source communities. So if you're at that stage and you feel like your situation's similar to ours, please let us know. We'd be happy to share our experience and best practices and continue to have engagement. And I think I was looking at Bunny's profile while he was doing his Q&A there, because I have not met him or interfaced with him, but it seems like our paths could have an interesting intersection. And I think it says, don't contact me on LinkedIn, come have a beer. So with that, I'll say, come have a beer with us sometime. We are OpenTAP, and I'll hand it over to Brendan to show you what's in store for the future here.
Yeah, so Jeff kind of took us through, our history and how we got here, and now I'll talk a little bit about what we're kind of doing today and where we're looking to go moving forward. And with that, one of the big things that we're looking at is, ultimately what are the challenges that we're trying to solve here. Jeff kind of talked about some of the trends that we're seeing, but fundamentally when we're talking to customers and our end users, whether it's in the pure kind of open source purist community, or if it's in more of our sort of commercial traditional space of things, what is it that they're trying to achieve that ultimately OpenTAP is trying to help them with? And really, I think it comes down to three main pieces. One of them is time to market, right? That's always something that people are worried about. There's always a push to release faster, to release sooner. There's always going to be issues that occur and things that they run into. And so anything that we can do to help them with that is ultimately going to be beneficial. And so as we look at the different areas when they're coming to us, time to market is probably the major focus that they ultimately push on us. And kind of within that, you know, especially looking at a sequencer in general from an OpenTAP sense, that the question that we always get is around performance and test speed, right? And that's something that we really put a lot of focus in. Even though this is an open source component, it can't sacrifice on performance ultimately. It has to be just as good as a commercial tool or other internally developed tools. That's how we're going to replace those ultimately. We can't be you know, just having something that's free and open source and thinking that's good enough. It ultimately has to have the performance around it as well for people to truly use it, because ultimately they have a job that they need to accomplish, and they can't just, you know, mess with something early that's not really ready. It needs to be ready for full production. This is used in, you know, large manufacturing lines in all different industries of the world, and it needs to have that overall test performance to be there. And then another major issue that always comes up is, you know, we're talking about companies that have existed for many years. Within Keysight, as Jeff mentioned, you know, we have a 80-year history of writing tests and developing products, and many of our customers have that history as well, right? And so they don't have the ability to throw everything out and start over. They need to be able to integrate with existing stuff, integrating with new technologies coming in the future, and not be kind of forced into a strict model of everything. They can't you know, throw everything away and start over and build on our platform. They need to be able to leverage what they have and integrate with our platform to be able to ultimately provide them the benefits that they need. And so how did we accomplish that ultimately, and what is it that we're kind of delivering? This is just a high-level overview of things. In about an hour after this, there's a deeper dive technical tutorial that we have that will really get you a deeper understanding of developing on the platform and what it looks like and how to build everything out. But this is just kind of high-level overview of things. And basically, what we have is at the bottom here is the OpenTAP sequencer engine, and this is the kind of open source piece that we ultimately have created. And then we have this plugin architecture around everything, and this is kind of a combination of things that get created by Keysight, things that get created by our customers, our partners, and get built out to create an overall solution. And so there's a couple main components within that. One is what we call DUT plugins, which is basically the device that you're testing. So you'll create a plugin to be able to interface to that device, whether it's, you know, a COM interface, SSH, TCP, whatever it happens to be. As long as there's an API for it, ultimately we can connect to it. And then you have what we call instrument plugins, and basically this is sort of, you know, Keysight specialty, right? This is the test equipment that you're going to be controlling, the measurement equipment, whether it's power supplies or signal analyzers and signal generators, network analyzers, whatever it happens to be. Again, anything with an API we can ultimately have a plugin for. And this is kind of where Keysight has a lot of their focus, is creating these plugins that bridge the gap between the sequencer and then the physical equipment that we sell ultimately. And then kind of one of the other fundamental pieces is what we call a result listener. This is basically what is in charge of handling the data. So as you're running tests, this will parse the data, filter it, format it, write it to a database, send it to a CSV file, ultimately any data format, any type of data storage, you can create a result listener for to handle the data. Then kind of building up from there, you create what we call test steps. So basically these are your kind of test functions, the specific measurements that you're doing, you know, putting the device in a particular state, calling a measurement on an instrument, kind of bundles that larger communication with settings that an end user would potentially pass in to do specific functions. And then kind of the next step up from there is what we call a test plan. This is basically a sequence of your test steps. So you can have kind of just a flat sequence of multiple steps. You can do sweeping, you can do conditional branching, you can do you know, if statements, different types of things to kind of sequence through all of your steps in the full kind of automated way. Basically, that's ultimately what we're trying to do here, right? Is actually automate all of our test sequences. versus kind of the manual state of things. And then kind of the top level ultimately is a user interface. We have what we call the editor, which there is a free community edition for, and then also a commercial version that Keysight sells. But an end user could also build a custom user interface on top of this because, again, OpenTAP is completely open source. The platform can easily be extended for these lower level plugins, but also the higher level interfaces as well. So this is kind of the solution ultimately that we see people building. And why we've kind of had a lot of success with this model is that because of the plugin architecture, it allows for one to have a common platform. That's really one of the bigger issues that we've seen, right? Is that, as Jeff mentioned, even within Keysight, we had 10, 20 different sequencers that were created. None of them work together. None of the teams work together. None of them talk to each other. So there was a lot of replication and duplication that was getting created. And that's even exponential outside of our company, right? That no one's talking to each other. Everyone's doing the same thing over and over again. And so this really provides that standardized platform. And then we can add the value on top of it by, being able to leverage, instrument plugins, different result listeners, different types of steps. Ultimately, the devices that are being tested are going to be kind of custom and proprietary to whoever's running those tests, but they can grab an existing instrument plugin that knows nothing about their device and still be able to interface all of them. So the architecture is really the big piece of everything that allows this to tie all together. And so if you're interested, and hopefully you are, in about an hour, we'll have a couple other people from our team and actually some university students that will have a tutorial of building a solution out. And it's actually using the PS Lab board, if you're familiar with that, and our open source Python plugin, which is another interface that we have into the OpenTAP sequencer. So it'll be kind of a full open source solution from the software to hardware. And so kind of now that we've kind of achieved the main just open sourcing component of things, we don't feel like we're done, right? There's more to it than just getting your lawyers to sign off saying it's okay to open source this. You need to be able to do multiple different things to ultimately truly be successful. And so we're kind of focusing on growing in a couple main areas. One of them is building the community. So we're doing that by sponsoring events like FOSSASIA and meeting new people and engaging with people. We're creating a couple different things to help reach out to people that may be interested, which is our newsletter, our forum. We have different sets of YouTube videos. We have a new blog and news page. So there's a lot kind of going on that will be able to actively reach out to people versus just giving them the code and hoping they can figure everything out. And so that's kind of a big step that we're taking. I posted the links in the chat for most of those things. If you guys want to sign up, it would be great. We're not going to bombard you with stuff on the newsletter side of things. It's more or less a quarterly newsletter. So hopefully it's at a good cadence where it's useful, but not overbearing and filling up your email box with things. The other kind of set of things that we're really working on is building out our portfolio of plugins. So like we said, that having the kind of standard platform is a big step, but then ultimately what we need is kind of the common portfolio of plugins that everyone can use and consume, right? So that a lot of those right now are coming from Keysight, but our hope is to help build out that community where they're creating these plugins, contributing them back. We have a few existing customers that have started contributing things back. We're hoping to kind of streamline that process, make it even easier to do. And then ultimately, that is really where we're going to see a lot of value, we think, where these kind of standard plugins can be used by everyone. So you're not building everything from scratch every time. And then the longer we go along this path, the less and less you're actually building from scratch. You're really focusing on adding your true innovation, everything that's specific to what you're trying to do, not something that someone has already done, once or 100 times before. And kind of related to that, the other aspect that we're trying to build out is our contributors. As I said, right now, a lot of the actual contributors are from Keysight. We have a few different companies that have signed our contributor license agreement. PS Lab is part of that as of now, and there's a few other ones. Nokia, as Jeff was mentioning, was kind of the major initial kind of big company. We have various other ones. They're all listed on our website, and we're hoping to build that out as we move forward to really show the overall kind of benefit from not just Keysight, but to the entire test and measurement community. And so with that, these are kind of the big things that we're hoping, will help you guys and us ultimately. So we have our forum, as we mentioned. This is where kind of all the engagement goes on for technical questions, and anything else is all posted on this forum. We have our newsletter that we just launched. So if you can sign up for that, you'll be able to kind of keep up to date with everything. You won't have to go to, reach out for. We can tell you when things are coming and provide updates and give you kind of an overall summary of what's happened over the last quarter, essentially. And then kind of the main landing page is at opentap.io. This is where you can link to the forum, the news, the blog, our GitLab page where all the code is hosted as well as the plugins themselves. And so anything that you can do, you can basically get to from the OpenTap page. And then kind of the last thing with all of this is, I mentioned a few times, but we have a tutorial coming up in about an hour that will do kind of a deeper technical dive on all of this. So we gave you the high level overview of why we did this and kind of the journey, but to kind of get your hands dirty and really see some of the stuff in action, we have a live tutorial as well that's taking the OpenTap sequencer engine, our Python plugin, and then the PS Lab board, connecting it all together, building out those instrument plugins, the test steps, the test plans that I was talking about in the architecture picture. So hopefully you guys found this talk interesting enough that you'll join us again in an hour for the next one. But yeah, I think that's ultimately all that we had. So I think I'll open up for questions from there.
Okay, thank you very much. And yeah, I think people are also preparing already for your tutorial workshop. But there is one question here from Roland. Roland, would you like to ask the question yourself?
Yes, sure. So I've just noticed you in the last 2 minutes, actually, your CLA. But I wanted to understand, you're thinking about including or carrying drivers for competitors' equipment in your code tree. So, for example, not so much that a competitor will do it, although they might, but if I, as the owner of a Rigol spectrum analyzer, were to develop a driver and send you a pull request, would you be inclined to accept it?
Yeah, so I'll answer first, and maybe I'll let Jeff give some more detail because we've actually had some of this happen before. But so part of it is ultimately things like that they wouldn't be in the core of OpenTap, right? They would be in a plugin. So actually, we wouldn't even be managing that. So we don't really even have control of saying no, actually. So if someone wanted to do it, they can contribute that plugin, and even if we wanted to say no, we would not be able to. But
so
ultimately,
surely you control your own tree.
Well,
if I send you a pull request, you by definition decide whether you accept it or you don't.
Sure. Yeah. So, but for something like controlling a specific device, that actually doesn't end up in the OpenTap core. That ends up in a plugin, which is a separate component, basically. So they actually all have their own individual repos ultimately, and they're managed independently. There's not like a conglomerate of every possible thing. There's a core repo for OpenTap, the sequencer engine, and there's individual repositories for different plugins. So whether that's for particular devices or particular instruments or a collection of those, those are all separate actually. We have a GitLab page where we kind of collect everything and kind of try to organize things and make it easy to find. but they're actually in separate repos. But I think more specific to your question, independent of the architecture, that's very much something that we would support, and it's something that we recognize is, to really be, ultimately our goal is to be a de facto standard in the industry, and for that to happen, we need to support competitive products, and particularly within our industry, there's from our companies that we work with, they're generally not only using Keysight hardware to begin with, so we have to be able to support those. That's a lot of the reason that companies ultimately go, and create their own internal tools anyways, because they feel like something coming from a commercial customer is going to lock them into their hardware, right? And we very intentionally have an open structure that wouldn't that doesn't lock them in. The whole point is that they'd be able to connect to any device that they wanted ultimately.
Yeah, I think Brandon, you kind of got to the crux of it. Is the core itself doesn't interface with the hardware, et cetera. So that would be in a plugin. Those plugins can be created by anybody, and as Brendan indicated, that interface is documented and open, and there's no way for us to prevent it. But even if there was, we're fully supportive of people created plugins. Actually, some of our customers have actually created competitive plugins, as Brendan said. They're not using 100% Keysight, and then they've open sourced those onto the core project repos. So there's different project spaces that people can go in and create those. Probably more valuable in the test and measurement industry. I don't think as many people are going to be going hard into the source code itself, but they would want to see the plugins exist, the binary form of that. And if you go to the OpenTap.io package repo, we'll be allowing anybody to load up, and as long as they acknowledge that they are the authority and have copyright or permission to host those, then we can have them hosted and put up onto the web page. So that's whether it's competitor, hobbyist, commercial company, customer, whatever. Anybody's free and welcome to do so.
I think these legal questions are never easy. And yeah, possibly a lot of questions. And yeah, so the question is always like, which contribution to accept and which not, and what are what's the process and how does it work? And I think there's also some time later on after the tutorial, and you will be around and also be able to go into more detail than with the questions that people have. Yeah.
Yeah, and if people still have continued questions, please feel free to take them to the forum on OpenTap, and definitely happy to engage everybody. Continued on when it's not 2 in Colorado, or 3 in because it's daylight savings time this weekend actually. So
I'm about to lose an hour.
But thank you guys for the attention and the questions, and again, really hope that you stick around for an hour for the PS Lab integration demo that's soon coming.
Yeah.
Okay, so claps to you. Thank you very much for this presentation. And I have to say, it's a dream coming true. Yeah, because like how many years are we talking about this? All layers have to be free and open. And yeah, I mean, we understand there are always like details and questions about policies and about merging and about development and so on. But I think the approach that you are taking is really exciting for a lot of people. And yeah, I'm really happy that we start to have a cooperation more closely also with the FOSSASIA community and with the Pocket Science Lab project. So thank you very much for joining us, and we see more from OpenTap and both of you in a little bit. Thank you.
Cheers.
Thanks, everybody.
Cheers. Okay, so and now we will start in a moment with a presentation of Eric. Yeah, and Eric, you are here already, and I would like to test your microphone and your image before we get into your session. Eric, I need to promote Eric to the moderator, but I see Eric, yeah, okay, here we go. Here we go. So Eric, you need to switch on your microphone still, and I already made you to a presenter.
Hi, Mario.
Yes, hello, excellent. Okay. Yeah. So are you able to switch on the camera also?
Yeah, working on it.
And do you have slides? You can upload the slides here. There's a plus icon. Okay. So you're already all set. Okay, excellent. Then then I will just like share a few details about you first. And okay, excellent. So thank you everyone for joining this session. This is now the official start of this session, how open ecosystem empowers developers to digitalize industry. And the speaker is no other than Eric Pan, founder and CEO of Seed Studio. Welcome, Eric, and thank you very much for joining us.
Thank you, Mario, and hi everyone. It's been too long that we cannot meet each other. I see so many old friends in the attendees, and I'm very looking forward to share today. Yeah.
So
just
I would like to give a short introduction.
Okay.
Eric, so Eric is a maker and biker and founder of Seed Studio and Chai Hua X Factory. He's a producer of Maker Faire Shenzhen, and he's a believer in open source and crowd innovations. He endeavors to integrate the latest AI, IoT technology and supply chain resources to create an open platform for global developers to turn ideas into prototypes and solutions. His major effort is creating Seed since 2008 as a technology service company to provide open hardware and agile manufacturing services. Seed works closely with technology providers to offer an open, modular, and structured solution for IoT and AI. It also integrates the supply chain resources based in Shenzhen to help scale prototypes up to mass production, with all the works done to accelerate hardware.
Hello? Can you hear me?
So there was a short issue here with my connection, but I think it was just very short time, right?
Yeah, it's working now.
Okay, excellent. It's working. So Eric, actually, this mentioning of the biker, that you are a biker, right? I think there's also a bigger story to this, that like people in China and so on, they share that you like you worked in Silicon Valley, you worked in US, you had different jobs, and then you came back to China and you didn't know like what would be the next steps in your life, and you decided at one point to go around by bicycle in China, and then you arrived in Shenzhen and you thought, okay, that's kind of the future. We can connect like all these open source communities and the ideas and passion for open source with the maker community and with the industry and all this hardware economy in Shenzhen. So I really like this story, and I really like this connection with a bike. Is that somehow true, like what I said? Is that a bit of the story?
Thank you, and thank you for mentioning it. And yes, that's true, but I was basically in China and cycling around. Like the journey continues. Like as of Seed, we have been spent 13 years. It's like feels the same as biking into uncertainty. It's a journey that nobody has ever done before, and it's remote, but you keep going, and it's wonderful.
Excellent. So thank you very much for joining us, and I will hand over to you and give the time to you. Thank you very much.
Thank you, Mario. Hi, everyone. This is Eric, and like I just said, I'm super excited to talk to you virtually, and looking forward to meet you very soon after the COVID. I'm glad things are coming down. So it's like a little more silent during the COVID. We have a lot of experiments going on. We move a lot into industries. So I like to share today is how open tech ecosystem really help old industries digitalize. So a short introduction of Seed. We started with something like the interactive modules, but now we are doing some, it's going very complex that we are doing more industrial stuff on the hardware. And there are some short of facts we have trying to summarize. We started by making open source hardware from 2008, and we have thousands of the scale. And last year we have shipped more than 2 million pieces of all kinds of hardware to global developers. And secondly, after we distributed these components, people come back to us asking for help for manufacture because we are based in Shenzhen. We have access to all the supply chains. And all the designs based on open source hardware are much easier for us to manage because they have shared supply chains. So we have been keep providing manufacturing services. We quite agile manufacture, even from a small like 10 pieces to all the way to mass scale manufacturers. And as the journey moves on for the last like 4 to 5 years, we have been doing a lot about industrial IoT. Like making a little bit of module is not enough to really survive in real scenarios. So we explore the requirements of the real industrial field needs. And we have a lot of research projects going all the way into real products. So for the last 30 years, we have been working with a lot of customers all over the world. And also we partner with from startups to big companies to bring the latest hardware technologies to people. So we are very much surrounded by open source, and we are true believer of open source. I try to summarize in a good way that how closed source is becoming more disrupted by open source. In the beginning, before 1990s, everything is almost closed sourced, from the infrastructure, software to chipsets to all the hardwares. But I think it's explosive after 2005. We have the first Arduino, we have all the maker movement, everybody's hugging it. And it's immigrating from open source software to open source hardware. And we are very glad we have been part of it from 2008. I've shared the pain of other developers because I make stuff myself and I cannot access the open source hardware. And whenever I made a prototype, I cannot bring all the way to commercialized or finished products easily. So I established Seed in 2008 and keep providing all kinds of hardware modules and worked with a lot of prominent partners. But as we look beyond from 2010 to as of today, there are more and more open source software is becoming dominant in cloud services. It has been dominant in a lot of edge computing as well, and a lot of more users, like tens of millions of people, knows Arduino, knows open source, and use Raspberry Pi to create their own devices. It's true. It's very confident for us. We see that open source is becoming more dominant, and we are very happy to be part of it with you. So whenever the FOSSASIA comes with the invitation, I think, okay, I gotta talk with the guys. A lot of new findings and observations we can share. And the most important thing I feel is that the people having more accessible technology, they become the new techsmiths. It's like blacksmiths or silversmiths. They are the tool maker. They are the technology bringer of our generations. But with the support of more open source devices, they can bring more digital transformation to old industries. And we are, for the last many years, we have been striving on this part. So first, let's look at the techsmiths, which probably means you and your friends around the community. We see a lot of device prototypes from the community. It's not only just okay, I light a LED with Arduino. It's people using the open tools, really trying to make some solutions. It's not a full set of infrastructure, but it's like a functional. It's a device with vertical knowledges, with a specific know-how from the creator to users alike. And we see people using the open tools to make the water quality sensoring. They use the voice interaction mirrors. They're making their own DJ equipments. They use it to predict the maintenance of the machines. We see a lot of open source devices. And a lot of these experiments, they are beyond traditional researchers. Like one of our users called Benjamin Cabby, he using multiple channel gas sensors to tell from different alcohol using machine learning on a microcontroller level computing. So whenever you make these technologies more accessible and the people are finding new ways to resolve their solutions, which is amazing. And I think the community, the TechSmiths is well beyond the education. They are going all the way into machine learning through everyday practice, through contests. It's happening everywhere. I think you all know well about that. But let's look at it in a big picture. I feel that digital transformation is very important because of its diversity of devices. If you look at the cloud infrastructure, it's basically multiplies. A few companies, a few giants provide the cloud service for the majority of the companies using them. And on the gateways, with a few big players, everybody's using them, it's like the niche. But when we go down to the things, you have too many diversity that you need to bring a new device into that. And it cannot be created by single companies. It cannot be created by Apple that satisfy all the hardware needs. It should be from everyone. So we see that's where the makers, the startups, the hardware developers should become the next TechSmiths. And we have created the makerspace in Shenzhen called Chaihuo. And for the last 80 years has becoming the best cap in Shenzhen. People come to Shenzhen looking for the hardware ecosystems to create their product. And we provide the basic tools, workspaces, and the network and supply chains. So I think Shenzhen is quite a unique place. The whole city is like a makerspace or incubator. And Chaihuo is becoming a ground for a lot of people coming in, and they don't come here with ordinary community needs. They come here with a purpose. They want to create something. They want to make a device. They want to make it for themselves, for their own industry, or they want to sell to the global needs. So we see a lot of people, they come here with more monetary purpose. They come here with a mission, and they fit into our understanding of TechSmiths. So for the next year, we have much less visitors, and we want to duplicate these dynamics. So we are making more training courses, teaching more people from a non-engineering background, how do they really use open source hardware to make their first prototype? How could they use IoT to resolve their own problems? How could they bring STEAM education into their neighborhoods? So we want to, enable more people to not only just explorations, but go all the way into a professional role of this making. And also last year we worked with the government. We asked the government what kind of public needs do you have that you should be opening up, inviting more startup or individuals to help you to resolve. So they talked a lot about the agricultural needs, about the the sustainabilities inside the cities. The government opened the issue, and we invited more people to create the solutions in 2 days workshop. And the feedback back to the government, then they can really look at that and inspire. If possible, they can talk to the team, then turn that into a feasible project. So on the people side, I think we have done a lot of in the beginning to encourage to promote the maker movement all over Shenzhen and China. And I think it's time for us to go from the possibility to productivity. We want to bring more trainings and members and all ready-to-use solutions to people all around the country and all over the world. So we don't need to create these solutions like individually in our sectors, but we can share the common know-hows, and the open tech can go from somewhere like the experts, and people can save the energy to deploy that in their neighborhoods. And so last year we suspended the Maker Faire because of the COVID, but this year, as the situation is getting much better, let's put a optimistic case that it's going to be free to travel in this fall. So we are pulling back the Maker Faire Shenzhen in 2021. It's going to happen in November in Shenzhen. So all of you are welcomed. I will send out the invitation soon. But I hope that to meet you guys personally and to share more about our possibilities in the industrial solutions and get things going. So secondly is about the devices. So we have been talking a lot about open source hardware from the day one of City Studio, but looking beyond, I feel there is no more needs about open devices. It's not a single hardware, it's more a hybrid of software, hardware, and open knowledges. So if we look at in the time channels, the open source hardware are oriented from open source software community. People create their first Arduino, they provide their first big board, and move all the way into a big wave for open source hardware creations. In 2010, we have the first Open Hardware Summit. And then the open source hardware goes into two directions, as we can see. First, we have more open source chipsets that be more available to the public. You can create open source chipsets with RISC-V instruction sets and make the chipsets easier than before. But that's not what we are going to talk about today. We are more interested in the open source devices, because the software people who has been the system integrator for new technologies for decades, they are afraid of open source hardware itself. They are more like interesting or more compatible with open source software and devices. So we see by making more hardware into devices will open more doors to system integrators. They are sitting into the digital transformation wave, and they can repurpose the device for their own usages. And it's not a fresh new. We see this as happening for many years. So I think one remarkable one is Safecast in 2011, when the Fukushima, the radiation leakage. People want to tell if the radiation is accurately reported in my area. They set up the equipments and share the data. And following the similar trends, we have Smart Citizen, who is doing the environment sensing in a more citizen way. We just heard the precursor sharing from Bani Huang to make your own mobile phones and mobile devices. And we have been doing a lot of devices from Ray Speaker, the Open AI speaker, and Open Ray phone, Ray servers. We are trying to make more devices. Now it's taking more shape. But the most challenging thing we have been trying to do is about industrial IoT, because fetching data was easier than before. You can have a very cheap and simple Wi-Fi module, connect to Arduino, and you can get a sensor data to your cloud services or to your app. But how do you get the real-time data in the field, like outdoors, in the farm fields, or in some harsh environment, in factories? So we spent about 3 years trying to wrestling with that. It's much more challenging, but we are very happy that we can get more real-time data from the extreme environments in real time. But to survive in real things, to share with you that we're doing a lot of tasks beyond our previous back capability, like waterproof at the beginning. Then we need to worry about the UV radiations, because you put something under sunlight for years, you need to worry how the case is really holding off. And also need to worry about the consistencies, because different devices, you not only to calibrate them, but you need to make sure they have the similar results in different temperatures, in different voltages environments. And also because we are doing the environmental sensings for weather station, we need to do the wind speed calibrations in real wind tunnels up to 60 meters per second. And of course, the different temperatures, humidities, and then you need to test in different environments about the long distance communication. This is just the beginning of a lot of stuff. If we are really bring the prototype into field, but we see that happening. And this last year we have the open source material station, which can tell you about the micro weather data from your locations. You can get the temperature, you can the licensing, wind speed, wind meters, etc. And it has been deployed, surprisingly, in a lot of smart city applications in China, and we are deploying in the farms in all over the world as well. But it's the hardware itself is not the device. It's just the beginning that you can get more data. But how do we go beyond to use that data with from data you have the information, you can really guide the activations to guide the operations. I think that's the key for the next stage. And we see a lot of people have the shared purposes. We talked about smart system, which is for the environment sensing. And we have helped the Microsoft research to bring the code jumper, which is for visually impaired kids. They cannot see, but they still should own the rights to do the programmings. And we have the tool for them to do that. American Printing House was the biggest printing service for blind people, and they are now reselling them. And we have been carrying Alpha Explorer, which is from a Spanish team from Ariel, to make a cheap alternative for spectrum analyzers. And it's also open for customizations. People repurpose it for antennas, for different spectrums, for AV, audio, remotely debugging, etc. And we have TraceFly, which was a drone, but we can really use for swarm autonomous drivings. And a lot of practical research has been happening on that. And we just released with B2 Doc, which was like a miniature of Boston Dynamics, can work on different domains. It's for education as a start, but we see the possibility that more accessible palm-sized robot dog. And this Nano with oscilloscope is also from the community, from a small team in Guangzhou. They want to, okay, let's just make an oscilloscope, but people can make their own firmware. And also Piper was like DIY laptop you can build from your Raspberry Pi and have all the courses to explore the physical computing. So we see from here that it's not only about a hardware, it's about the device that could be a replacement of your existing tools, but they can also create more new possibilities for the next step. So we are doing a lot of these years to help people to wrap up, because you design from open source, it's much easier to wrap up from the small batch. And we work with local supply chains to really deliver the production grade stuff. And let's talk about other industries. We were kind of too innovative for City Studio. We're always looking for new digital things that can really be revolutionized. But after many years, we realized that there is no new problems. All the challenges, they are from the older problems. All the industries, they are basically existed for hundreds or thousands of years. I think the key is how can we work with them to bring new solutions to the existing offerings. So cloud and edge, from the IT industry, they are really creating the frontier. They want to digitalize agriculture. They want to digitalize cities. They want to make everything smart. And we are very glad they are in the between. In the beginning, it was we take washing machine for example. The washing machine was traditional, but people keep adding new stuff into it. First, they have electricities, then people want automations to save more time. They want to tender to different textiles, so they have more intelligence inside. Now people feel that we need to connect with retail. We connected to more smart homes, so it's becoming more autonomous. But if we, as a technical background, we look inside, there's nothing big changing. It's about the connectivities, it's about the AI, it's about the computings that has been changing the little chip, the little hardware inside the device. So if we keep that route going, we can see a lot of projects really taking shape. Like we work with these real estate companies a lot, trying to digitalize their communities. For example, you can see the weather forecast from the TV station, but now you can have a microclimate forecast from your app. Because you live here, you care more about your microclimates. Also, the warehouse is having more real-time data about their temperature maintenance, about their energy efficiencies. So they are having the issues for many years. Now, through the open technology, their product managers, their project managers see they can talk with the open tech ecosystem and ask for the help, and also to leave out the contracts. We have been talking with big companies from Schneider's, Unilever, Vanco for these past few years, and I'm very convinced that this could create a lot of opportunities for us and for you to really bring the possibilities into productivity. And this list goes on, people need a new gateway for the solar energy systems. They want more computing on the premise. They want easier to manage the cold chain logistics on the move, but also to have the full data chain, even equipped with blockchains, and also to reminding of human beings, while they're driving, to make them sleepy stages more alerted. And also this moving into educations, which we work with different education bureaus to bring the latest technology offerings. It's not just a philosophy or concepts. It's a real gears that we used in the production environment. We teach people how to use them, how to understand the possibility, and get prepared. So time is short. Back into a nutshell, what CITI has been trying to do for last many years is our mission is to make the technology open for everyone. We want to become the hardware platform that enable more digital transformations. We work with tech providers to integrate their new tech into open source module. We work with the supply chain in China and globalized to provide agile manufacturing services. And now we are making more configurable solutions, more open devices to help the community to bring their latest solutions to their industries. So we are looking forward to more to work with you guys to create more solutions, and also to deploy the latest devices into your neighborhoods, into your vertical needs. So I think we don't have much time for real-time questions, but I will be happy to answer them later in the offline, in the online notes. And feel free to write me an email if you have more questions or any help needed. And also, we are opening for hirings to interns, no matter which country you are. We can work remotely together. So thank you so much for your time, and looking forward to initiate the conversations and bring more open tech to the ecosystem. Thank you.
Thank you very much. And yeah, we see a lot of people are actually already tweeting about your session here and announcing that Maker Faire is in November in Shenzhen again. So thank you very much for sharing these and all these interesting facts. And I see that there's a question from Harish, and I think for one question we have time. So Harish, would you like to ask your question?
Hello.
Sure. Yeah. Hi, Eric. Thanks for the talk. I'm just curious about I think I just saw the answer to that. RISC-V CPUs for any of the seed environment that you're sending up.
Mm-hmm.
Do you have any RISC-V CPUs solutions?
Yeah, we have providing it with Beagle board. It's called Beagle 5. We announced it in January, and it's going to be shipping in a few months very soon. And we'll keep having more open CPU along the way.
Great, thank you.
Yeah, glad you like it.
Okay, Eric, it's been a pleasure to have you here and at the event, and I can't wait to get back to your makerspace. Which we always like. We had some meetups there with your support last time. So thank you very much for that. And yeah, keep in touch. I think you shared the information and we can reach you everywhere. And I hope we can see more projects and corporations with Seed Studio. It's been a big supporter of open hardware for many years. So thumbs up. Yes, Harish is showing that. And thank you very much, Eric, for this talk. Have a nice day and see you soon. Bye-bye.
Thank you. Have a good day, everyone. Bye-bye. Stay safe.
Okay, so yeah, that was nice to have like a trip around the world from the US to China. China's in Shenzhen, that's where Seed Studio is based. By the way, it's the same time zone as Singapore, but we are moving now to Germany, to Robert Mies. Robert, are you there? I already saw you before. Please switch on your camera and your microphone. So I'm making you a presenter as well. Robert. Yeah, so we'll be starting in a moment with the next session. It's with Robert Mies from the TU Berlin. And yeah, there is a icon in the middle where you can switch on your microphone and then we can test and we'll start the session in a moment. So stay with us, we'll start in a moment.
All right. Can you hear me?
Yes, now we can hear you.
Okay. I'm sorry about this. I was in there. I managed it earlier. Now I had to come in
No
again.
worries. And do you have like slides that you want to upload?
I would do a screen share and then do the upload afterwards if it's okay.
Okay.
I don't mind to upload them at all. Okay, I have a problem with my webcam. One sec, I will do it again, yeah? I have to sign in again. Somehow it doesn't accept it.
Ah, okay, no problem. So, yeah.
I'm sorry about this. My camera really doesn't seem to be working now, which is a shame because it worked earlier.
Yeah, but are you able to share your screen, Robert?
Yeah, that should be fine.
By the way, sometimes what we see is some versions of Firefox seem to have an issue sometimes, while other versions of Firefox seem to be working. And sometimes it works if you switch on the webcam and then switch it off again and switch it on again. So yeah, technology is kind of magic, I guess. And the more you are inside the technology community, maybe the more you wonder yourself how things are implemented sometimes. But yeah, Big Blue Button has been a great tool for us, and it's great to plug it into Eventia. So Robert, we don't see your screen share yet. I hope you should have the rights. Thank you. Yeah, and for anyone else, just like as a reminder, we have here the shared notes that you see here on the left-hand side, that you can leave your questions. So we're collecting questions there because sometimes there's a lot going on in the chat, and on the shared notes you can see place for your questions that you can ask to the presenters. Okay, Robert, and thank you very much for joining us. And your sound is working, right? We can see activity on the screen, but we can't see the sound yet. The microphone is activated, but we can no longer hear you. So, so maybe it's actually your microphone. No, don't need to change that. Usually, it's your microphone. So it must be somewhere on your configurations, because a big blue button already is you activated your microphone here already. So, Robert, I would say, if it's okay for you, then we can try to move this session to the next session. So, I'm not able to hear you. Is anyone else able to hear Robert? Please let me know in the chat. Ah, now we have.
No, I can't hear him yet.
Okay. Good, yeah. Okay, so then...
I think you can join and leave the audio by pressing the phone button.
Yeah.
Can you hear me, Mario?
Yes, now we can hear you. Good.
Okay, I've just changed my setup completely, so I will try and share the screen again. I'm really sorry about this. And now my whole screen. Hello. Okay, can you also see my screen?
Yes, we can see your screen. We can hear you and we can see your screen.
Okay, and then the last thing, if at all possible, but we won't touch that one. But I think now that's what's happening.
Yes.
And I think you can see me now.
Yes, we can. Well, it was starting. I can't see you yet.
Okay, never mind. That's not so
clear, I guess. Just take in a moment. And yeah, Robert, I will introduce you.
Okay.
Yeah, thank you very much for joining us here today.
Happy to be here. Thank you for inviting me.
So Robert Mies is a research assistant at the TU Berlin, the Technische University of Berlin. And Robert Mies studied industrial engineering with a focus on mechanical engineering at the TU in Berlin here. And during this time, he has also gained practical experiences through a 3.5-year activity as a working student at Siemens Energy in Berlin. Since April 2016, Mr. Mies has been working as a research assistant at the Chair for Quality Science at the Institute for Machine Tools and Factory Management at the Technical University of Berlin. So welcome to this session here. And I have to say, like always these translations, I don't know if they're always correct, research assistant, because it sounds like a student position, but I know that you are very instrumental, for example, in the OpenNext project, and actually leading several areas and work packages in this project. So yeah, I wonder where we will upgrade the the names, how we call things in German, like right research assistant. I think like the translation seems a bit like, you know, not 100% aligned, but
no.
I think people understand. And I hand over to you. So thank you very much for joining us, Robert.
Yeah, thanks, Mario. This is an interesting comment, which I also feel the same way about. This reflects the university situation in Germany and I guess European-wide. We get not the same pay and titles for that reason. That is, let's say, in line with our activities that we're doing. So, like you said, I've initiated the project Open Next, and we are coordinating it at TU Berlin, which is also therefore my main responsibility as project management. I'm a research assistant or associate at the Technische Universität Berlin. I have been so for 5 years, and today here I'm presenting about the project Open Next. Our motto is to transform collaborative product creation. And I'm very happy to be here at the FOSSASIA Summit that you invited us, Mario, because you're part of the project Open Next. Of course, it makes sense for us to come here because of the PS Lab, to also give a wider context what we're doing with the PS Lab right now project. And yet again, yeah, I want to mention that this project has received funding from the European Union's Horizon 2020 Research and Innovation Program under grant agreement number 869984. So we are European funded for 3 years, and we are right now in the middle of it. So still way to go. The next 1.5 years will definitely be very exciting. And I want to say a bit that really my introduction is much shorter now, because Eric Pan has said already so many things about open source hardware just now in this great talk. Eric, if you're still listening, I think it's really nice how you brought in the idea of the TechSmith and how that leads to diversified devices or a higher diversity of devices by everyone for everyone. And I think these ideas are way ahead of time. I think the Shanzai model is really unique. And in Europe, let's say, we like to think of ourselves sometimes as being ahead, but I think that's we are also just at the beginning here of a great journey. So let me introduce you a little bit what I mean by that. So I have a small agenda. I want to talk not more than 10 minutes, and maybe we can have a bit of a discussion, Mario, if it's okay, and more deal with questions. So I feel that Eric gave all the background, but I mean, the thing is that what open source hardware does is, of course, just to reiterate it, it is hardware for which a free right of any use belongs to the general public and whose documentation is completely available and freely accessible on the internet. So this is from a definition of a German Dienstweg, which is a quasi-standard. Yeah, it's of course started a long time ago, the open source movement, and in the mid 2000s or early 2000s, it really transitioned into hardware with Arduino and other projects, and I think a Seed Studio actually being also heavily involved also from an early time. And now we see that even cars and other objects, yeah, I mean, many things that people can also produce themselves are being shared on the internet and developed in a collaborative way a lot of times. And this is new and this is exciting. And we are researchers, so why are we? How did we get there? Why would we be looking at this? Because existing theory doesn't really cover this, or it's not really. You can't really use it in this sphere. Yeah. So we need new theory in a way. Yeah. I have a background in industrial engineering, like you said, Mario, and I want to say a few things how we came to make this project and what this project is about, because it's somewhat engineering driven, but let's say maybe a new engineering. Yeah. So OpenNext focuses on encouraging and supporting small medium enterprises. This is very important. to unleash the potential of open hardware through engagement in collaborative open design of products and services together with Fab Labs and makerspaces. And I think the idea of the TechSmith that Eric mentioned is really strong, and we're trying to bring this in with Fab Labs and makerspaces, particularly in actions in the Open Next project, who work with companies or SMEs and take them into the open source development ecosystem. Yeah. And this is important because there is this maker economy as well, and makers can really bring in a lot of knowledge, but also they can activate together with the company consumers to work together with them. But the open source development ecosystem is much wider. It also involves education and research especially, and hopefully also public policy makers. There's an exclamation mark by chance behind it. Wake up, and we can also interest them. And there are many other actors, but what we are trying to do now is that there are really new collaborative design processes that have emerged here and are emerging further. So we're researching that, and there are new business models that have to be established and properly understood. And I think there is a lot already on the ground that's happening, but this is something we're studying also to understand it really and document it. There is a great need for ICT infrastructure and especially open source tools and open source tool chain for hardware development. I think is a great vision that the FOSSASIA and also the Open Tech series of events could maybe be a great platform to also interact on that. And I guess it's already doing that. And yeah, moreover, of course, prototyping and action, right? So they're products, they're not software. Open hardware deals with products, so prototyping and testing and getting to also understand what kind of documentation do we need, what are product success. In the end, we want to have open source hardware products, and they come together with services a lot of time, like I said earlier. So this is the background. And we have 4 simple project goals. We want a wider adoption of open source hardware. We want to enable Fab Labs to support companies, which is a very particular idea in this project. But we also provide IT solutions for open hardware development. And last but not least, we want to document all the journeys of overall 18 SMEs by the end of the project. PS Lab or OpenTech is one of the companies involved. So this is partly why we're here, because of this great partnership, which I really thank you for, Mario. It's been working very well for the last 1.5 years. But we have also 5 other company partners, and they're all small, medium enterprises, and they're very different actually. Yeah, and some of them are established, some of them are less established. So we're also dealing with startups that are focused on open hardware. And I want to say that who are really the target companies, we think SMEs are quite interesting because they have the flexibility and the interest a lot of times. And also they have a background where they actually can understand the needs better maybe of open hardware development, whereas corporates are having troubles to integrate open hardware development back into their structures. So that's where we see like the low-hanging fruits. And I also want to point towards an article of Lars Zimmermann from eFactory, who actually published this just on his blog a couple of weeks ago about activist companies, which I added to his own logo. He means social entrepreneurship, the common good economy, NGOs, the Make Sense network, which some of you may know or may not know, but it's pretty interesting, and many others. And all these can be activated for open hardware development, and this is a real mission. Yeah. So we have different pilots, and I just want to give 2 pilot examples in practice. So and also tell you a bit about the ICT solutions, just to give you a few samples of what we're doing in the project. So the first pilot example is the fiction or future factory, which is being repainted, as you see below. And this is about starting an open collaboration with Bach in Amsterdam, in Fiction Factory, who are now calling themselves Open Future Factory, and to make products or a product out of factory wood waste. Yeah. So the idea is that they started with open calls in October to hire a creative maker, and they formed different teams, yeah, community team, feedback team, business teams, and they're really involving consumers, makers, and clients with these teams. Yeah. So this is the screenshot is some weeks ago that I made it, or even months. Now it's even there has been much more activity. This is from the Wikifactory page, where anyone can join them. The second example is about co-creating models for the world's coolest sustainable and open source, I'm quoting, with Sticker and Underbrunn in Copenhagen. Yeah. So Sticker's last death is made from sustainable materials and designed to be upcycled. You see it in the photo. And I will, when I share the slides, you can also press on it and get to a great article describing this better. And there are free plugin slots that you can see on the end of the table, and they can hold a variety of desk accessories. And now the idea of this open collaborations is with designers and producers. These accessories will be created to fit the plugin slots. Yeah. So, but basically, there's a professional team. And they want everyone, yeah, lay people, but also people who have a few interesting experiences to come in, yeah. It's not just for producers and designers to join in, because you can have your own desk and you can put this at home in your own desk, and you can also tinker with it. So these are just two examples, and I think Mario, maybe in the Open Tech Summit soon I could talk about other examples. These were just, we have 3 industries. One is consumer electronics, one is eco-friendly mobility, and one is what I just showed you, build-to-order furniture. So, like, one of the goals is also to create ICT infrastructure in OpenNext, and so we have been doing so on a social product development platform, Wikifactory, which is another great partner of ours. And in Q1 20, there was a great effort by the second partner involved here heavily, leading this is the Fraunhofer IPK here in Berlin, and they've been making user stories of collaborative engineering needs for open hardware. And now they are developing 4 categories of platform features for interoperability, documentation and guidelines, community management, so to find skills and allocate them, and to collaborative production engineering. So these are very, let's say, clear MVPs that they've defined there, and I guess it would justify another presentation to give real details on that. But maybe we can just wait for while the year is progressing, and then we will have the open hardware tools, also some of them as open software, and others of these tools partly will also be implemented on the Wikifactory page. So just to give an outlook, so current dynamics really in our running 6 pilots in Netherlands, Denmark, and Germany are promising. We have a graph database also in progress I want to mention from the Fraunhofer IPK, together with the Wikimedia Foundation, that will connect open source hardware modules across different platforms. And this will also be, it's called the LOSH, yeah, LOSH, it's on GitHub under our project account. And yes, last but not least, yeah, I realize the time is over, so I thank you for your time and listening to me. And yeah, maybe we have still some time for 1 or 2 questions, Mario. I hope I didn't overstretch the time.
Okay, yes, sure. So thank you very much. These were quite a lot of details, and I see a question of Harish. Harish, would you like to ask your question?
Sure. My question has got to do with the fact that you mentioned DIN has got a standard for open source hardware. I'm actually very pleased to read that they actually did state it as a standard. Do you know if that has been made available to ISO or IETF so that it becomes a global standard as well? Thank you.
Yeah, great question. So we have been, or we're closely involved with the team, have been participating in it as well from the start to make this DIN spec. There have been some attempts with the IEEE, but their open source board was somehow the OSCOM, it was called, was discontinued, I believe. So they're reorganizing, and we're trying to keep in touch with them and have already pitched it to them. Or let's say the initiator of the DeanSpec startup was also in the OpenX project, Martin Heuer. I mean, I think this would be really the logical next step. The standard is available, open access, so they could see it themselves, but I guess we have to push for it, and we will.
Have you tried the IETF for that matter?
No, maybe it's something looking towards.
Okay,
ISO,
thanks.
ISO, by the way, ISO we find very complicated, but
yeah, no, I mean, my apologies for suggesting ISO. That's a painful organization to deal with. So I rather work with organizations that have got a clue. Even for that matter, W3C. If I don't know where the overlap will be, but anything that is open, that has their content and standards made publicly available for easy download, without having to pay for standards. So I think anything like that would be very useful. But DIN being part of the national body represented at ISO, they may have different challenges. So they may not be able to do that with to work with free standards bodies.
Yeah, no, totally agree. Yeah, I think we look in that direction. Great hint. Thank you, Harish.
Yeah, and I just want to also connect here Hong Fook, because she has been in discussion with the IEEE, and I think, Hong Fook, you're joining one of their organizations, so maybe that's something to align to. Do you have some information?
Yes, so I was just appointed last week to be on the Center Associate board for open source. Yeah, so I got the appointment last week.
Right.
So I'm also looking forward to work together with them in the future.
Yeah, this is great news. So actually, then you, Martin Heuer, and I, we should set up a call, I think, fairly soon about this. Great news.
Sure. I did not announce it yet because just got it last week. Yeah, but we definitely should connect.
Yeah. The good thing is we've already pitched it to them before this OSCOM board was dissolved. So yeah, I think we should be able to pitch this again and refer to it. Yeah.
Okay, excellent to see us having connections on many different levels. So, Robert, I think there are a lot of things and that we could talk about more. And we will be having events in the upcoming months that we can share through our networks dedicated on some of the topics. And I would like to invite you also to our discussion room here in the event. So if anyone has more questions and would connect, maybe check out the discussion room for the next few minutes, or are there other ways to contact you?
Yeah, actually, there's mainly my email account, I'm afraid. But really, you can also just call me on the phone. So the on our website and I think also on the slides, I will put my phone number, and it's put through right to my mobile. So I prefer, let's say that. Yeah, either write me an email and I set up a call, or just call me on my phone because I'm really happy to speak directly and make things concrete.
Okay, excellent. Or we can also use Big Blue Button now. So thank you very much again, and we appreciate that you shared insights to OpenNext and what's going on in Germany and the European Union and how we're making connections around the world. So then this session is over, and I will hand over to Mr. Marco Gutierrez.
All right. Hello, everybody. I hope you guys can hear me. All right. So next up, we have a bunch of people. So if you guys can start sharing your camera and testing microphones, hopefully I can pronounce all the names correctly. Kushik, Darwin, Ashton, Alex, and Ivan. Right, let me just. All right, I can see someone. Darwin. I can't hear you. Can you check your mic?
We can hear you fine.
Yeah. Okay. Oh, Harris can hear. Yeah. We can't hear you, Darwin. So if you can do the usual turn on and off. Thanks.
Can you hear me now, Marco?
Yep. Yep, we can hear you now.
So let me share my. I need to.
Let me find you here. I need to give you the rights for. You're going to be presenting, right?
Yeah, I'm going to be presenting.
Mm-hmm.
Can you also see me?
No, right now. Yeah,
no.
Now I can.
Can I have the ball to share the screen?
Just let me find you on the list.
All right.
Where are you? Oh yeah, I saw you. Yep. Should be able to share your screen now.
Extra.
Is the rest of the people joining now?
No,
yeah,
no,
you
no.
should
Yeah,
be.
no. Oh, yeah. Okay. Kaushik and the rest are not joining, but then I have their recordings, right?
Okay, perfect.
I want to
you should be able to share your screen in the bottom right next to the camera icon.
Next to the camera icon. I hope I have only shared external videos and
Oh, that's on the.
all right,
you're clicking on the actions, right?
Sorry. All right. Okay.
On it.
Yeah. Screen one. Right.
All right, so I'll start introduction. So Darwin is a research and development engineer at Keysight Technologies, and we're gonna learn how to build a test automation solution with OpenTAP by using a suite of fully open source components all the way down to the hardware. Yeah, please go ahead.
Okay. All right. Good evening, everybody. So let's just jump into the next slide. I think thanks, Marco, for introducing. And then you guys can just, this is my Twitter handler. If you need to reach me after this session, just go ahead and tweet me inside that. All right. And then I'm obligated also to introduce my teams. And Kaushik, senior R&D, software engineer. He's been working on the, or the lead engineer also for the Python SDK plugin for OpenTAP. And then we have 3 brilliant students from University of California, San Cruz, Ivan, Alex, and Ashton. So let's jump into the agenda. So what we are going to look into today is we're going to look briefly. I believe Brandon and Jeff has already gone through the introduction about OpenTAP. and also the architecture, but we're going to go through briefly, so set up the stage before we go into the tutorial itself, all right? And then we're going to look into how the 3 students engage into the OpenTab and which program they are through via the we call it as a CSSPP, which is called the Corporate Sponsor Senior Project Program. And then last, we're going to deep dive into the tutorial aspect. So what is OpenTab? So briefly, OpenTab is a project for open source test automation, test sequencer, right? And the main aim is actually to build a test sequencer which is scalable, using a scalable architecture based off 3 core ideals, which is simplicity, scalability, and speed. This goes from your development phase until the production. So time, as mentioned by Brandon, time to market is very important. So this is where the core of it, the OpenTab itself, based off these 3 ideal cores. And then OpenTab is actually built on top of C++, C#, all right? And it's a proven language. So on top of that, we have right now Python SDK plugin, which helps a lot of people, especially those fresh students, right? They have most of them has the first language is definitely be a Python. That's what been taught in university. So we are in a good start also. And the OpenTab are being used right now in hundreds of products and applications available, all right? And also the foundation of OpenTab is fast flexible automation solution. As I mentioned, it's now from the start to finish on the DVT till the manufacturing. So next, we're going to look into the architecture of it. All right, this is basically how I would just let me give you a pointer. That'd be better. All right, so we can see there is another OpenTab itself sits in the center. The engine sits in the center, and then the rest of the components are actually plugins, like plug and play, right? So the OpenTab can exist by itself, but then when we need a DUT, a device under test, we can create a new one. All right, we can create your own device. And then plug it to the open using the class. Either you extend the class or use this. All right. And then we also have a tester plugin, which is a tester is like as mentioned by Brandon, it's a kind of function. For example, let's imagine like you want to do a benchmark for your own PC, right? This is a simple example that, to give you an idea of it. All right. If you benchmark to your PC, you have to look into a few components, right? You need to look at CPU performance, you need to know your RAM read-write speed and so on, and then also storage. So test tab, you can look into like one test tab doing a CPU testing, another one is doing like a RAM. So all those comes into a group where we say this is a computer performance test, right? And the overall is called test plan. But the small individual part is the steps, all right? And then we also have the instrument plugin. You can create your own plugins. This is not tied to the OpenTab. It's a plugin, right? It's a plugin. So you have in the future there can be a lot of plugins comes, like a lot of new instruments. So in order to grow, in order to be flexible, the instrument plugin you can leverage the interface or the base class of instrument, and then create your own instruments on top of it. All right. And then we also have result listener. Right now, Keysight or the OpenTab has open source the CSV result listener, where you can take the results from the test plan and then create your and then output it into a CSV file. And then we also have a test log result listener, and a DB storage is one of them is a Postgres DB. All right, you can create your own result listeners by using maybe NoSQL, MongoDB, for example, or time series database. Sky's the limit. Your own ideas, whatever, how you want to do is depend on the project itself. All right, and then we have the user interface component as well. Right now, OpenTab comes with the CLI, the CLI mode UI interface, and also we have Keysight has its own editor, which is a UI based. That one is based on the community edition, but you are not bound to just use these two. You can create your own user interface. Maybe you can create like based off a web based, right? So sky's limit. Imagination is the best part, right? And then we're going to look into how OpenTab has been used across right now. So what you can see, there's 4 pictures here. This is just a samples, all right? But there are a lot of use cases. The one that on the top right, top left is actually a web UI automation. And then this one is the Wi-Fi 6 Plus positioner. testing, and then this is a cybersecurity penetration test, and the last is the robot arm in manufacturing. So all these kind of different range of fields of testing, right? OpenTab can be used. So this is a real like a strength of the OpenTab. It can be in a lot of more fields and stuff, right? It's not just a niche. It just sits on the certain niche field, right? So that's the power of the OpenTab. And then right now, let's go into the reasons why we have this student engagement in our on the OpenTab itself. So right now, Keysight has been partnered with the University of California, San Cruz, to create a course in the university itself, being used to spread across other universities, to introduce test and automation. So this course will be using the open source PS Lab board itself, where we have these oscilloscopes all in the board of the PS Lab. So that's to actually teach the new students about the test, measurement, and the test automation. And then the reason why we do it is actually when we have actually encountered when companies are looking to a new hire, right, new grads, one of the hardest aspects is finding the candidates that can apply the academic knowledge, theories that they have learned for the past 4+ years in the real world or the real industry applications, right? So, and then many expertise in a specific knowledge silos, but few have the real depth knowledge and that can able to extend to other expertise or other areas. In addition, that what we actually encountered is the field of test and measurements are not actually given a kind of like a important or interest like how other technology ecosystems are there. But the thing is, test and measurement should come together with other inventions, right? Because we cannot do invention and never do the testing. So how are we going to be use it properly, or how are we going to test the reliability of it, right? So all of these are very important. And what we Keysight see is actually a few key benefits of being in the test and doing the test and management is we effectively able to collaborate with the other team, all right? And we normally never work in a silo or individual, and we can able to extend our knowledge from our core responsibilities, all right? And as day by day, approaching, right, hardware and software, the gap is becoming lesser and lesser. So eventually, once you want to do something in hardware, you need to also do programming. So the OpenTab able to provide this for the students, and together with Keysight, we are building the course for the students so they can have this knowledge. All right. So this is to break the normal sentiments that right now they have under the test and measurement field. So right now, let's jump into the tutorial. I'll be sharing you guys the screen. Let me just hope right now we have got a base of understanding of OpenTab. And remember, try to remember again the architecture of OpenTab. We're able to go through it. We're going to today build an instrument based off, we're going to try to connect to use the PS Lab, and then make a specific class that able to control the oscilloscope in the PS Lab IO. And then try to make a measurement from that, and then look at the result and look at our result listeners. So how are we going to build all those steps? And the three engineers, there's three new students, brilliant students from University of California, will able to guide us through right now. And then please feel free to ask questions and also jot down questions, right? We are there to entertain. Share the new video. Can everybody see this? Oops. Can everybody see?
Yeah, Casey.
Yep,
All right.
okay.
and it should come set up settings on the right with the test plan in the middle. So you look to the left, going over test steps. We have multiple test steps we can use to test our hardware. Under PS Lab, what Alex talked about, we have our generate sine wave, we have our RMS voltage. Then if we move, we have our test plan. When we add these, they will generate and be available here in our test plan. And our test step settings is used to modify parameters we want to pass through those test steps. Our log panel is to view what is happening during the execution. And you will see information being printed here after you run the program. Now let's see how to create a test plan. The PS Lab sine wave generator states a spec of 100 to 5000 Hertz. We're going to be using the test steps that Alex built to test this specification. Okay. So first, we're going to add some instruments. Do that by clicking on Add New, the plus sign, and then we're going to add our waveform generator and our oscilloscope. Close, click on OK. Then we're going to go to the left side on test steps and add our generate sine wave, the RMS voltage, and we're going to go to flow control and add the parameter range. Move the parameter range just by clicking and dragging it to the top. Then I'm going to make the sine wave and the RMS voltage children of that. I'm clicking on both of them, just waiting till the sweep range is highlighted and just dropping it inside. You see this is completed on the left side of this diagram. This shows that these two steps are children of sweep range. To get rid of this little red icon, you can go to the left where it says frequency, click on the 3 bars, parameterize on parent. We're going to click on sweep range. And now we're basically going to edit the output of our graph and what we want it to start and stop at during our test step. Now let's start at 100 and then stop at 10,000. Now let's run the test plan and see what results we get. We can do this by clicking on the green arrow. When our test is completed, we can make our way up to Tools, Results Viewer, and from here, you see our x-axis as frequency, our y as voltage, and around 5000 Hertz, you see it start to drop. So you can see we have successfully tested the spec of the board. From looking at this results viewer, you can also do many things with changing the x and y axis, the chart type, so histogram. So now we successfully know how to create a test step and run it. We saw how to use OpenTap to create a Python plugin on our PS Lab board, and we saw how to install and set up the Community Edition.
Okay, so just a quick question. Anybody else still playing the video, the tutorial?
Watching and listening, yes. Got left behind fairly early.
All right. Okay.
I mean,
Then,
it's not. Sorry, that's not a critique of the.
Yeah.
That's not a critique of the tutorial. It's just that to do it realistically needs the ability to pause, and it's not viable during a live session. So that's fine.
You can watch it again because it's a recorded version as well. So I think I just continue first. All right. Okay. Currently, right now, I hope the whole development cycle. Sorry, the light is switched off. Back to dark mode. So so what I'm going to say is hope that the tutorial have given you a glimpse of the development cycle, how to develop, and the overall architecture, how the way the OpenTap engine reacts with, or how can be tied together. We can able to, how does it, like, actually it's all, as mentioned, it's not within the core, it's not tied together well. So it's like you can plug and play. So when it, based on your project requirement, like how we just did just now, all right, we can have multiple plugins, and then when that particular use case came in, we can just put the instrument in or the DUT in, and we can use our test steps. We can create multiple different test steps, and then create a new test plan out of it, and then it is all works well, but it's not tied like a super solid. So it's all plug and play method. All right, all is a dependency. And then if this overall session have triggered you your passion or interest, if you can go into this opentap.io, you can also scan the QR code over there. There is a documentation as well, a deep, even a better documentation, a document for user and also for developers, and how you can create your own packages out of it. All right, so even deeper. And then if you have any question, across before that, on the top side is what we can see is actually the OpenTap GitHub repo, GitLab repo. We publish our source code there. All right, and then if you have any questions while developing, and if you just have any questions, right, please do feel free, go to our OpenTap community forum. We'll be all there, and then you can also find the QR code, and also I think Brennan have shared the links to the both GitHub and also the OpenTap forum. I think that's the end of my, and if you have any questions, I'm here to answer as well.
All right, thank you very much, Darwin. Great tutorial.
Oh, thanks.
I think there's no questions on the share notes for now. Quick question: is the code that we just saw, is it available on a GitHub repo, or you guys plan to put it somewhere so people can follow up?
Put it, yes, definitely we can put it somewhere. But how do we publish the link for that repo? Is there any way we can publish it?
Yes, you can.
Oh. Let's see.
Okay, I think I'll publish it in the session post.
Yeah, you could also put it on the if you just meet the slides later, you can also put it there. But yeah, I guess
okay, definitely.
Yeah, that should be good. Yeah, perfect. Thank you very much.
Thank you.
All right. So we're on.
Sorry, I have a question, if I can still ask.
Mario. Mario has a question.
So,
all right.
Darwin, I just wondering, that was a bit fast. I mean, like, it was really compiled and step by step, but I think it is great that you're sharing this video. and then people can stop, right, and continue.
Yes.
But I'm also wondering if, like, were you based in Singapore, right?
Yes, based in Singapore.
So it would be cool maybe if we could work together with Hackerspace SG and organize a meetup. I don't know if that would be possible to do that workshop, for example, with people hands-on. The situation is improving step by step. Of course, we have to see how things progress. But this would be something that I could imagine to follow up, and possibly also we could organize at one point in the next few weeks something.
Yes, definitely. We would literally love to engage with the makerspace, and then and give a live talk. It will be better, like face to face with a small group. It will be lovely also.
Yeah.
We can organize a session like that.
Yeah, cool. And you're already talking with the right person, because Marco is aligning people there also. I guess it's a good contact, right?
Yes, definitely. We'll keep in touch, Marco.
Yeah, sure. Thanks
Thank
for your
you.
talk.
You're also based in Singapore, right?
Yeah, I'm also based in Singapore.
All right.
So
Okay.
yeah, let's keep in touch.
Yeah, keep in touch. Yep. See ya. Thank you.
Yeah.
Take care.
Thanks.
Bye.
All right. Oh, and our next talk, we also have 3 people. So Ulrich, Marcelo, and Lisa. If you guys can start getting ready. Oh, I see Ulrich. I think you'll be the one presenting, right? I think I'll give you presenter, right?
Yes.
There you
I have
go.
it pre-recorded. I will just add the link here, but
All right.
you have to kind of do the intro and then say get go, and then I will start, and then we are here live for the question. We have some little issues with one of our presenters. The situation here in Brazil is really, really bad. So bear with us a little bit, but I still think we have enough manpower here to answer your questions later.
Okay, great. Yeah, thank you very much for coming. Very excited for this talk. It looks very, very interesting. The Inspire ventilator sounds like a very interesting talk by Ulrich, Marcelo, and Lisa. So please, guys, you guys can go ahead and start. Thank you very much.
Good. So we will play our video, and then we are here live for you to answer the questions. So let me do that. We are currently all still stuck in Brazil, and things are actually not looking so well here. But in spite of all the challenges, I think we have achieved something quite remarkable that we would like to share here. We are kind of tired of what is going on. We have a lot of things to do. As we build ventilators, we have to deliver ventilators, but one of my colleagues will tell you soon a little bit more about that. So in theory, we should actually be stuck at this building here at the moment, but of course some of us are at home and only rarely we can access this building, but this is where the main research for this project and the main production for this project is going on. It's a CT building, the Centro Interdisciplinar de Tecnologias Interativas at the University of São Paulo campus. And so the 2 persons who are there, you can now see here in the video. So with me, there is also Marcelo. So Marcelo, if you can just kind of give us a little wave into the camera, and Lisa also kind of give a little wave here into the camera. Hello. And so I'm here in this project in my role as the Caninos Locus ambassador. I'm also, as you see, academically in this realm of working with hardware and software, but I got in touch with the people who work with the hardware producer, the Caninos Locus group here in Brazil. And so as you see, we have here 2 of the main heads who are working there. So you see here in the middle, Marcelo Zufo, who is one of the founders of the Caninos Locus group and is the project coordinator in this project we are presenting to you today, and also a professor at the electrical engineering department at the University of São Paulo. And then we have Lisa Costa-Tupiase, who is the Caninos Locus chief scientist, and she's also the research and development coordinator at LSI Tech in São Paulo in Brazil. So thank you for having both of you here. And so I've been already talking about Caninos Locus a lot of in this little start. And here you see kind of one of the first products coming out of Caninos Locus. Some of you who are active in the hardware scene might have heard of our Labrador here on the right-hand side. It's a single board computer, which is not only targeting makers, but also industry. And you see it is modular, so there's some great thought which went into there. And there has been a lot of focus on open hardware and open software in the design of this board. But there's also a microcontroller, that's the Pulgar or Flea that you see here on the left side, which also has its root in the Caninos Locus group. And both of these boards and the experience we have built up with these boards lead to the main and the core project we want to share here today in our presentation. I will now hand over to Marcelo, who is the real expert, and can you tell more about how the ventilator was created?
Okay, thank you, Uli. It's been a challenge for us working this project since the very early stages of the pandemic in 2020. In fact, our concerns about the pandemic started early in January, since we have a major tech conference in Las Vegas, CES. We have the IEEE conference in consumer technologies. And at that moment, experts, engineers, professors, scientists at this conference start to become aware and very concerned about the situation that started mainly in China. Many professors from China at that moment didn't attend the conference. So we come back to Brazil quite concerned, worried. We start to do early discussions. And then the first wave badly hit Europe and North America. And then that was very scary. We are really worried. And then by 15 March, professors at USP start to join together efforts to do something related to ventilators. At that moment, we had a global movement of people, makers, universities designing emergency ventilators. And we have been approached by Professor Raul Lima. Raul is an expert on lung physiological dynamics. So he was the guy who really understands how to design a ventilator from scratch. And that was the inventory that we had started on 19 March. So what is a mechanical ventilator? A ventilator is a kind of equipment that is the only resource that we have to treat COVID. Because COVID has a secondary condition that we call ARDS, acute respiratory distress syndrome. And the only way to treat this killing secondary condition is using ventilator. We should say that a significant amount of people that is dying from COVID worldwide, people are dying under this condition of being intubated using ventilators. So suddenly ventilators became a fundamental piece of hardware to treat people. And it's a very hard system to design. It's a very critical one because any failure, any bug can lead for the patient death. And worse than that, it's highly certified. Certification agencies across the globe, Europe, Asia, FDA in US, and Brazilian certification agencies are really, really careful about making this equipment available in society. In fact, in Brazil, like US, it is a crime that leads to 10 years in jail, the improper design, testing, and use of ventilators without certification. So considering this situation, we decided to build a ventilator that should be low cost for emergency situations. When we say emergency, is when we observe collapses, health system collapses. We need to consider contingent scenarios where ventilators are not fully available to everyone. And also, we should consider this pandemic economy that is similar to a wartime economy, where we have logistic pitfalls, material shortages, embargoes, politics, corruption, and all other associated problems that will block citizens having access to this equipment. So in our project from scratch, using very common and widely available maker technologies, laser cutters, 3D printers, and open source platforms, in less than 120 days, and Liza will properly talk more about that, we had designed more than 7 boards in several configurations because we're pursuing the certification, and also including requisites in real time. We basically said, we are flying, building the plane. But we are very fortunate because in around 100 days from scratch, we have a fully certified device. So which are our design assumptions? The first assumption that we have is that the ventilator will not have compressed air in remote and poorest areas of Brazil and South America. So Inspire is a ventilator that can generate compressed air by itself. We like to have a low-cost product, robust, biocompatible, very fast to manufacture, off-the-shelf components, easy maintenance, fully certified by our Ministry of Health, fully validated in terms of functionality, because, again, when we plug this ventilator on a human, that is, again, the only source of life for a given patient. If I would like to repeat, if the ventilator stops in few minutes, the patient will die immediately. We need to work on very hard operation conditions, 24-hour days for 15 days or more, and as much we can, but we need to observe the local regulation. We need to keep this project using open hardware and open project. So in our case, we did what we call a cyber-physical approach. We did an adaptation of what we call a manual resuscitator, or usually we call AMBU. AMBU is a closed artificial representation of the human's lung. So if we can have precise algorithms that can deliver exactly the amount of air and oxygen to the human's lung and remove CO2, we can keep life sustained and we can eventually cure the patient, because then we can observe what we call the lung's dynamic complexity. The concept that we had was very simple. We just have an AMBU compressed by a high precision digital step motor using micro steps, because again, the lung is very, very sensible. We have precise sensors, we have a touch screen, and that's it. Everything else is plastic, aluminum, and 3D printing parts. So here is our maturity level evolution from scratch in 15 March. By August, we had approval, and in October, we start fabrication distribution. We go through all certification steps, so we try it upon animals, pigs, and also we try it upon humans. We just complete another round of trial where we tested the ventilator again upon 40 patients in our clinical hospital. So here is the technical specs of version B that was certified. So we have independent buttons, we have 7-touch screen, we have on-off buttons. We can drive inspired by automotive batteries. Yes, you can grab the nearby truck or car, plug in the Inspire, and the Inspire will work for several hours. Minimum requirement using motorcycle batteries is 2 hours. At this moment, our team is embedding a new battery that can operate the ventilator for 8 hours. And Liza team need to adapt these functional requisites every day. Every day we have a new thing to modify. So that is version B. And then, based on our lessons, distributing ventilators around, especially with nurses, intensive care units across the whole country, we did version C. That is looks a bit more like an Apple iPhone. It's much more soft. We have round surfaces, and it's much easier to clean it. But we did more, and Liza will exploit that a bit better. But version C, we have Ethernet, Wi-Fi, Bluetooth, GPS, LoRaWAN, AGL7, and local AI support. So at this moment, we have distributed up to date 147 ventilators entirely in the whole Brazil. We joke that we are the 7th cavalry because we used to arrive when there is absolutely no another resource. Basically, the distribution that we show it to you here is the collapsed health system map of Brazil.
Thank you very much to you, Marcelo. I think when I first saw this project, I was so impressed, and I think there's so much knowledge in so short time reflected in there. And I can't wait to hear from Liza about the future and where this is going.
Yeah, the situation here in Brazil is really complicated now. And we are having this big pressure in order to deliver the ventilators as soon as possible. We could deliver already around 150, but we have plans to deliver 1,000. And our design team now is improving the production and test procedures in order to have shorter manufacturing time. But relating to the evolution of the project, we have a roadmap, and regarding the evolution of Paninos Locus program as well. We have been working in improving the system software reliability in many ways. One of our efforts, for example, is to simplify the software update mechanism what will help us to have this shorter production time and updating the system more easily. Regarding the hardware evolution, what we have now with our ventilator is a license from our health agency that is for emergency and transitory use. Next step is to apply for medical equipment class A that we can use in hospitals, and medical equipment class B that is required for use in domestic or on domestic environments and in ambulances. You can see here some requirements for these certifications. What we have to evolve in order to get class A and B is to have a more complete case of ventilation modes and to be more reliable to electromagnetic interferences, and also to have less electromagnetic emissions. I'm showing here the level of emissions that is allowed in each class and our current emissions, and our goal is on the other image where we are not passing above these lines. And we have already reviewed projects for this, and now here is this new board, and we are doing the tests and evaluations in this week. So it's going right now. A little bit slower because of this pressure to produce the ventilators, but we are still going on with this line. Other evolution that we have in mind is to make the ventilator connected. So INSPIRE is ready to be fully connected in a variety of technologies. It will allow to explore big data processing to develop more efficient treatments. We are planning to use artificial intelligence to analyze the relationship of ventilator configurations, drugs used, the patient profile, and how the disease is evolving. And it may extract valuable information for fighting the disease in the future. So this is one important line that we are working for next step in the ventilator. And regarding the Caninus Locus evolution, we have a complete roadmap. So we have higher performance platforms, always focusing on the edge computing, but still with more capability. We have some that are more focused for artificial intelligence, but the most exciting project that we are conducting now is about developing our chipset for Pulga. That is our low power, low cost, and autonomous platform. So we are doing it, and we believe it will be a great advantage for the program and to use in the Internet of Things.
Liza, thanks so much. I think the future still looks challenging, but the future looks also like it is worth kind of digging into these challenges. And I think we have already proven that you have the capability to shape the future in the way you are envisioning it. I think everybody here, including me, will wish you a lot of luck in moving on. I'm looking forward to work with you in the future again. But of course, we are presenting here at FOSSASIA to disseminate what we are doing here. So we want to actually reach out and get, of course, input from the community, because building the community around this and impacting the world is one of our goals. Thank you for staying with us until this point, and we will have some time now to answer some questions directly. But the administration of FOSSASIA has ensured us that we also have a public room where you guys can continue asking us what is going on or getting in touch with us. But even if you don't manage there to get in touch with us, so please kind of go to Caninus Locus, join and follow us there. We are reporting news there when we get some time to actually do that. If you want to promote us, then of course that is also very welcome, and everything helps here. And maybe when we beat the pandemic, there will be chances of actually meeting in person. And we would, of course, encourage you, after reaching out to us, or if you happen to be on an academic exchange, either in Brazil or Estonia, to get in touch with us. Or if you are a company that is interested in what we are doing, then of course, we are also very interested in industrial connections for the future. Yeah, if you can't manage to set it up now in the questions or in the talk, please reach out to these contact addresses here and set up a virtual coffee with us, or suggest a project and get in touch. And let's hope that this was not the last time that we see us, but just the first, and we will have many more meetings in this community again in the future.
All right, thank you very much. Forgot to say that Ulrich is Caninus Locus Ambassador and Software Engineer Professor at the University of Tartu in Estonia. Marcelo is Caninus Locus Founder and INSPIRE Project Coordinator Professor at the Electrical Engineering at University of Sao Paulo, Brazil. And Liza is an R&D Coordinator at LSE Tech in Sao Paulo in Brazil, and Programa Caninus Locus Chief Scientist. Let's have a we have some time for questions. So let's go with there was a first question on the chat asking if you guys can explain a little bit more on what are the different parts and how they work together.
Yeah, I think it would be best if Marcelo directly talks about it. So Marcelo, if you unmute yourself, can you kind of say something about the components again that are making up that? You're still unmuted.
Okay, thank you. Well, we try to keep the system very simple. We basically have 4 parts. Display, where we show what we call the breath maps. So we can display the breathing curves, oxygen level, frequency. Basically, that are the 3 parameters. It seems to be simple, but the lung is very fragile. Any mistake pumping air to the human lung can create severe damage that can lead for infection too. So, but anyway, we have the display. The second part is the step motor that pumps pressure, the ambu. We decide to use step motors because they are really precise. And this precision is also important to generate the correct curves. Then we have the single board computer. We are using Caninos Locus. We can eventually use another single board computer, eventually Arduinos and others. And in this single board computer, we have also precision air sensors, 12-bit, high speed. So these sensors, they close the loop. So we pump air, we measure the lung response. So basically, that are the parts on the ventilator. Then the critical thing is the software behind. The software implements unique closed loop control techniques that we will publish sometime. And these closed loop techniques are related to the lungs physiology. And that came from experts on lung physiology down here. But in overall speaking, the system is very simple. 4 parts: display, step motor, ambu, and computer. All pieces together.
Ulrich, I think you're muted.
There are more questions I see here. So are you moderating them, or are we just
Yeah.
going?
So I think Roland has a question he wants to ask.
Yeah, this is the sort of open source collaboration question. Have any other projects picked up your design, your software, and use them in their own environment? For example, seeking certification from their own regulator.
Yeah, that's something that makes us a little bit disappointed, because the regulation here is very, very strong. For example, improper management design of ventilators give 10 years of jail. So the regulation is really, really strict. So we have an understanding from the legal department of the university that if someone do an improper copy of the ventilator design and someone die, the original authors are the main responsibles for that. So
not the person who made the copy and used it, the designers.
The designers, because the designers got the certification. So what we did, we start to limit the access of the project to a closer community of partnership with us. And under the hurry of delivering the ventilators, because we are, at this moment, we have probably in Brazil 300 people using the ventilators. Yesterday, for example, I spent the whole day in the Navy base here. We are trying to produce more 50 ventilators. So we have this aware of not having professors being jailed here, because we are being almost jailed in October. You know, companies seeing our open movement start to consider switching us. And that means that in 24 hours, we can be jailed for 8 years. So that is the thing that we need to, I'm insisting on this. Thank you for this question, Roland. We never designed something so critical in terms of life sustaining. And when we opened this door, we had discovered that the environment is very strict related to certification. Somehow that is understood because we are saving lives. And when we turn the ventilator, that is the only thing that is sustaining life of someone. So if there is a bug or anything, you kill the people, you kill the person. But also there are secondary liabilities related potential damage that you can do to someone's lung. So because what we call Class C human sustaining critical devices, that is the certification that we got, law is very strict. And law somehow clashes with our vision of open source. I'm a super advocate of open source. But they came to me in October and said, hey, professors, you have two options. You can be jailed, and that could be happen very soon, because some commercial companies are blaming that you guys are doing something open source, and that is not proper. Or we momentarily closed it. At this moment, we have 250 volunteers, and the project is open to all these guys. But we passed away the message that we have this legal situation. As soon as the things tend to calm down, we want to address it again to see if we can modify the law to allow more open stuff in this arena. Anyone who is getting in touch with us, hospitals, research departments of some companies, we are talking openly about that. But we cannot put in the public domain, because if that happens and someone do an improper use of the ventilator and someone die or get hurt, the guys who got the final certification in our federal agency could be jailed.
Well, I think that
wow. Good luck.
I think that is the most core question that can be asked here, and I think one of the main reasons why we are here at FOSSASIA, because I think only this community and only with this outreach we can in the future address such questions, because if we want open hardware to make an impact, we have to address these questions at one point. And so if you guys have ideas, contacts to move that forward, please follow up with us and profit from our experience, but also let us profit from your experience there.
I'll offer one observation before I remove my face from the session. A very similar problem exists with tools that are doing things that encroach into legal advice. So a friend runs a startup in computational law, and there's always this risk that a thing that produces a template contract, for example, might be something that somebody argues was legal advice. and therefore that they relied on it, and this caused bankruptcy, not death, thankfully, but caused a bankruptcy, and they then want to go back and sue the people who published the template or who published the tool that populates the template. And so there's, fortunately, this has been going on the internet for decades. There's a gradually evolving understanding of the difference between someone publishing a thing which is a sort of legal tool versus someone taking on professional obligation to say, I am a licensed professional in this area, I have examined your case, you have retained me as counsel, and under those three conditions, I advise you X. So to maintain that separation has been the answer for a lot of legal tech. To make absolutely clear that the thing that looks like a thing that replaces a lawyer does not, you still need legal advice to rely on. I suspect that something similar may apply in your situation, but it's a large, complicated animal, and it's not just money, it's lives. So there's reason for conservatism, I accept that. I'll yield the floor because I know there's at least other questions to come, and I'm not the moderator, so thank you.
Yeah, thank you for the question, Roland. And yeah, this is a very interesting topic. We could go on and on it. And it's very nice that you guys are addressing it. There's a lot of excitement here. There's a lot of people, Kelvin Tan saying this is very inspiring, amazing, the speed of the product iterations and design. And then there's another question asking, can you give an insight of why features like Bluetooth and local AI supports and version C of the ventilator are actually needed? Don't they make the challenge of power management harder?
Yeah, that is a very nice question. Thank you also. One thing that we learn, unfortunately, people using ventilators unfortunately die. And we do believe that happens because the health team, sometimes they need a remote support to proper ventilate a patient. So we enhance our ventilator with a lot of connectivity features like Bluetooth, Wi-Fi, high-speed Ethernet, because we are moving on towards collecting data from the ventilators for big data and AI analysis. So that is exactly the point where our research teams are working at this moment. We are commissioning a super server at USP, and very soon we hope to start to collect this data. We do believe that in future, eventually, AI will help tuning the parameters of the ventilator to save more lives. That's why we have all these kind of connectivity features. We put Bluetooth, LoRa, Wi-Fi, Ethernet, and GPS. Thank you.
Nice, thank you very much. There's also a question saying there was a talk of using diving masks in ventilators where face mask parts are unavailable. Is that a possibility? Have you guys considered using diving masks?
Not sure.
Is that even?
Well, when we design our ventilator here, we are on economy of war. So most of the hardware parts that we had used are standard maker parts that we can find everywhere. Another thing that we need to face is the certification. So during the process, we did, for example, on the single board computer, we did 7 designs to adapt the requisites to the certification specifications here. But what we learned is that in this approach, we can use local parts, and in the end, we have a super low-cost ventilator. Usually a ventilator here costs something like $20,000, and we can do a ventilator using this approach with less than $1,000.
All right. Yeah. Thank you very much. That makes a lot of sense. There's many more questions coming up, but we don't have. I'm afraid that we don't have that much time. Would you guys be available at the discussion room so people can address these questions on the side? That'll be great. All right.
Yeah. Okay. So we will head. So Marcel and I will head over to the discussion room.
All right.
We'll definitely hang out for another half an hour or so there, and so please feel free to engage with us directly.
All right, perfect. Thank you very much. Yeah, great, amazing project. Very exciting. Thanks a lot. Thank you, guys.
Okay, meet you later.
Yeah, see you
We're
around.
heading over to the discussion room.
Yeah, everyone that has questions, please head to the discussion room. They will be there to address your questions, and all of those that are still pending, please go there. Thank you. Thank you for your presentation. All right, and I guess we're gonna go with the next in line, which is Alessandro. Alessandro, are you around? You can start setting up your.
I'm around.
Oh yeah, I can hear you already. Wanna set up your camera?
Yeah. Okay, great.
All right.
Hello, everybody.
Oh wait, let me give you the rights of presenting.
Yep.
Make presenter. All right, you should be able to upload slide, share screen, whatever you want to do.
Yeah.
All right, so in the meantime, Alessandro, it's a biohacker at Top Lab at Top EV. I guess I hope I pronounced it well.
I'm a biohack. So I'm. Can I introduce myself?
Yeah, sure. Go ahead.
I will.
Yeah, perfect. Yeah, then I'll leave you to it. The role of PS Lab in designing open source scientific equipment. All right, whenever you want.
Yes. So I wanted to introduce myself. I'm Alessandro Volpato, master's biologist, biotech innovator, and someone calls me biohacker because I'm involved into this movement of do-it-yourself biology. It's kind of self-initiating projects and taking on scientific research. I'm based in Berlin, and we have a community, like tiny community lab, and we are collaborating with several partners. We are building, for example, mushroom materials. We teach people how to do it, or we do experiments with bacteria producing sand, or more or pushing forward eco-sustainability. Okay, today it's about using a Pocket Science Lab as platform to design scientific equipment. This is important to us. I'm a biologist. I don't have an electronic engineer setup and background, and for me, it's really important to have access to these tools. And for this reason, I learned how to program, how to a little bit to design electronic circuits, to build open source scientific equipment that can be used to teach how science is done in the laboratories, and to involve citizens and curious and individuals into research and tackling, for example, ecological sustainability together, and push them and find a solution together. Okay, so because we may have an audience that comes from biology and not from tech, I will quickly explain what is a microcontroller. It's a tiny computing unit that is used for simple tasks. embedded systems, they are called. For example, you have it one in the car, is the computer that when you push the button turns on the radio or raises your window. You don't need a full-scale computer for that, but really a tiny computing unit will do the task. So how does the microcontroller scene look like? So in 1971, the microcontroller units look like the tiny element in the red circle, and that was the technology. In the year 2006, found on Hackaday, it's a circuit board to drive a radio commanded truck, tiny one, a toy, and the hobbyists are playing around with this technology just as a learning experience. And this kept going because it was so useful that also biologists started to prototype and to play around with microcontrollers and technologies. This is an event in Berlin, which is Science Hack Day, where science enthusiasts come together and hack on science topics and projects for a whole weekend. This is an experiment where a biologist automated a system to push evolution in yeast and microbes to let them eat and degrade plastics. The cool thing is that, the main question is how can you use computers and controllers to read life parameters or the parameters of living beings? How can you digitize even such a thing? And how can you teach a computer how to interact with a living being and giving in what he needs? And yes, so we are talking about digitization and what's going on. So in the tech environment, first we make good use of steam, of motors, and that was set up a mass production environment where we could produce a lot of our products, and adding some automation to it enabled us to get where we are right now, where a lot of products are being produced and sold. But we are still pushing for digitization, because now we are with our phone devices and all the technology that we have, we are producing a lot of data, which is stored in, because we saw that in 2010 we hit the point where there was practically all the information that we store it digitally, so not more on the paper, but on a computer. And the computer is able to read what our needs are. And if computer can communicate with a production tool in the industries, it's possible to produce services and products on demand. So yes, this is the direction and the trend that the industry is taking. And what about biology? We started to digitize living beings. So digitization is the process of converting information into computer-readable format. How do you put yourself into a digital format? This is a tiny tool which is called MinION Sequencer. Is a DNA reader. It's a device that's used to read your code, your blueprint. So the DNA is simply a code, a blueprint to build an organism, to build a human, to build a bacteria, to build a plant. And it's a code. You can, my genetic code. I can sequence myself and read action of to build myself. And on the right, we can see how does it look like this genetic code. And you can imagine it's like the programming code, the source code of a program. There are parts that are instructions, there are parts that are text, there are loops, there are executables, there are things that don't have to be executed, things that has to be executed under certain conditions. And yes, this is how we interpret now living beings, digitized living beings. And what about open source? Because this is a proprietary device, but how are we going on with open source and with democratizing these techniques and methods? On the left, we can see the Opentrons, which is a pipetting robot. In a biology lab, the work of biologists is mainly pipetting tiny amounts of liquids from one vial, one tiny tube to the next one, cooling and mixing and splitting. And this is basically what a biologist does in the lab the whole time, which is a pity because he could use its time in a much more efficient way. For this, pipetting robots have been built. They can this open source robot, which usually costs $100,000 to $500,000. Yes, it is an amazing. Yeah, it's fun and amazing at the same time. And this version, this open source version, costs around $5,000. And this is amazing because it's used also. It was used in the coronavirus and COVID crisis, and it's still used to extract the viral protein. The tiny elements that compose the virus, it's possible to extract them and prepare them with the robot, which speeds up a lot what has to be done. And I will share my screen now. And show you what's the next. How do I knew how to do it. Well.
You should have a button to share your screen on the next to the camera.
Yes, share your screen. It doesn't only share. Yes, I gave allowance. No.
Yeah, let me try to give you the presenter rights again.
Okay. Because it's stopping me. Okay, so I will do in a different way. So please wait 1 second. I will share with you the video. I see here share an external video and okay. Let's see if it's working. Yes, great. And this is the new way in which open is tackling and true. Yes, you have to click to play. Please. And yes, so we won't pipette around anymore, but we are already able to move liquids into electrical fields. And here is a device, OpenDrop, is open source from a partner of mine, which is Urs Gaudens at Gaudi Labs. And you can see how liquids are moved. which is extremely cool. You can imagine you have the reagents of an experiment in these tiny droplets, and there are some parts of this chessboard, parts, cooling parts, or simply analytics sensors. But at this point, at this time, we don't have any sensor connected to it. And so we are in the process of developing this integration of sensors with within this board. So, yes. So I will my presentation. Now, how do I get out of here?
Can go back with the action button.
Okay, here, this one. No. Oh, sorry, guys. Keyboard and meeting, log out. Share your screen.
There you go.
Undone. Whoa. Okay. We are on the presentation.
Yep.
Can you see the presentation? Someone? Yes or no? I don't see the chat anymore. Okay, great.
Yes, we can see the presentation.
Yes. So we saw how is the situation developing into the open source environment, and now we can have a glimpse in the future. How does it work? On the left side, we see this Promit ion. This is the device, so the tiny device that I showed you to read the DNA. This machine is able to handle 48 units of that. To handle such an amount of data, the three boxes that you see are computers. Are computers just to handle this amount of data. And this is a machine that will play a major role in the future of biology, because it will enable us to read, to extract a lot of information from the microbes that are around us, from the microbes that are in the environment. For example, in an hospital, which kind of antibiotic resistant bacteria there are in which room, and how they are evolving, or where you can monitor all the pests on a crop and know exactly where to intervene to have pest control reactions, and in the very beginning. Now I will show you I will share the link with you again for the next video. This is okay. We learned how to share the video. Let's see if I will be able to come back then. This is the OpenDrop bioserver. If you click on the link, and you will see how we put together in an open source way this device that was able to move the droplets. And you can think about each of these robots being a technician in the lab that is running an experiment. And you can see how you can parallelize experiments and have, in this case, 8 lab technicians working in your lab. And this is a box of the dimension of smaller than a baking oven that you have at home. And this is being digitized, and how this revolution is impacting the laboratories. And this is what scientists are in a deep need of getting in touch with open source designing communities, because the pace of an oven, yes, a bake oven, like something that you have at home, yep. So I learned, I do like this. And confirm. Okay, great. We learned how to come back. So yes, this is the future of lab automation, and open source is catching up at a really fast pace. And we can, if we manage to work together between scientists and developers, we can have a really collaborative research environment. Can you imagine how much data can you share if the data is taken by a sensor or by a robot? And you can really make biology reproducible because you simply have a program to run an app to run on your bioserver. You simply insert the reagents, and the experiment will run on its own and share with you the data online. So yes, this is the future of the biology. And this is the actual challenge, how to integrate all these quality sensors that are around into the microcontrollers. Things like the Pocket Science Lab or Arduino, or using this controller as the computing core for these sensors. The sensor that are used in the laboratories are not different from the one that we are using when we learn Arduino. It's not different than a light sensor. There is no difference on a thermometer, a temperature sensor, the humidity sensor. These are all common sensors that are found in many devices. And from an engineer perspective, there is nothing extremely difficult to build. It's just the quality of the sensor. Yes, I will go more in depth into this bioserver later on, Shang, so that in the Q&A, because it's a topic on its own. And so everything is about integrating data acquisition on these automated platforms. I will make you a practical example because maybe it's too abstract. Spectroscopy in the laboratory. Okay, now you're not an expert, so I will tell you in cheap words what we are doing in the laboratories. Spectroscopy is simply the study of the interaction between light and matter. Let's say, whoa. What are the applications? Let's go for applications so that you can understand if you can study the light, what can you get, which kind of information can you get out of it. We are using this spectroscopy to measure different compounds in the food, for example, to find toxic compounds in the blood, to check water quality, if it's drinkable and how can it be dangerous, to check for heavy metals, for example, or for other organic pollutants that are dangerous to our health. In pharmacy, it's used to check the purity. Yes, exactly, rainbow science. In pharmacy, it's checked to check the purity of the medicinal compounds. So how clean is a drug, for example, a medicament, or to determine how stars, what stars in the sky are made of. So it's really, there is a lot of opportunities with this spectroscopy. And so you can imagine that I met Mario Belling, and we said, I asked him, what can you build with PS? What can you do with Pocket Science Lab? I'm a scientist. I don't know anything about microcontrollers. And he told me, well, you can use sensors and connect it to your phone. We have apps and measure a lot of different things. There is an oscilloscope, there is a multimeter, a wave generator, logic and much more is getting added, like robotic controls, digital instruments. And I said, and he asked me, what do you plan? What could you do with it? And I said, okay, I want to do spectroscopy with it. And so spectro what? Because he's not on the the biology side, and I told him, yes, by connecting a spectrometer with PS Lab, you will be able to analyze food compounds, water quality, medicinal substances, and doing biology and chemistry research, and even check what stars are made of. I said, okay. He said, cool, let's do it. And this is why I'm here. And so we are trying to integrate these biology sensors into Pocket Science Lab, use it as a computer for a microcontroller for laboratory devices, and make these devices work on your phone or on controller. CCD sensor is the future of light sensors. This sensor has 3,600 singular light sensor in it, and that's really powerful to measure what we want to measure, the rainbow that we want to measure. So the spectrum, it's called in science, and each pixel will measure a different color, let's say so. And here is what we did. We, on the left, from the left to the right, we prototyped on a breadboard sensor and how this driver circuit board for the sensor, and we make it run. We make it run on the Nucleo, which is an industrial microcontroller for prototyping. Then we took the circuit board and we baked and assembled all the tiny parts that are needed to make it run. And with Daniel Vesolek, we made it run, and you see that the sensor is working on microcontrollers. And so we build a GitHub repository so that other people can collaborate with us, although it's a really early stage. So we still have to enable collaboration in the development, but we are working in this direction to make allow everyone to collaborate. And what's coming next? Our to-do list is yes, to connect first this sensor with the Pocket Science Lab and get some reads out of it. We need to design a case for the sensor, because so on the top left you see the schematics, the 3D schematics of my old spectrometer, and on the bottom you see something new, how I'm prototyping the new case and setup that allows the new sensor to be integrated. We have to make it work, and in the very end we have to share tutorials about how you can analyze, for example, plant compounds. And when you learn how to analyze plant compounds, then you learn also how to analyze food or pharmaceuticals. So it's a really powerful tool, or water, if you have it and know how to use it. And so the vision is to automate spectroscopy in these open source devices. I will sharing with you the next video. And this is what I'm, another of my projects. I'm producing a transparent microfluidic support to move, to make the support, the board transparent, so that light can pass through it, and we can analyze the colors or the optical properties of the droplets moving on the device. And this is a transparent printed circuit board. And yes, this is my idea. This is why I'm doing an open source spectrometer, to automate the reads on the on the automated platform. And yes, this is what I hope to do in the middle future. So this is another topic on its own, and this is cool because it allows a really tiny amount of liquid to be moved. Okay, now I'm back to my presentation. And it would be nice if with Pocket Science Lab we would manage to integrate this sensing technology on this microfluidics device, on this open drop. And so this can happen for many more devices. So Gaudi Labs is producing a lot of scientific laboratory open source devices. It would be extremely cool if instead of connecting to a computer, you could connect it through to the FOSSASIA Pocket Science Lab and to your smartphone, and to share data directly. And in the same way you can connect a sensor to the Pocket Science Lab, you can do the work the other way around. You can have a Pocket Science Lab as a platform to share more. For example, you can use it to retrieve data and to collect it in we call it in a laboratory logbook. This is where the scientists store and record all the records of the experiments. It was done on the paper. Nowadays, there are already apps to organize your data and the results of your experiments. And this is cool because it allows the whole team to have an overview of how the whole team is working, or to have a direct access to every data produced by the scientists working on experiments. So that's the future of biology: sharing, digitizing. And in the very end, if you have a lot of data that is produced and stored in a structured way, you can also run machine learning and allow a computer to have its say on the intellectual work of a scientist. So yes, we can integrate machine learning. If you imagine to have a shared logbook in a laboratory, you can imagine also to have more laboratories sharing their logbooks. So you can exchange between among scientists. Yes, it's almost to the end. I'm close to the end. Don't worry, Marco. And you can help standardize reagents, instruments, and so that you have comparable results and reproducible protocols. And you can enable community research on a world scale and data sharing. And this is in an open source environment. This will be extremely powerful. And on top of it, you can, the coolest thing is that you can enable a marketplace where because robotization enables, lowers the skill level needed to run experiments, lowers the barriers to access to experimentations, enables digital teaching, enables tailoring experiments to as a service and having customized research as a service. And you can have this marketplace exchange of knowledge or services on top of Pocket Science Lab if Pocket Science Lab provides scientific tools to make experiments. So this is my vision for the integration of lab equipment on.
All right, thank you very much, Alessandro. Very nice to hear a different side of the open source. I think I'm gonna let go with one question, one very quick question. Harsh, do you want to ask your question?
Yeah, sure. Alessandro, thank you for the talk. I got a question about how do you certify a particular equipment for use in, like you do analysis of DNA or whatever. How do you ensure that this is actually accurate? How do you do the baseline? How do you do the calibration of these kinds of products so that they are comparable, they have, the results can be accepted by people who need the results?
Yes. For now, we are not that far for every lab equipment, for every device of the laboratory. I can tell you how do I do with the spectrometer. You usually take references which are cheap and available. In our case, the advantage of having these compact fluorescent bulbs, which are mercury lights, and they emit a spectrum, a rainbow, which is extremely precise. And when you correlate your reads with this spectrum, you are able to calibrate and to determine all the parameters of the calibration of your instrument. For example, accuracy, precision, resolution. And this is, so once you are able to produce these numbers, you are able also to tell what you can measure. There is no certification actually at this stage. At this stage, we are just doing we are expliciting to our customers that we are doing it for scientific research, and everything has to be held as scientific research and is not meant to be used from a wide audience, but from a broad audience. But this is our goal, to go through all this step about how do you calibrate an instrument, which is for lab usage. And I will already tell you, because it's something that it's possible to do, and it's not. You just need the right tools. And how I do is to collaborate with institutions or partners who can actually certify and move me forward towards the certification institutions. Okay.
All right. I think we're out of time. Would you be available for some more questions in the discussion room? I think there's more interest on your talk. A lot of people excited about this different view of open source and open hardware.
I'm totally available, and so just let me check. How do I join the discussion room?
You just have to click on the left. There's a left on the left. There's an arrow.
Yes.
You can click, and you will see the video rooms. Yeah.
Found it.
All right.
Okay, then
perfect.
I click it. I say goodbye to everyone, and you can find the discussion room off from here. So bye bye.
Thank you.
Thank you.
All right. Now we have our next presenter, which is Alessandro Bestman. All right.
Hello.
Hello. All right. Can you set up your video?
Yep.
I can hear you already. Perfect. All right, so I'll give a bit of an introduction to Alexander. He's a PS Lab developer at FOSSASIA. He has a background in chemical engineering, in which he holds a PhD from KTH Royal Institute of Technology in Stockholm, where he studied about lithium-ion batteries. Very interesting. And very impressively, he is one of the guys behind the PS Lab Python. So yeah, very excited to hear about your live demo of PS Lab Python 2.0.
Thank you. So
Thank you very much.
How do I share a screen?
So you should have a share screen next to your video icon.
Got it. So let's see if you can see this. All right. There we go. Okay.
All right. Yep. That's it. Thank you very much.
So I'm gonna do that. Yes, and you can see that. So yes, thank you for the presentation, Marco. So this is going to be a quick demonstration of the API in the new version of the PSLab Python library, which was released earlier this year. So as you can see in the shared screen on the right-hand side, there is a live feed of my PSLab board. Hello. So you can see what I'm doing. I will be connecting some wires and some resistors and stuff to it later. And on the left-hand side, there is a IPython shell, which I will be using to control the PSLab. And I will try to go a bit slow so that you can hopefully follow along. But first things first, this is not an introduction to Python itself. So in order to follow along, it's good to have some familiarity with Python, the programming language already. Otherwise, it might be a bit difficult to follow. The first thing we're going to look at how to do today is how to install PSLab Python. As of a few months back, it is available through the Python package index, which means that we can install it using pip install PSLab. So in my case, I already have it installed, of course, so that was very quick. But it should be basically the same for someone who does not already have it installed. The second step that is required for Linux users only is to allow your current user to access the serial interface to the PSLab device. On Linux, regular users typically do not have sufficient permissions to access serial devices unless they are members of the dial-out group. And in that case, you need to install something called a UDEB rule. And that can be installed by running pslab install after you have installed it from pip. So in my case, I have already done that. So it just tells me that that's already done and not necessary. You may need to run that as root. Okay, once that is done, we can import PSLab. And then let's first take a look at the oscilloscope instrument. So first we need to connect to the PSLab board, which is done by instantiating the Science Lab class. You can see that the LED on the board turned green, which means that the connection was successful. So let's start by capturing an oscilloscope trace. So the Science Lab class is an aggregate which holds all of the other instruments. They can also be instantiated individually, but we're not going to cover that today. So the PSL object, which is a Science Lab instance, has an oscilloscope attribute, which we can use to capture an oscilloscope trace. The capture method takes the number of channels on which to capture samples as the first argument. So we will capture samples on one channel for now. The second argument is the number of samples to capture, which can be at most 10,000, which is what we're going to do right now. And the third argument is the time gap between each sample in microseconds. For now, we are going to use 1 microsecond. You can see that the system LED on the PS Lab blinked, which means that it performed some kind of action. Next, we're going to want to plot this. So let's import matplotlib to do that. We can plot the timestamps, which we got in the X variable, against the voltage levels at those timestamps. And there we go. So as you can see, that was not very interesting because there's nothing connected to the board right now. So all of the samples are, of course, very close to 0. So what we're going to do is we're going to connect one of the analog outputs, specifically the one labeled SI1, to one of the analog inputs, specifically the one labeled CH1, channel 1. There we go. We can use the waveform generator instrument to generate an arbitrary waveform on the analog output pin that we just connected by calling the waveform generator attribute of the Science Lab instance and the generate method of that attribute. The generate method takes the number of channels on which to generate waveforms as the first argument, or alternatively, you can name a specific channel on which to generate the waveform. The second argument is the frequency of the waveform. So by default, the waveform that will be produced is a sine wave, which we will see in a moment. So now we are generating a sine wave on the analog output. Let's see if we can capture it on the analog input. So we will rerun the capture method. There we go. Let's plot that again. And there we go. That's much more interesting. We can see that we managed to capture a sinusoid. And if we do the math on this, which I'm not going to do, we will find that the frequency is indeed 1 kilohertz. So that's capturing a single channel. You can also see that in this case, the trace starts at an arbitrary voltage, which we might not always want. So if we rerun the capture command and plot it again, it will start at a different voltage. A common feature of oscilloscopes is the ability to trigger the capture at a specific voltage, and of course the PS Lab can also do that. So we will add a trigger condition to the capture call. It will trigger at 0 volts. So when the signal passes 0 volts from low to high, the capture will begin. I'm going to run that command twice because there's sometimes an intermittent bug that makes it not work the first time. There we go. Now we can see that the capture trace starts at 0 volts. We can also trigger at a different voltage. We could trigger at 1.5 volts, for example. And then we see that the trace starts at 1.5 volts. We can also capture on multiple channels simultaneously. So I'm now going to connect another analog output to another analog input, specifically FI2 to CH2. Let's see, like that. Okay. So we will again call the waveform generator attribute and the generate method of that attribute. This time we will generate waveforms on two channels simultaneously. We will still use 1000 Hertz as a frequency, and we will offset these waveforms by 90 degrees. Now let's capture some traces again. So now we have to capture two traces. So we have to add another variable. Start here. We'll capture on two channels, and now we have to reduce the number of samples to capture, because the total number of samples, which is the channels multiplied by the samples, must not be higher than 10,000. Okay, let's take a look at that. We will plot X versus Y1 and X versus Y2, because the timestamps are of course shared between the samples. There we go. So we can see that we have now captured two sinusoids, and they are indeed offset by 90 degrees. The analog, or rather the arbitrary waveform generator can output waveforms other than sine waves as well, of course. So we will reconfigure one of the channels to instead output a triangle waveform. So then we call the waveform generator attribute and use the load function method, which takes the channel name on which to load a new function as the first argument, and it takes the type of waveform as the second argument. So here I'm loading a triangular waveform. So triangular waveform is predefined in the library. So you only have to specify that as a string. We will see later that we can also specify arbitrary functions, but let's start with this. So now the waveform on the second channel should be triangular, no longer sinusoidal. Let's see if that is the case. Indeed, that worked. Fantastic. So you can see that the settings are otherwise preserved. The frequency and the phase are the same as before. It's only the shape that has changed. Let's see how we can load an arbitrary waveform into the other channel. So to do that, I'm going to import NumPy. See if we can't load two superimposed sine waves into the first channel. So to do that, I'm going to pass a lambda function to the load function method. So let's say that we want to pass the following function: sine of x plus a higher frequency sinusoid on top of that. Then we also have to pass the span across which this function is defined. So we didn't have to do that when we loaded the triangular waveform because that is predefined in the library. But if you're loading an arbitrary waveform that is not predefined, then you have to specify the period across which this function is defined. So we will define it over 0 to 2 pi. Let's take a look at what that looks like. There we go. As you can see, on the first channel, we are now outputting 2 superimposed sinusoids. First, there's the 1 kilohertz sinusoid, as we saw before, but there's also a 5 kilohertz sinusoid with a lower frequency superimposed on top of that sinusoid. So that's how you can load arbitrary waveforms into the PS Lab. Let's take a look at if we can't load a square waveform and see what that looks like. So to do that, we will take the absolute value, no, rather we'll take x, and then we will divide x by the absolute value of x. So that will be -1 for negative values of x and 1 for positive values of x. We also have to consider 0. We don't want to divide by 0, so we will add x equals 0 here. So if x is equal to exactly 0, this part here will be equal to 1, and otherwise it will be equal to 0. This is to avoid division by 0. And we will define this on the span -1 to 1. Then we will capture that and see what that looks like. Yeah, so as you can see, we are now outputting approximately square waveform. So since I did not multiply the function by 3, the amplitude of the waveform is now 1 to -1. We can also increase the amplitude by multiplying this function by 3, up to 3. The voltage cannot exceed 3 volts, or 3.3 volts, I think. Like that. And there we go. Now we have a square waveform with a higher amplitude. There is also a different way to generate square waveforms using PS Lab, using the PS Lab, and that is to use the PWM generator, which is what we're going to look at next. So I'm going to disconnect the first channel from the analog output and connect it to a digital output, specifically the digital output labeled SQ1. There we go. So now we will call the generate method of the PWM attribute of the Science Lab instance. So we will generate on one channel. It will generate a waveform, the frequency of 1000 Hertz, and a duty cycle of 50%. Let's take a look at that. All right. So now the triangular waveform disappeared, which is because some of the digital outputs and the analog outputs share hardware resources. So we will actually disconnect that as well. We can see a bit more clearly, and then we can just capture a single channel. we don't have to use the trigger anymore. So actually, when you have set the trigger once, if you wanted to disable the trigger, you call it with a false argument. Yeah, and there we go. As you can see, the PWM generator, of course, outputs more clean square waveform than the analog output can do. It can also generate much higher frequencies than the analog output. The analog waveform generator is limited to about 5,000 kilohertz. No, 5,000 hertz. Sorry, 5 kilohertz, as we saw previously during the OpenTap presentation. But the PWM generator is limited to about 8 megahertz, so quite a lot more. So we can set this to 1 megahertz. Wait, okay, no, that was the wrong method, sorry. Don't do that with oscilloscope. Here we go. Okay. So we will see that if we try to do this, if we try to observe a 1 megahertz signal using the oscilloscope, we won't get very good results because the oscilloscope is not fast enough for that. Yeah. So that's where the logic analyzer instrument comes in. The logic analyzer instrument has an equivalent capture method we will call PSL logic analyzer capture. We will capture on a single channel. That's enough for now. Well, okay, so right now we didn't capture anything because we have to move the wire to the digital input. There we go. Then we can see that now we captured a bunch of stuff here. So these values that we have captured are timestamps. Timestamps where logic level events were detected. And the logic level event in this context means a transition from low to high or high to low. So in each of these timestamps, the PS Lab detected that the logic level at the digital input transitioned from low to high or high to low. So in order to plot that so that we can actually see what we're doing, first of all, I'm going to capture fewer samples because otherwise we're not going to see anything. Let's capture 10 events. In order to actually plot that, we can call the helper function get xy, like that, and then we can plot that just as we did the oscilloscope trace. There we go. The x-axis here is microseconds. Actually, when did I start? How much time have I used? I lost track of time. I think I started at 12:15 roughly. So we're 15 minutes in. Is that correct? That's correct.
You should have like 5 minutes. Is it?
5 minutes?
Oh no, you started at 10, right? Yeah.
I started at 10 past, so 20 minutes. Okay. This is a 40-minute talk. Is that correct? So I have 20 minutes left. That's what it says in the schedule.
It's a 40 minutes talk. Yeah.
Yeah. Good. Okay. Good. I think I need to move a little bit faster here. Okay. We can also, of course, generate multiple PWM waveforms simultaneously. So now I'm going to connect a second digital output to a second digital input. There we go. Now we're going to generate PWM signals on 2 different pins. We can use different duty cycles for the 2 waveforms, but they must share the same frequency. So we will have the second waveform have a duty cycle of 25%. We can also offset them by a phase between 0 and 1. So we can offset them by, for example, 33%. And then we capture timestamps again. This time we will capture on 2 channels. Let's capture a few more timestamps. Now you will see that we have 2 arrays in the timestamp variable. So as before, we can use the getXY function to get something that we can plot. So we will do this. Unlike the oscilloscope, the logic analyzer, the return values from the logic analyzer are not guaranteed to have the same timestamps. So here we have to use 2 different X variables. And then we can plot this as before. So in order to be able to see something, I'm just going to offset the second trace by 1 volt. There we go. That's correct. That seems a little bit strange. It seems like the... Okay, I may have to look into this. It seems like the duty cycle of the second waveform, which should be 25%, is instead 75%. Right. Live debugging. Yeah, we'll let's just skip that for now. So as I said, while the PWM wave signals can have individual duty cycles and phases, they must share the same frequency. But sometimes you might want to use to have 2 different PWM signals with different frequencies, and in that case, you can use the reference clock mapping method to generate the second signal. So we will do that on the second channel here. Yeah, it happens. So we will use the map reference clock method here. So we will do that on the second output. And this method takes a prescaler as the second argument. And the prescaler here is this method is a little bit tricky to use. So unlike the generate method, you don't set the frequency directly, because you cannot set arbitrary frequencies using this method. You can only set frequencies that are even ratios between 128 megahertz and powers of 2 up to 15. So that means 128 megahertz, 64 megahertz, 32 megahertz, 16 megahertz, 8, 4, 2, 1, half a megahertz, and so on and so forth. And the prescaler is basically the denominator in that calculation. So if we set a prescaler of, for example, 8, we will get a frequency equal to 128 megahertz divided by 2 to the power of 8, which I believe is, how much is that? That's half a kilohertz. No, half a megahertz, 500 kilohertz, sorry. And now we will see that we can capture 2 signals with different frequencies. So as you can see, the frequency on the second channel is now half of the frequency on the first channel, which, as you may recall, is 1 megahertz. So that's how you can generate PWM signals with different frequencies. Some other limitations of the reference clock map is that the waveform or the signal is locked to 50% duty cycle. Okay, let's move on to the next instrument, which is the multimeter and the programmable power supply. So I'm just going to connect one of the analog inputs to one of the programmable voltage sources. So now we're going to use programmable voltage source 1, which is right there. Okay. There we go. So the multimeter can be accessed as, just as we access the other instruments, as an attribute to the Science Lab instance. It has a measure voltage method, which by default measures the voltage on the pin labeled VOL, I think. So right now I have connected it to a different pin, CH1, so I'm just going to tell it to measure the voltage on that pin instead. Okay. -5 volts. That's probably correct. Let's see if we can change that. We can change that by calling the power supply attribute, and then we are now connected to the pin labeled PV1. We can set the voltage like this. And now hopefully we will measure, yes, 0 volts. So PV1 can be set to any voltage between -5 and 5 volts. So if we set it to 5 volts and measure voltage with the multimeter again, yes, we now get 5 volts. There are two other, the PSAT has 3 programmable voltage sources. PV1, which we are using right now, can generate voltages between -5 and 5 volts. PV2 can generate voltages between -3.3 to 3.3 volts, and PV3 can generate voltages between 0 and, I believe, 3.3 volts. Next, let's take a look at the programmable current source. So in order to see anything there, I'm going to connect an LED between the PCS pin and the ground pin. There we go. Hopefully you can see this. Now we are going to call the power supply attribute, and we are going to set a value on the PCS pin. The programmable current source can output currents between 0 and 3.3 milliamps under ideal conditions, which do not always apply, as we will see in a moment. Let's start by setting it to 1. Let's start by setting it to half of a milliamp. Yes, I think you can see that the LED turned on. So if we increase the current to 1 milliamp, we should see that the LED gets brighter. Which it did. Fantastic. We can go a little higher, 1.1 milliamps, or 1.5 milliamps, I mean. Now it got dimmer instead. I'm not sure if you saw that. Let's do that again. So that's 1 milliamp. And here we are trying to set 1.5 milliamps, but instead it gets dimmer. So the current clearly is lower. And the reason for that is, as I mentioned before, the programmable current source can output between 0 and 3.3 milliamps under ideal conditions. But ideal conditions means a load resistance equal to 0. This is a red LED, which has a voltage drop of approximately 1.7 volts, which means that the load resistance is equal to which means that the load resistance is equal to 1.7 volts divided by whatever current we are passing over the LED. And if the current is too high, the load resistance becomes too high, and then the current source cannot output the requested current. So let's set it back to 0. Okay, I'm going to try to finish this up so we have time for some questions. Let's just show one more instrument, or one more feature of the multimeter, which is the ability to measure resistances. So by connecting a resistor, let's remove this wire, by connecting a resistor between the RES pin and a ground pin, we can measure the resistance of the resistor. So I'm not sure what type of resistor this is actually. We will see in a minute. Again, we call the multimeter. This time we call the measure resistance method, and we see that this resistor has a resistance of approximately 1.16 ohms. No, what is that? 116 ohms. Sorry. Yeah. Okay. That's quickly about the multimeter. I think I'm going to skip the peripheral buses for now, so that we have time for more questions, and it can make up some time here. I will just briefly mention that the PS Lab can also be extended with external sensors on any one of its peripheral buses, which are there's an I2C bus, there's an SPI bus, and there's a UART bus. I'm going to wrap up the live demo there, and yeah, I would be happy to answer any questions that might have cropped up during the demo.
Right. Great. Thank you very much, Alexander. Excellent job. Pretty impressive. There's a question. I don't know if you can go to the shared notes, but there's a question from Alvin that he's run into some problems when importing PS Labs, and he's asking if he really needs the hardware to do that import.
Yes. You do need to have hardware. Not to import. You should be able to import the library without the hardware, but it won't do anything unless you have hardware. So let's take a look at this error. Okay. Module not found. The module named PS Lab. We install PS Lab, which seems absolutely correct. And then we go to no module named PS Lab. Yeah, that's very strange. I don't have a good explanation for that right off the top of my head. My guess would be that you might be inside of a Python virtual environment, perhaps, where you did not install PS Lab. That would be my first guess.
Yeah, maybe we need more details about the installation.
Yeah, I think we need some more details on the installation to answer that. Second question: Do I need? Yeah, sorry.
Oh no, yeah, no. I just I wanted to point out, like, maybe the failure when you don't have the hardware comes when the connection is done, right?
Yes, exactly. So you should be able to import the library even without the hardware. Second question: Do I need a piece of hardware to run this? Yes. The library does not offer any hardware-independent functionality, so you can't really do anything interesting with it unless you have an actual PS Lab device. And
I also have one question very quickly. You started working on this on 2020, is it?
Yes, I started working. I joined the project in summer 2020.
So there was a Python library before, right? Did you work on top of that, or did you rewrite, or?
Yes, this is basically a complete rewrite of that library.
Oh, impressive.
So the version 1.0 of PSLab Python, which was the version that existed when I joined the project, it had basically all of the same functionality that we saw today, but the API was a bit more, let's say, clunky, because the library at that point was designed to be used as a middleware between the desktop application, the graphical user interface, and the board. It was not really meant to be used directly as a standalone library, although of course it could be used like that.
I remember I used that library, and we even had problems for some Windows machines and Mac OS. Have you tried this one with Windows and Mac OS?
With Windows, yes. With Mac, no.
Oh, okay. All right. And there's the last question. What do you think about OpenTap?
I think that's very cool. I wasn't aware that they were using the new API, so I was very happy to see that they have found that and that they are finding it useful. Very cool.
Yeah, that's great. Yeah, that's amazing. All right. Thank you very much, Alexander. Great job. Amazing. Very impressive. I can't wait to test it out on my PS Lab. Thanks a lot.
Thank you.
All right. So I think our next speaker would be Mr. Patmal. Oh, someone is here. All right. I'll let you guys do it. All right. Yeah.
Hello. So I hope you guys have enjoyed, you folks have enjoyed the PS Lab tutorial with Matplotlib library. And so up next we have Mr. M. Padmal, and he is a great man. So Mr. Padmal is a PhD student at Uppsala University in Sweden, following his dream to become an expert in electronics. His research area is battery-free sensor networks, having a master's degree in wireless communication engineering from University of Oulu. And today he will be explaining us Pocket Science Lab, what's next with PS Lab. So I am sure you folks will be very happy and energetic to learn something new. So now I'll give the stage to Mr. Yu. Thank you. And I'll give you the rights. Yes.
Okay. I think I just shared my presentation here.
Yes, it's visible.
Perfect. Okay, I think we can get started. So welcome to my presentation on what's next in PS Lab. I think we had a small introduction about myself. I've been an active contributor for the project since 2017, when I started this project as a GSOC student. And now this is the second day of FOSSASIA Summit 2021, and we had a couple of presentations and workshops on PS Lab. By attending those, now you would have a broad idea about what this pocket-sized device do and how the software development is progressing through. Just a small recap on the journey so far. We started working on a hardware prototype somewhere between 2017 and 2018. Our first goal was to make the device as small as possible. So we made a prototype and tested the board made to follow the dimensions of Arduino Uno form factor, but the components were placed on both the top and bottom sides of the PCB. Once we shared the news about this new device among other developers, we received many good feedback from the community. That is regarding the manufacturing cost. We were to build a prototype by populating components on both sides. We'll have the board need to be run through the assembly twice. But this is something we can try to reduce by changing the design. So we changed the design. We had to run many tests and revisions to finally get PSLab version 4. We call it PSLab v4. All the components from bottom side were transferred to the top side. And we had to enlarge the board to as big as Arduino Mega form factor to get all this thing done. Because with the Arduino Uno form factor, it was very difficult to get everything on the top side. So this was okay for us. And this board, PSLab v4, was first released at the FOSSASIA Summit we had in 2018. We got many constructive feedback from users, and that got us into developing the next version, PSLab v5. So we had 5 prototypes built. We didn't release it to market at that point because we need to have a few developers get their hands on 5 of those and get their feedback. So it was great, and we were finally able to make a flow connection between the new features we added to this new PSLab v5 design. Iterating on that, we got the new PSLab with enhanced features and many updates. The new PSLab v6, we call it, comes as a much denser package with all the features it had in its previous versions. Instead, in this new design, we upgraded the existing components from the early design and added many cool new features. Well, let's start with connectivity. Early designs had a micro USB port to have a wired connection between a host computer and the PSLab device. The new PSLab board has a USB-C port. It's the one we saw with the Alex videos. This enables us to get a higher power draw from the USB cable and have a much higher speed in connectivity. There was in the earlier design there was a pin opening for an ESP12 module, and it would require a user to solder a ESP12 module by themselves, which we found a bit impractical. So this was changed in the new design. We replaced this ESP12 connector with an ESP01 connector. It's the same chip, but ESP01 comes as a separate module with header pins. So users can simply plug this board in without having to solder anything. And that's not all. So we had a SPI interface to the new PSLab v5 design, and the I2C connectors were made compatible with groove sockets. Groove sockets is becoming more like the standard in I2C connectors because many vendors keep on developing different sort of arrangement with the 4 pins, this ground, VDD, SDA, and SCL. So we wanted to be compatible with commodity devices and sensors as much as possible while supporting advanced features PSLab is offering. So apart from that, now there is a reset switch, that is to restart the board in case if it's stuck, or to help the board to get into bootload mode for firmware upgrades. And the board also comes with a new WS2812 RGB LED. And apart from that, I worked a bit on the seal screen. Just to get a bit of an eye candy. Instead of the monophones, all these usual circuits are using, I wanted PSLab to stand a bit different. Now the fonts are a bit sharp and it looking good. We were able to pack so many new features on top of existing ones because we moved to smaller components, smaller footprints actually. They were in fact better than the previous ones. Technology was developing, so new models are coming out and we needed to keep up. So the voltage regulators were changed from big ICs to small QFN alternatives, and the UART bridge we had earlier, which was a microchip MCP IC. It was quite big. So it was replaced with this Silicon Labs CB210X UART bridge, which is quite famous these days with these newer ESP modules and many peripherals. So now the PS Lab V5 has this UART IC. And PS Lab can PS Lab can function as a standalone device. The meaning is that you don't need to have a computer or a mobile device to use the PS Lab, as it was in the early designs. The new standalone mode allows PS Lab to be used as a data acquisition device. Such a data logging feature would be very useful in various outdoor experiments. Say with a suitable waterproofing case, now you can leave PS Lab outside connected to a sensor and make it log the sensor readings until the battery or the memory card runs out. All these hardware changes need one other thing updated, that is the firmware. This is not the last hardware update we're talking about. So to make production faster and to roll out new updates in firmware, we implemented a bootloader. This bootloader, because our microcontroller is based on microchip PIC architecture, so we had to base this bootloader on their proprietary ECBL library. It was quite a hassle implementing this bootloader back then with the all free compilers and IDEs we are using. It was kind of hard. But finally, Microchip released a new version of ECBL library, enabling us to surpass all these challenges. So the compiler was working, everything was good. So that enabled us integrating this bootloader into the PS Lab firmware ecosystem. But there's a little catch, because users will need to install a separate application named Unified Bootloader to upload this hex file with the new firmware update for the PS Lab. And I told that the new PS Lab comes with a standalone mode. That means it can act as a data logger. This new firmware update enables the user to switch between the normal mode and the standalone mode. And normal mode is when you use the device plugged into a mobile device or a laptop. And standalone mode configuration would be fetched from the SD card. Well, Android and desktop apps already have this feature implemented during our last stages of the year before. Users can specify which instruments or sensor they need to have the data logger work with, and what is the timing interval between each data logging, and many other parameters specific to each of these instruments. This mode uses the real-time clock to record timestamp, and the logs will be saved on the microSD card, and you will have access to a comprehensive data log at the end. And like I said, this is now the last update for PS Lab. We are researching on various microcontrollers that are cost-effective and compatible with current features PS Lab is offering. The key idea is to go for a much open design, decoupling from proprietary IDEs and tools program, because we experienced that in firsthand while developing it with the microchip. And we have our hands-on research with ARM-based platforms to get this done. And there are weekly meetings that anyone who is interested with PS Lab development could attend. And if any of you are interested in joining hands with the development, please feel free to drop a message in our Github channel. And that's it from my side. And thanks for listening. If you have any questions, I can take them now.
Okay, well, thank you very much, Padma. And I see some questions here. So, yes, on the chat note. So, can you explore using RISC-V CPUs? Yeah, that's the question about like going even more open.
Yes, I guess that's somewhat related to FPGA, I guess. Well, the thing with that is that's something new for us. I mean, for the development, we don't know how to integrate that with the current ecosystem we're having with the just let me read. Vehicle bonds. What is the plan for the current version? Yeah, that's what I was talking about. I mean, we were kind of in research mode recently with ARM-based microcontrollers, because right now we're using microchip and we have to rely on their compilers. We're using the free versions and they have quite the limitations. And some of the features don't work with, say, in Ubuntu. We have to switch between different operating systems to make them work. It's quite hard with the current development. So we were thinking that an ARM-based alternative would be a better approach, but it requires a whole lot of development process. We have to build up from scratch. So if we try to do that, we would need some more resources in development wise. And well, if any of you are interested, then feel free to join us. We can make it happen.
Cool. Yeah. So I see like it was added here about like the seed components and also DigiKey or DigiKey. Right. So there's quite a lot going on with RISC-V, but then there is another question, and I think we also discuss this regularly in our meetings. What is the plan after the current version? Any other chip? So it's going in the similar direction as the previous one.
Exactly. Yeah, that's the one I answered just now. With the RISC-V CPUs, actually, I don't have much idea. But I guess that's somewhat related to FPGA.
Yeah, I think we're definitely happy for people joining. Padma, I want to ask you also, what is your personal vision? What could be achieved with PS Lab? We heard Alessandro today, who has a very big vision about really like changing science into like everything just must be open, and going into biohacking and biology topics. So spectrometer, of course. What's your personal vision? What do you think, in what direction can this project head, and what kind of applications and instruments could be supported?
Well, I believe in a common market strategy, we need to keep up with the current development. We can't rely on devices that were built, say, 5 years ago. So we actually need to have our devices updated and upgraded. And my vision is to have PS Lab come with a new IC. I mean, more like much capable. Right now, there are many capable microcontrollers out there in the market, say STM32 and the NXP. There are plenty of them. And I think if we can get them on board with PS Lab, then that would really drive the way PS Lab is kind of helping the open science and scientists in a much better way. That's how I feel it.
Okay, thank you very much.
Sorry, Mario, go ahead.
And so we, yeah, Padma, that was a really good insight and a good wrap up of many years of development. Yeah, personally, also looking forward to the next steps. So yeah, PS Lab is a big topic, and a lot of this growth is because of you. So really appreciation here from my side, and I think from the community, like how we heard from Marco and others, they want to test it, they want to see what are the new steps, and yeah, I can't wait that we release the next version. So excellent talk. We're here at the end. Thank you very much, and have a good afternoon.
You too.
Okay, and we are coming to the next session. So we have Shubham here. Shubham, you are really like supportive for many days, and I want to say thank you to you for supporting the teams and in different channels, answering questions and so on. I just was now helping out a bit because it was a bit noisy, unfortunately, where you are, and but we really appreciate your support. And you check out a bit how's the noise, and if you want, you can continue. We're always like happy to integrate new people in the project of like FOSSASIA Summit. So how is it there over with you?
Thank you so much, Mario, for such a good words. I'm really flattered by you. I really liked it, and with that, I also like the concept of PS Lab, like having a ESP module integrated with it, and it's really a good module, and I cannot stop myself from trying one. And
excellent. So I let you continue here the session. So thank you very much, and please go forward. Move forward. Thank you.
Sure. Thank you. So next we have all the way from Africa our friend Samson Gori. So Samson, Mr. Samson, are you here in the talk? Sorry, in the summit? Can we have you on the panel? Can you switch on your camera and mic? Samson? Okay, no problem. I hope Samson will join us soon on the panel. So till then, I'll share the video which is shared by Mr. Samson for his talk. And as you can see on the screen, the topic of his talk is Growth from the Open Source Community Africa. A short introduction about Samson Gori. He is a co-founder of Open Source Community Africa. Samson is a software developer who believes in changing the world, an open source advocate primarily maintaining Sugar Desktop, while also serving on the board of directors with Sugar Labs and sustaining Open Source Collective as a board member. Such a good person. We all like your work, Samson. So now I'll share the video and we can move forward with his talk. And Samson, if you get back to the event, I would request you to turn on your camera and be on the panel.
Hi, welcome to FOSSASIA 2021, and I'm here to talk about the open source growth and open source community Africa. Before I start, I would love to do a little bit of introduction about myself. Awesome. So my name is Samson Gadi, or you can call me Samson. I am the co-founder for the Open Source Community Africa, which is a project that I co-founded with a friend sometime around 2018 to, kind of help shape the growth and, help enable the community when it comes to open source. I also serve as a board for Open Source Collective, which is an amazing project that I love because they also enable communities like mine to better, raise money to sustain the project. And when it comes to open source stuff, I am a contributor for Sugar Labs. I previously was a board member for the project, but right now I'm more focused as a contributor on the project, making sure that building tools for education is a priority for me. So it's a project I'm super excited about. Lastly, I am part of this program, amazing program from GitHub called the GitHub Star, and it enabled me to interact with the community at large to see how we could help when it comes to sustainability, particularly in communities like mine. So it's pretty amazing that I'm part of the program. So if we want to talk about open source, there's one country that we should definitely look out for, and not because I'm from Nigeria, but the fact that there's numbers that sort of back the country. So as you can see here, this is the latest report from GitHub showing the fastest growing countries on the platform. So Nigeria happens to be, the fastest growing country when it comes to, numbers of projects, and when it comes to like how expanding, and contributors are coming, particularly in the open source space. Now, why is this number growing, or what does this number represent, or what is bringing this energy from a continent like Africa? Simple. Like I said, it's showing about 60% are youth, and these are my friends. We took this photo. Well, I'm not dead, anyways. So these are my friends. They're actually standing at the festival, which I'm going to talk about.
Sorry for this action. Um,
Hi, welcome to FOSSASIA 2020. About the tagline. This is something that my friends over at Open Source Community Africa, we keep saying, the future is open. Now, what does that mean? The festival, which I'm going to talk about later on, it just shows how young the open source community space in Africa looks like. This is the typical contributor behind every project that you know. And I can't talk about open source in Africa without talking about the tagline. This is something that my friends over at Open Source Community Africa, we keep saying, the future is open. Now, what does that mean? In order for us to make sure that we have a system that is there to kind of support and to also help in collaboration, this is the structure that I and my friends over at the Open Source Community Africa, they were currently doing when it comes to helping to define, to shape, and to help grow, the ecosystem. So how are we building? We started as right now, the current version anyways, we're currently working with developers, designers, and also technical writers. And the reason why we're trying to do more stuff away from just focus on developers is the fact that when it comes to open source, there's not just the diversity of people, but also the diversity of skill sets. So it's very important for us, we at OSCA, to make sure that we have great supporting system for even non-coders and people that do things around other technical skill. So if you look at this slide, you see that and at OSCA, which is obviously at the top, it's kind of driven in two ways. There's the community side of things, and then there's the project side of things. And between the community side of things, we have a system in place, or I would say more of a program, that is called the chapter program. Now, this chapter program enables OSCA, which is the Open Source Community Africa, to go into local cities and to be able to help to support what is required in those local cities. So it's like your typical developers program. Like, for example, one of the most popular developers program in the world is the Google Developers Program. So it's like the typical GDG that that is around your city, but this is more in line with OSCA and more in line with the open source vision. So we use this chapter program as a way for us to go into different cities across Africa, and then we identify people and also great communities that want to do more in open source. And secondly, the festival, we initially did the first one in 2020. We're still working on seeing the possibility of doing one this year. But the festival aim is to kind of create an annual or maybe twice a year program that sort of celebrate and create a system where people can network, like your typical summits, like, or in this case like FOSSASIA, right? So it's a system in place where we have a way for people to come in and to explore and to share things that we're working on. So it's one of the amazing things for us over as part of our community program. Now, when it comes to project is a little bit tricky because internally we don't have a lot of project. But for us to be able to make sure that we, like we said, building the next billion creators, which is a team for us internally at Oscar, we want to bring things into two different parts. So first, advocacy, and second, contributions or contributors. Now, advocacy is the opportunity for us to work with people that identify as open source advocates to help them, to give them a system in place that enable them to go out and to publicly talk about open source. So just typically what I'm doing right now, I'm serving as an advocate for Oscar at FOSSASIA. So that's what a typical advocate in the open source community Africa space does. And then there's the contribution side of things, which is kind of like the same thing anyways, but just different wording. Now we work with open source communities and we work with open source projects in outside of Oscar, and then we bring them internally within our community to enable people that want to contribute to project for them to be able to contribute. So making sure that we have a system in place while working with other communities to make sure that we have more people going into that project. So the advocacy side and the contributor side are two key ways that we drive the project creation and project contributions over at Oscar. Now, this is a bit tricky and this is also very funny. One of the things that I noticed, particularly because myself, I've been traveling a lot, not thanks to COVID anymore. Whenever I go to conferences or I, say I'm from Africa, I'm coming from Africa, people often confuse Africa to be a country. And now I'm not going to say, trying to fault anybody in, it's, we are humans make mistakes, but often people don't really want to make research, but it's also really welcome anyways. So Africa is not a country. Africa is a continent. It's a continent like Asia, like, North America, Europe, South America, and, like I mentioned, Asia and Australia. Now, I'm not obviously going to, show the map of Africa, but this is more of like to show you where the version 1 of our program started. Obviously in Nigeria, which is where most of the open source community Africa folks lives. So it's very typical for us to have more representations in Nigeria compared to other side of the continent. So over at Nigeria, when we started, I live in Port Harcourt, and my co-founder, she's based in Lagos. So that was the two main place for us when it comes to having local events. And eventually we grew to more cities within within Nigeria. And then while working on that, we were like, okay, it's time for us to expand. But then one of the hardest things in Africa is how diverse, the continent is in general, from things like language, cultures, and multiple things, right? So what we started doing was to closely work with individuals like our friends that are in these countries, and then see the best possible ways for us to expand the Oscar vision down to their community. And in order for us to do that, we created a chapter program, which I previously mentioned. Now we use the chapter program to expand to other cities and other countries in Africa. And this screenshot here was taken sometime around late 2019. So before 2018 when we started, and sometime around late 2019, we're in about 5 countries and over 11 cities. Currently, we're working on the version 2 of the chapter program that should enable us to cover as much African countries as possible, particularly do more in the south and probably do more in the north. So these are the normal ways that our community event looks. So from some photos somewhere in Kenya to some in Port Harcourt to some in Lagos and some in other part of Nigeria and other part of Africa. So what we normally do is to have a local, smaller event where we talk about open source and talk about contributions, or even do more hackathons or maybe hack some open source project. Now this is an amazing list for me, and this is a project created by a friend of mine called AceKid. Now we had back in Nigeria, again, going back to the GitHub research, there's a lot of projects coming out of Nigeria. One of the most popular one right now on top of my head is called Chakra UI. And it's being used by a lot of companies and a lot of individuals within the JavaScript ecosystem. And it just shows how amazing it is. Now, he made a list called Made in Nigeria. It's on GitHub. You can go search it up. And this is the way for you to see projects that have definitely come out of Nigeria into the global open source space. So you can, if you want to learn more about it, the link is down. I think it's called acekid.github.io/Made in Nigeria. And speaking about our community event, we were at some point, in order for us to make people to become creators and to have more open source projects, we started making them to work on projects that may improve the engineering skill or maybe designing skill or technical writing skill. So we worked with our partners, Open Collective, which is a platform where Oscar is registered when it comes to fundraising. And what we did at that time was to work closely with the team to come up with a bounty program that would be available within the Oscar ecosystem or Oscar community. And if you look at the slide very well, you see like price tag like $50, $100, and some other couple price tag being listed. And we closely share this bounty within the community, and people that wants to work with them definitely start working with them. Aside from the bounties, design is one of the important things here in Africa. Africa does have a lot of art, and it's very typical that you see a lot of designers coming out of the continent. And in order for us to make sure that we have a system in place that will help designers locally, particularly if they want to do more stuff, out of Africa, is by collaborating with the kind of, in my opinion, the main group that sort of helped shape open source design, which is the open source design.net group. So we started working with them closely sometime around 2019 with some amazing members within the team to kind of work with us closely to see how we could shape things. And one of the ways that we create diversity in Africa, particularly bringing more women in open source, is by partnering with a second organization called SheCode Africa. So SheCode Africa is a nonprofit organization that strictly helps more women into technology. And sometime around 2019 to 2020, Oscar was able to collaborate with SheCode Africa to bring more women into open source. Going back to the bounties again, this was basically what we were able to do in order to improve an actual coding experience for some persons that identify as developers. Now, this is kind of one of the highlights of the festival, and it's amazing showing how a group of individuals are coming together to discuss open source. Now, just like what I mentioned, right? The next billion creators. Sorry, this was a screenshot I took from the festival last year, but it just shows how amazing we've come, particularly for the open source community Africa. And it's one of the amazing things that I'm really excited about as a co-founder, seeing how we've been able to grow under the last 2 years. So anyways, thank you very much. Thank you. If you have more questions, please, you can probably follow me on Twitter. Let me see if I can go back. Yeah, you can follow me on Twitter at Samson_Godi, and we could talk more.
Yes, so as Samson stated, if you want to talk more, you can also hop in the live channel and ask your questions to him, as well as you can register your questions in the shared note folder. So Samson, it was really a great talk from you, and I am really happy the open source communities are increasing in Africa and knowing about it and Oscar. So what are your plans for 2021 open source communities and some of the events you will be organizing, if we can get some hints?
Yeah, thanks for having me, and thanks everybody for having me here. Like we know, 2021 is something that we are currently looking for because as previously we had system in place that helps to host people locally to have events, but now because of the pandemic and COVID, we're still
Yes.
looking forward to have something similar to that. We previously in 2020 had virtual events, and for us to reach out to more people, it was even a lot easier because you could easily tune in anywhere in the world and then you can watch, the events. But at the moment, we're working on like I mentioned on the talk, we are working on the version 2 of the chapter program that should enable us to reach out to more cities in Africa. So it's something I'm very excited about, and possibly hosting the second version of the Open Source Festival. I think you're muted. I think you're muted.
Shubham, you're muted.
Oh, my bad. Sorry, my bad. Sorry. I was so involved in Samson's good words that I forgot that I was muted. I was wishing good luck for open source communities in Africa and all the best. So,
Thank you, everybody. All right.
Yeah.
Bye.
And bye. Have a nice day. Welcome, Shivai.
Yeah, thank you so much, Shiva.
Yeah. So I'll.
Okay, thank you very much, everyone, for the experience so far. Okay, so we are preparing for the lightning talks, which are going to start in a moment. And yes, I also invite Hong Fook to support the lightning talk speakers together with me.
I'm here, Mario. Please go ahead.
Okay, great. So the way we do the lightning talk, so if you don't know what's a lightning talk, basically we try to share some information like in a very short time, and we give several people the possibility to have a 5-minute talk. So the way we are trying to do this here in the online event is to run a video for like 3-4 minutes and then give the speaker a chance to quickly have a comment, so to fill the 5 minutes. And let's see how fast and quick we can get that. So please enjoy the lightning talks. And I see like some people are already joining and sharing the camera, but actually we would like you to share the camera then specifically when your session is up, so not like the entire time. So Shivai, stay a bit and then we will do this in a moment. So Hong Fook is already sharing here the information and in European time zone, and we have Singapore time zone, for example, as well. Yeah. With the overview of the sessions. Yeah, so basically the first session is then from Raga Razanya. Raga, you already have a whopping 91 people who want to see your session, and I see a lot of people here coming into the talk. Probably the others are watching it on YouTube or other channels, so it's really great to see that. And Raga, are you there?
Yeah, hi Mario.
Yeah, it's great. Raga, please switch on your camera, and then we're gonna play a video, and you have your moment to share like a short insight or a short comment afterwards. So Hongfuk, please help me to play the video of Raga Rasanya Paruchuri.
Hello everyone. Share about the application of artificial intelligence to create music on this esteemed platform. If I were not an engineer, I would probably be a musician. I often think in music and live my daydreams in music. I can't remember a single day when I did not open up my music player. Let us quickly start by listening to a music composed by Magenta's AI tool before diving deeper. Interesting, right? Does it feel like a human composition or a machine made it? When humans are efficiently composing several kinds of music, then why AI? That's because AI is paving a way for every music enthusiast to generate their own music compositions in an easy manner. AI starts by analyzing the data from different compositions when it creates musical pieces. The algorithm learns what characteristics and patterns create music that are enjoyable, that mimic a certain genre. The AI model can also compose innovative musical numbers by combining elements in unique ways. Let's know how and when it all started. The earliest use of the computers to compose music dates back to the mid-1950s. As research continues, initiatives such as Google Magenta, Sony Flow machines, IBM Watson Beat, etc. AI tools can compose compelling music. Traditionally, composing music has involved a series of activities such as the definition of melody and rhythm, harmonization, arrangement, or orchestration. When a piece of music is performed, musicians add patterns of small deviations and nuances in pitch, timing, and other parameters. These patterns account for the musical concept of expressiveness or gesture, and they are necessary for the music to sound natural. However, now we are significantly being able to generate music instead of a huge orchestra with deep learning models. In 1980s, David Cope, a composer and professor of music with his experiments in music intelligence, built a foundation for many current AI models on the market right now. First, music and its attributes are encoded into databases, then the collection of the recombinant segments are extracted into a certain identifier and pattern matching systems. From there, the musical segments are categorized and reconstructed into logical musical order until new music output is produced. We will now see how Google Magenta can be used to create AI music. Why only Magenta and not any other existing services as mentioned before? Magenta is an open source library powered by TensorFlow, mainly for manipulating music and images, and use this data to train the deep learning models. The Magenta AI has three phases: the deep learning algorithm, autoencoders and music VAE, dataset, and training. Initially, the deep learning model has to be built using the Magenta library. Music VAE function allows the use of the autoencoders to create music by interpolating music, a sequence of music notes, encoded into a latent factor, and then decoded into a sequence again. A latent factor is a type of model that allows high-dimensional input data, and it allows for the smooth interpretation on the music sequence. Eventually, smooth and realistic output can be generated. Awesome, right? I had a lot of fun while learning about such emerging trends in music. Yeah, thank you everyone.
Thank you very much, Raga. That was some insights about AI, and yeah, you have some slides which we can also see. I think that they will be then added to the session.
Yes.
Are there any additional comments that you would like to share?
Yes, I have a video which has to be played. So it's there in the slides.
Okay, So that was the video, and you say you also have slides. The time is up, yeah, but I see a lot of people like you and already at a star here. Do you think you're going to win the popularity contest?
I hope so.
That would be really great. And please invite everyone to support you, of course. It would be nice to have somebody from BVRIT, where we ran Julia Test a few years ago, right? Hope we can do it again. Thank you very much, Raga. And we are moving to the next person. It was a pleasure seeing you.
Thank you so much. Yeah, thank you, Mario.
So the next person is Batram Hosha. I'm really unsure how to read this name correctly, but Batram, if you are here, please say hello. You are the CEO of Davos Networks, and you are talking about next generation penetration testing solutions utilizing human and machine intelligence. Batram, if you're here, we're playing your video now. Hongfuk, please help me to play the video. We are coordinating here now together.
Offering comprehensive cybersecurity solutions. Our flagship product is SwissBounty, which I'm going to present today at FOSSASIA Summit. SwissBounty is a cutting-edge solution that transforms traditional pen testing into a cross-source security platform by utilizing augmented intelligence to discover and secure vulnerable applications. Our vision is to develop the next generation a fully autonomous penetration testing solution. Our mission is to help companies and organizations find security problems before they become business problems. So what's the problem? 75% of the breaches occur on the application layer, leaving making identifying vulnerabilities a top priority for organizations today worldwide. And despite new advancements, such as enablement of the AI into the pen testing stage, still there is a lot of shortcoming. For example, there is a lot of manual and automated limitations for the current solutions of the market. There is lack of security testing into the software development lifecycle, which is also one of the our key approaches here into the DevSecOps environment. And there is no real visibility into the testing activity. On the other hand, by enabling AI into the pen testing, we also tackle one of the main problems right now in the industry, which is growing talent shortage, with 3.5 million positions going unfilled globally and 350,000 alone just in Europe. We are changing how we view cybersecurity, taking the new approach through the bringing the hacker mindset of operation, deeply integrating security testing into the software development lifecycle for dynamic, continuous, and adversary testing, and ensuring best practice standards to meet compliance objectives. Our solution matching machine intelligence with ethical hackers to provide actionable intelligence. Our value proposition, it costs less, is more cost effective, save the investment for human resources in pen testing, is more efficient, generating reports with zero false positives, as well as is more innovative, learning from behavioral ethical hackers and taking to the next stage. Our business model, B2B, with recurring revenue, bringing value in both ends. We are in a booming market and is growing at a fast pace. We target medium and large enterprises, mainly financial, healthcare, and federal agencies. Our revenue stream, primary focus, selling our cross-source and AI solution to enterprise customers that enhance continuous security testing by utilizing the power of crowd, and secondary focus, selling our automation solutions to our partners that already focus on traditional pen testing solutions. Our go-to-market strategy by driving awareness, problem solving, and partners in distribution. We have partnership already with some of the leading companies that we have listed here. We are well positioned to our competitors based on performance, as well as into speed, visibility, and scalability, and also our unique approach to integrating pen testing into the software development lifecycle. Our advantage is that the team that we both come from, the management team comes from expertise in the domain, or world-class partnerships, and access to large pool of talented ethical hackers, as well as our patent preparation for our solution. That's a little bit about the team who is behind the company. We all have collaboration with University of Geneva Information Security Lab. Some of our partners which we work, and some of the milestones that we have achieved in the end in the previous months. That also includes being part of prestigious accelerators here in Switzerland, such as Tech for Trust, which is a leading Swiss cybersecurity accelerator program. So that's briefly about our company, and I will be happy. We are always looking for new talent, and especially for people who have expertise into the ethical hacking space. So I hope you enjoyed the presentation, and if you please feel free to contact us, and we wish everyone at FOSSASIA a great time. Thank you so much.
Okay, thank you very much for this presentation. It was quite interesting, but I think the title was a bit different. It was more like a company commercial presentation that we weren't really looking for. But anyways, wasn't too long, so we are moving to the next presentation, which is about why blockchain is called blockchain, from Shubham Patel. And yeah, he's an open source contributor also here at FOSSASIA. And we're playing the video now.
Hello folks, how you all are doing? I am Shubham Patel, and today I'll be explaining why blockchain is called blockchain. So let's dive into the history of Bitcoin and blockchain. In 2008, a personality known as Satoshi Nakamoto invented blockchain and Bitcoin. In 2009, the Bitcoin network was started. In 2010, first cryptocurrency stock exchange was launched, and in 2011, the value of one Bitcoin was equal to 1 USD, and now on the current scenario of 2021, you all know the value of Bitcoin, and it's rising like this, a very good curve. Sorry, not a curve, but a very good line. And it's good actually. The cryptocurrencies, we should move on cryptocurrencies. Why? Because it's decentralized and it's honest. And many new cryptocurrencies are also emerging in this state, like Dogecoin. Second thing, Bitcoin is not actually blockchain. Bitcoin is a cryptocurrency which works on blockchain. So, our main topic of the presentation. What is a blockchain? Blockchain consists of many blocks. A single block is made up of four things. A previous hash, which stores the hash value of a block. A timestamp, which stores the value of the time at which the particular block was created. A TX root, which consists of the multiple transactions in a particular block. And a nonce. Nonce is the value which, when added to the hash of a particular block, and the first 30 digits or 30 characters of that particular hash becomes 0. 30 indicates the level of that particular block. So like currently it is 30, but when the blockchain was first started, or when the Bitcoin was first started in 2009, it was 8. So like you need to add the value of nonce, that is 1, 2, 3, 4, 5 till n, until the first 30 characters of that particular hash value becomes 0. And this is the work which the miners do. And once the miner found that particular nonce which is suitable for that particular hash value, he's awarded 6 Bitcoin according to current scenario. Back in 2009, the value a miner gets when he or she finds the particular nonce was 50 Bitcoin, but now it's 6, and it will be gradually decreasing as the mining of Bitcoin requires high computational powers and GPU powers. So this was the process by which a block is added into a blockchain, and a transaction is been successfully performed. And blockchain is a decentralized network, and every person in the particular blockchain can notice everything, can witness everything, and see each and how a particular block is added into a blockchain and what are the new blocks which are added. You can further refer this PPT for getting a brief or an overview about blockchain. And I think in this new era, everyone should know about blockchain. And in FOSSASIA event itself, we have great speakers on blockchain. And I hope this was a short introduction of blockchain, and you guys got an overview of it. At the last of the slides, I have mentioned some books which you can refer for getting in-depth knowledge of blockchain. You can also ping me on Twitter or any other handles. My Twitter handle is Shubham_Patel21. Thank you. I hope you like my small presentation, and I love to hear your doubts or have a conversation on you about blockchain.
Thank you very much, Shubham. And yeah, if you like, you can still share a short comment now, right after the video.
Sure. So I hope you folks have founded my presentation good. And with this, I also want to pitch one thing, that you folks can research about the founder of blockchain, and mysteriously he was just disappeared after the foundation of blockchain. So it's an interesting topic which you can more dig upon. Genesis block and the founder of blockchain. That's all. Thank you.
Okay, thank you very much. And we're moving to the next speaker. It's Kuku Serfat. Kuku Serfat, I think I remember you. You were also at the FOSSASIA Summit in Singapore in the past. And Kuku was talking about from Docker to Podman in 5 minutes. So I'm going to play the video first.
My name is Kuku. I work at Citra Digital Intas in product development. Let's start with Docker first. If you are a Docker user, you understand that there is a daemon process that must be run to service all of your Docker commands. Daemon problem number 1. Imagine that you are using Docker in production and the Docker daemon stops on an attended upgrade. It's a critical problem. Docker uses containerd under the hood. When containerd is upgraded, it stops and restarts its service. Docker stops when containerd stops but doesn't restart. Daemon problem number 2, still about daemon and containerd. When containerd was updated, it stopped Docker, then stopped containerd. When it was done updating containerd, it broke back online, but Docker stay stopped. Here is a comparison between Docker and Podman. Podman is nearly functionally identical to Docker. Both solutions are container runtimes, and they are able to use the same OCI image. Even the syntax is mostly the same, the key difference is how they handle the container stack. The most significant difference is the absence of a centralized daemon. Podman is a daemonless container runtime, and that's the really cool part about it. There is one more big advantage for Podman over Docker. Podman not only can run containers like Docker, but also can run pods, as you find on Kubernetes. So that the name is Podman. Podman is a daemonless container engine for developing, managing, and running OCI containers on your Linux system. Container can either be run as root or in a rootless mode. Simply, you can use alias docker equals to Podman. Why we use an alias? Because most Docker command is same with Podman command. For example, docker run, Podman run, docker info, Podman info, docker logs, Podman logs. and so on. But please pay attention also. Not all Docker command equals to Podman command. For example here, Docker container rename, because Podman does not support container rename or the rename shorthand. Also Docker container update, because Podman does not support all 13 running containers. And the others like Docker node, Docker plugin, Docker secret service, stack, swarm, and the others. How about Docker compose is equals to Podman compose? Fortunately, since version 3.0.0, Podman has initial support for Docker compose, and the latest version is 3.0.1. Here is about Podman and Docker compose. The first is we can start the Podman system service. Number one is be sure the Podman, Docker, and Docker compose packages are installed. And number two, enable and start the Podman system socket activated service with sudo systemctl enable start Podman socket and verify the service. And then after that, we can run a compose. For example, we can use a compose from github.com/docker/awesome compose. Here is a WordPress MySQL. And then bring up the containers with Docker compose up, and then verify the containers running with Podman PS. And the last is verify WordPress is running using the localhost and port 80. Acknowledgement to my friend Rifki Avandi at Awan Sakti and Open Society for Diamond List with Podman material. Last but not least, we are in Citra Digitalintas hiring for Go, React, Docker, and Kubernetes. Please join us. Thank you and stay safe, everyone. Bye.
Thank you very much. And yeah, that was quick insight in 5 minutes, and we're moving to the next session right away. So the next session is about establish a friendly, welcoming, and collaborative project culture with Avik Basu and Till Kampeter. So we're sharing the video, and after that you have a chance to add your comments.
Hello everyone, this is Avik this side. I'm the manager for and along with me I have Till Kampeter. He is the project lead for open printing. Hello everyone, this is
and I'm leading the open printing project.
Welcome to this lightning talk about how to be a welcoming community, or how to be collaborative, how to welcome new members in the group. So today for the next few minutes, we are going to talk about that topic. So before moving forward, let me just present my PPT. Okay. So as I said, the topic is establish a friendly, welcoming, and collaborative project culture. So the first thing is you need to understand who is a new contributor, or what is the mindset of a new contributor. So a new contributor is somebody who is in a learning curve, who is still adapting to the changes, or who is adapting to the project jargons. Or everything is new to that particular contributor. So all the jargons that you are using for your org is new to that person, and initially that person will be hesitant to ask, so it requires a lot of hand holding. So to be a good mentor or a good community mentor, you first need to feel like a student, or as a new contributor first. As a welcoming community, if that person is in touch with you, then you are the face of the org. So the veteran member is the face of the org, the leader, a communicator, a technical guide. So somebody who projects goals of the org to the new member. So the veteran member is a primary face of the org. You need to keep that in mind. You first need to be a gardener. So train the basics to the new member. guide on the initials, handhold till the path is steep, give them as issues to work on, give them some initial assignments, give them some, to start off, maybe you can just give them some changes in the documentation, recognize their achievements and make them feel the ownership. So you first need to nurture your saplings if you want to see them grow into a big tree. Best practices, what you can follow is you can have meetups, you can approach your community members, ask them what problems they're facing. Keep the technicalities simple. Initial things should be simple. Do not add on complexity. Your communication should always be good. You need to understand that that person is in a learning curve, that person is shy, that person is hesitant to ask. So break that ice. Be always be available whenever they need you, otherwise they will not be comfortable. So these are the few of the best practices you can follow. So to be a good gardener, you need to follow this, and you need to keep this in mind. Good gardeners create good contributors, and good contributors build great communities. This should be the motto of any org to if they want to be a welcoming group. So that's it about today's talk. So if you can get in touch with us in our email IDs mentioned in the screen, we'll be very happy to collaborate or discuss further. So if you have any questions, do let us know. Thank you.
Okay, thank you very much. And I saw you already here in the session. You have a chance to add a few comments now. Avik and Till, please.
Hi, Mario. Thank you for... Yeah, I think the video is not... hello. Yeah, so our presentation was very short. What we wanted to project is like how somebody can welcome a new group because, we have been working on this. So all these are based out of our experiences, what we have, typically felt through our open source journeys in our org. So, if somebody has any questions, or if somebody wants to discuss further, feel free to get in touch with any one of us through email, and we'll be happy to discuss on that. So we have been working on this area of community management, or these areas of how to make new members comfortable in a group since some days. So we'll be happy to help if required.
Okay, excellent. So yeah, if that's all, then thank you very much. And Till, you didn't say anything, but we saw you, and yeah, I remember you from some other events.
Yes,
so
yes. This method which we are using to get new community members, I think we are already doing for 3 or 4 years or so, and it is working rather well. We got a lot of people into our project, which is by itself not too attractive. It was before it was really difficult to find people, but now it is working well. Great work from a week.
Thank you, Till.
Okay, so thank you very much for giving this insights into your project and approach, and I'm really happy to see an open source project and a free software project like yours thriving. So thanks for sharing. Have a good day.
You too, Mario.
Thanks.
Okay, and we are moving to the next talk, which is from Shiva Lamba. Shiva, I've seen you already before. We're going to share your video first, and after that you can share some comments. Shiva is talking about the rise of open source development programs for the underrepresented.
Hello, programs for the underrepresented people in tech. Now, first of all, let's understand what exactly is open source. As it breaks down into 2 words, open and source. Open meaning that it is open for anyone to come in and use, anyone to contribute to it, anyone to use it at any time without any restrictions on the geography or the race or the gender of the person who can contribute to it. And source means that the source code of that project or that program is completely open sourced, that it is completely visible to the public. It's not closed, or it's not something that is paid. And usually a lot of the open source programs are free as well. So the main idea behind open source is that anyone can come in and contribute to these kind of projects. Anyone can come in and share their ideas, and that is the impact of open source, that it brings in hundreds and thousands of developers from across the world to come and contribute to these projects. And this makes it a global collaboration, and even small changes to these can impact softwares that are being used by hundreds and thousands of people. So anyone who is contributing to open source can really get a lot of experience of software development and also real world software development practices that can help them. And again, with open source being very collaborative, it is much better in terms of security and in terms of getting bugs fixed, as compared to closed source software. So it's all about collaboration, all about contributing, and anyone can come in and give their suggestions and contribute to the code base of these open source projects. Makes it very inclusive for everyone. And that is the reason that we are seeing a rise of open source programs for the underrepresented sections in the tech society. So when it comes to tech, which is usually male dominated, we have seen the rise of the underrepresented parts of the sector. For example, like the women in tech, or people from the LGBT community, or people in color, also coming in now and contributing to open source. And there is an active advocacy for the number of users who contribute to open source belonging to these underrepresented sections. And over time, there have been a lot of different open source programs that have come up and are specifically made for the people from the underrepresented sections of the society. So one of them being the Rails Girls Summer of Code, which unfortunately got shut down last year, but hopefully it might be revised. Again, it is meant for the people from the underrepresented section of the society. Then we have Outreach, which is a currently going on mentorship program that provides 3 to 4 months of internship program with a stipend to a lot of different open source projects like Mozilla and FOSSASIA, a lot of different other organizations where the people from underrepresented parts of the technology can come and contribute to these projects. Then we have the Girl Script Summer of Code, and the main idea for all of them is to enhance and enable the people from the underrepresented sector of society to come and contribute to open source projects, real world open source projects that are being used by hundreds and thousands of millions of people. And their main their main goal is to present the ability for these underrepresented parts of the society to come and contribute to these open source programs and learn. And again, basically to empowering the developer communities with open source. And that brings up to my end to my talk. You can connect with me on my LinkedIn at @Shivai Lamba and Twitter at @HowDevelop. Again, thank you so much for watching this talk. Again, stay tuned. Thank you so much.
Thank you very much, Shivai, and you can share some comments if you like now. Unfortunately, I can't hear your microphone, but I can't debug the problem right now. Maybe refresh your browser, but I can't hear you. Manu, please still wait a moment because it's still with Shivai. Okay, and I will use the opportunity in the meantime to share this information that we are also running a workshop tonight. It's starting now in a moment in the workshop room. You can access it through the panel on the left-hand side. It's about web development, Python, JavaScript, and Open Event. So if you're interested in that workshop, it's starting in a moment. Shiva, I can't see that your microphone is on and working. So yeah, I think we'll just progress to the next person, and maybe Shiva can have the opportunity to join us later, or is it working now, Shivai?
Yeah, am I audible now?
Yes, you're audible. Okay, go ahead.
Yeah, so I'll be very quick, and as you know, like, thank you so much, Mario, for the opportunity. I just wanted to share a couple of points, and the major one being that open source is inclusive for everyone, regardless of experience. So whether you're a software developer with 20 years of experience, or you're a product designer, or even you're someone who is from legal stuff, all of you can come and contribute to open source. So open source does not have any foundations or limitations. From any part of the world, you can come and contribute to a project at any point of time, during the day, during the year. And most of the open source projects are always welcoming to newcomers, because they appreciate new people joining in and contributing to their code bases. Because the reason that they have open sourced it is that so that the world, people from around the world, can come in and use those kind of products and can actually come and contribute to them. So some of the few open source programs that I mentioned, those are all inclusive for people who belong to the underrepresented parts of the society. Now we are seeing a rise for them in not only in contributing to open source, but also in driving the technology. And that is probably the biggest factor that makes all of us happy, because now everyone is going, and it's not one part of the section of the society that's dominating open source. It's everyone, and it's all inclusive. And that is the main aim of open source.
Excellent. Yeah, really inspiring how passionate you are about this. So thank you very much for sharing. Yeah, thank you. Okay, and the next one is Manu, or Manu. Like sometimes not sure how to pronounce the names correctly. Manu Dasari. Yeah, we've seen you shortly already, and we're going to play your video first before you can share some comments. Manu is talking about hyper agility and being a smart, agile enterprise.
You actually use agile practices today, along with artificial intelligence and automation? A show of hands. For those interested, you could also scan in the QR code on the screen for putting in your inputs in a short survey as well. Now, based on what I have seen in the past, I would say not many. Now, this is sad, given that hyperautomation is one of the latest trends from Gartner, which combines automation and intelligence. And I would define hyperagility as augmenting automation with artificial intelligence to the agile practices. How does this all work? Let us take a scenario. For example, meet Pete. He's a product owner for a financial services business, and he would like to create a web platform solution for his customers. Now, he's never done user stories before, and he's new to the agile ways of working. Now, Pete takes a long time to brainstorm his user stories and to come up with the priorities for his backlog, as he doesn't have the right data insights to make the right decisions. So how can we help Pete? Pete can use hyperagility in various examples. For example, in the first one, there can be intelligent user storyboards that help Pete to augment his everyday activities during the discovery and inception phases of the Agile project lifecycle by giving helpful hints for the user stories, something like Google. Secondly, he could also have machine bots that help with the auto grooming of the product backlog, with priority suggestions based on the data analytics that is integrated and delivered to the product backlog. Thirdly, He could also integrate his DevOps dashboards with the real-time mining of the customer data insights to identify the value delivered. Now, Pete benefits with hyperagility because he has improved productivity as is able to come up with a breadth of user stories prompted by the intelligent bots. He has better access to data and is able to prioritize the stories in his backlog based on the customer insight suggestions by the intelligent bots. And more importantly, his company has improved ROI with the optimized deployment of resources. It's no surprise that Pete benefits from hyperagility. In fact, 9 out of the 10 AI leaders are advanced in data management, and 74% of them who are planning to implement these are having sophisticated data management systems plan in place to be done by 2023, according to a benchmarking study of over 1,200 companies. Now, what's next? Does it mean humans will be replaced by robots? Not really. They will be augmented by robots for better productivity. So what tools can be tapped? You can refer to the ThoughtWorks Looking Glass, which provides a list of trends that you can watch out for and best practices to adopt. And what does it mean for my business? You can explore how artificial intelligence and automation may join your mainstream agile practices in the next 5 years. Now, this is a snippet of the ThoughtWorks Looking Glass that you can have a reference to. That's all for my talk today. If you have any inputs, please scan the QR code here and give your thoughts on hyperagility. Thank you.
Thank you very much. Manu, any final comments?
No, great to be part of this. This is just an idea. So for free and open source software, if anyone is interested in building these type of solutions, very happy to collaborate on that. If there's any other questions, do drop me a note. Thank you and bye.
Thank you very much for sharing. Appreciate that you also show up so quickly. Thank you.
Okay.
And yeah, we have the next talk coming up, next lightning talk here. In a moment, yeah, I just wanted to mention to everyone also that the workshop is starting in the other room. And Hofuk, are you ready also for the next lightning talk? I seem to have lost my tab here with the overview. And here I'm back. So after Manu now, we have Stephen Jacobs from Open at RIT, our model for an academic OSPO. Stephen, I don't know if you're here, but we'll watch your video first. And if you're there, you can have yeah, some comments afterwards.
RIT has a 12-year history of engaging with our students around open source and humanitarian work. This includes our courses and our minor in free and open source software and free culture, our FOSS at Magic program, which provides students the opportunity to engage through open source in hackathons and other activities, and via our LibreCorps program, which provides students the opportunity to have cooperative experience educations, i.e. internships, with non-governmental organizations and humanitarian groups. Open at RIT is a key research center and the Open Programs Office for the Rochester Institute of Technology. It provides support to faculty and staff around their open work, that is, free and open source software, open source hardware, open educational resources, open data, open science, and related activities. We will be providing professional development content to faculty and staff who want to learn how to get involved in those areas or do more work in networking around those areas, both on and off campus. We offer monthly meetings and office hours for consultation on new or continuing projects. We support proposal and grant writing when the grant is for open work. And we offer the Open at RIT Fellows Program funded by the Alfred P. Sloan Foundation. This fellowship is awarded through an RFP process to faculty and then provides them with the same type of LibreCorps support that we provide to NGOs and humanitarian organizations. We have been chartered for the next 2 years to provide advice on policy, procedures, and compliance for open work, on guidelines for the evaluation of open work for annual review, tenure, and promotion, and on the collection of metrics on the open work done by RIT faculty and staff. The idea of an open source programs office for academia is a new one. As a result, we're working with a number of different organizations. OSPO++ is a group of academic, civic, and industry leaders who are interested in building more and more open source offices in academia and in urban management. The To-Do group is the Linux Foundation's Association of Open Source Program Officers from their membership. The Chaos community creates the metrics collection and analytics software Grimoire Lab. They're looking to build academic metrics into that system. The Linux Foundation as well is looking to grow more opportunities for academia in open source, and the Sustain OSS Academic Working Group is also looking at these plans. The IEEE SA Open Academic Working Group is built around the IEEE's brand new open platform for open source development and community. I hope you found this brief introduction to Open at RIT of interest. Feel free to get in touch if you'd like to learn more.
Thank you very much for sharing this. I don't see Stephen here in the chat right now, so we're progressing then to the last lightning talk and actually the last session here in the main hall of today. It's from Neha, and Neha will be talking about what is React server-side rendering and do I really need it for my web application? So we're playing the video now from Neha.
Hello, topics we're going to cover in this talk are different ways to render a web page, what exactly is happening during each rendering, and a comparison between them. As most of you know, there are two ways to render a web page, that is client-side and server-side. Let's start with client-side rendering. So this is how the whole process of client-side rendering will look like. When the server sends a response to the browser in form of HTML, which will just have the skeleton of the web page or bare minimum code. Browser downloads the JS to have the page in an interactable state. Browser executes React, any other templating library that you might be using. When all this is happening, you will be seeing a loading icon on your browser to maintain the calm of the user. Once the browser completes execution, the page will be both viewable and interactable now. So let's see server-side rendering. It's a little bit different than CSR. In server-side rendering, server sends ready to be rendered HTML response to the browser. The browser renders the page and now it will be viewable. And then browser downloads the JS. Browser executes it. When all this is happening, you will be seeing a viewable screen on your browser. Once the execution is completed, the page will become now interactable. So this is to highlight the difference between these two. In CSR, though the page will be up a little bit later, but once it's up, it will be both viewable and interactable. Whereas in SSR, the page will be up sooner, but you need to wait a little bit longer to have the page in an interactable state. So as you have seen, the server-side rendering renders the initial load faster. It is because in CSR, it requires more JavaScript to be downloaded and parsed, and also needs to make a second HTTP request to load the content. Whereas in SSR, your server's response to the browser is the HTML of a page that is ready to be rendered. Hence, the rendering is faster. So you might be thinking, which is better for me then? It's not all black and white, depends on different conditions and scenarios and priorities that you might be having while building your web application. Let's have a quick comparison between these two to understand that. The advantages of SSR over CSR are initial page load is faster. As you have just discussed, the blank page flicker that happens with CSR isn't a concern for SSR now. It's great for search engine optimization since the content is up before we get it. The search engine can crawl it and index it efficiently, which is not so possible with CSR, at least not simply. It's great for static sites. So if you think of heavily text-based sites like New York Times, SSR is a preferable approach in those scenarios. The disadvantages of SSR over CSR are require frequent server requests and hence can create bottleneck for the sites which are highly interactive. Throughput of your server is also less compared to CSR. The method that we use in React app to enable server-side rendering, that is React DOM server.render to string, is a synchronous CPU bound call, which will hold the event loop and hence the server will not be able to process any other request till it completes. So it's a big consideration for the application which are going to be highly interactive. And overall slow page rendering, since the content, so though the content is rendered and the consumer can see it sooner, but you won't be able to interact it until the browser completes execution. All these reasons lead to non-rich site interactions. So when to use SSR? You might want to use SSR if you need it for search engine optimization. You already have a working React app, need the best possible performance and are willing to pay for the extra resources. And also if you're planning to have a heavily text-based sites. You might don't want to use SSR if your React app isn't finished yet, get it up and running, then worry about the optimization step. Server resources are scarce, perhaps due to low budget or inability to scale. Yeah, that's all. Thank you.
Thank you very much, Neha. And I see you are here. Please share some final comments.
Yeah. Can you hear me now?
Yes, you're audible. Thank you.
Yeah. Oh, hey, everyone. Yeah, thank you for giving me the opportunity, and I hope you find the session useful. And I hope it gives you a good idea around how one can decide the approach, rendering approach they might want to use for their web applications, considering the facts that we just talked around this in this session. And also there are various companies like Quora and Walmart, which have been using server-side rendering, and they have seen huge improvements, performance improvement for their web applications. While there is Netflix, which has like gone for the hybrid mode, is like mixed of SSR and CSR. The initial content is rendered via the server-side rendering, and rest other is being handled dynamically by client-side rendering. So it depends upon like what type of web applications you are basically targeting, and based on that, like you can decide what is best for my choice. Yeah, I hope that like gives you a good idea around it. Yeah, thank you.
Excellent, Neha. That's really like nice to see how like much you're into this topic. And as we are not using React so much yet here. I mean, I think we're using a bit, of course, in the SUSE AI web project and so on. But for example, in Eventia, we're using other JavaScript frameworks, and we're looking if we can also use React.js. So yeah, definitely it's a good starter for me. And we are at the end of today's sessions. There's still
Mario, I think
yes.
There is a question for Neha if you want to type the answer or something.
Yeah, Neha, oh, that's nice. Thank you very much, Van Fook. I have a question. How are there more requests in SSR when CSR also has a lot of JavaScript calls which might block the parser? I'm not sure if that's a bit too deep, because usually we only have lightning talks, but you are the last one. So Neha, and that's by chance, actually, we didn't plan that, but I would just like give you an opportunity. Any answer to this?
Yeah. So because why there are more calls in SSR, because like so you will get the fully rendered page that will be just for the like HTML of your web application, but there will be no dynamic calls, right? Like and for initially rendering the whole page, you need to make a JAX call to get the JSON, which will like dynamically iterate over it and render that content. And there will be separate call for further on thing. But in server-side rendering, what happens is like even if you are not doing it lazily loading, what happens is that everything will be loaded at the first go, and hence that the like render is a bit slow. But once all the content is being rendered, everything will be on your web, on your client, on your browser, and it will be like easy to handle it. So you don't need to like iterate each call and again, which will slower the performance here. I hope that answers your that answers your question.
So at first I saw Pulkit was still typing something, but now he stopped. It looks like that answers Pulkit's question, and that's really nice. So Neha, I don't know, like, do you have a moment longer time? I think like we could have a short chat as we are just here at the end of the day. Yeah, so this is very nice, and oh, I see more people are typing SJ. So if anyone else wants to join us, please switch on your camera. We can also have a chat with more people. So Neha, may I know, like I'm always interested to understand a bit where the participants of the event come from. So where are you based, in which region?
Yeah, I'm based in London. Yeah, it's in London, Elford. It's in East London.
Yeah. Okay, so nice. So you and you found out how about FOSSASIA, about the summit?
Yeah, it was great. Actually, I have submitted the talk last year as well. It's just that because of this pandemic and everything, I didn't get a chance to attend and everything. But I was like really excited when I found my topic selected. I was really looking forward to this talk.
Yeah. Oh, that's nice. And so did you have the chance to look a bit through the program? What's interesting for you?
As in, I am a core front-end developer. So yeah, I'm like very much interested into web and mobile technologies. It's just unfortunately the workshop that was happening it's related to web and mobile technologies, but at the same time I had my session, so I was not able to attend it. But yeah, I will go through the recording though.
Yeah, actually the workshop is still happening. So okay. If you want to head over, Arip is doing it, and we're also streaming it on YouTube. I'm always impressed by Arip Jamal. He's our head of development. Mm-hmm. And yeah, he has so much knowledge that I'm sure everyone can learn something. So Neha, thank you very much. I hope to catch up here somewhere else, maybe in the event. Like nowadays, we don't have the chance to just meet by chance in the hallway, right? Like, and I'm just using this chance now as I saw you. So thank you very much, but you can stay or you can go to the workshop. Just feel free to do what you want. Or for example, if you want to ask SJ something, it's probably Stephen, right? I was looking. That's correct, for Stephen. Yes. I didn't know that he was SJ because I didn't know who's SJ, and I was looking for Stephen to give you the opportunity to also add some comments to your short presentation. Yeah, so maybe I would just.
Yeah, if there are any questions about the university, how an open source office works for a university, or how Open at RIT supports faculty and staff, I'm happy to ask them.
Yeah. So yeah, does anyone have a question? Please feel free to butt in, or for example, ask this. Harish Pillai, since we're keeping to UTC timings, individual country time changes are a local issue to manage. I don't know how that is related to time change in East Coast and this and that. Oh yeah, so time zones are a big issue.
Yeah, we just jumped ahead an hour on the East Coast in the U.S. at 3 a.m. this morning, and which clock was telling me which hour I hadn't caught up on. So I'm a little late. I'm sorry for that.
Yeah, it's a challenge. That's why we actually implemented, like we started around 2 months ago when we heard about this time change this weekend, that we implemented a way to add your personal schedule in Eventia to your calendar. And then it should show up, right? we never had this problem before because usually the event is run on site and then everyone is in the same time zone.
Of course, yeah.
Right. So, but like, thank you very much for like joining it and joining up. And definitely, if you have some experience with our open source event management tool here, we're happy to take your feedback and you can add issues. Stephen, but like apart from that, how is it going in the university? How are OSPOs progressing? I don't know, I heard a bit that Google cut down some programs in OSPO in the past, and OSPO of Google, for example, is now part of the cloud. Of course, I'm not in an internal, I don't know what is true, how it's really handling, if it's like reshuffling and so on. But I see things like that, and I'm not sure, I don't have all the information, but how are OSPOs going in the US? You probably have a lot of insights.
So in industry there, the cloud services and Google, there's this group called the To-Do group. If you go to your website, To-Do group, it's part of the Linux Foundation. You can search on that, and that will show you it's a group under the Linux Foundation of about 50 or 60 organizations that have their OSPOs, it's the open source officers on their organizations, and they get together and discuss how those are going. For universities, it's a very new thing. Johns Hopkins University only started about 18 months ago. My university we started in August. And there are lots more universities in a group called OSPO++ who are talking about getting together and putting open source offices within a university. So within a university, we have many clients, if you will, right? So an OSPO and a company, they serve their staff, right? Everybody's an employee. It's very clear. It's very basic. For a university, you have students, you have faculty, and you have staff. So you have people with three different rights situations, yeah. So staff are staff, and they have to do what the university says. At my university, students own their own IP, which is not something that happens very often. Often the university owns their IP. So our students have to be served in a different way. And then faculty are supposed to publish and distribute their research, but they're also supposed to ideally be able to patent or do things with the university. So how do you figure out what the university owns, what the faculty member owns, how they want to collaborate? So there are all those differences. And then before there were OSPOs at universities, the library has a policy for open access, what you're supposed to do with your research and whether you publish it in a journal or whether you publish it widely without any rights. You have the people doing scientific research in the open, you have data, you have open hardware, you have open software. So all of these are different licenses, and how is the university going to interact with those, and who has which rights there. And that's only one small piece. OSPOs also want to be able to educate people, to support them in their work, to train them on how to work in the open source world. So it's a very new area for universities to look at.
Stephen, you're already jumping into a full mode presentation here, giving us so much information. I have to get into this, but I also see Hongfuk is joining. Unfortunately, Neha left, but Neha, have a good time. And if you have any question about OSPOs, I also feel sometimes open source programs offices, many people know it, and they, for example, the young people, they benefit from it at sometimes when there are some programs, but they're not always familiar with abbreviations. I had it a few times today when I received bios of some speakers, and they had a lot of abbreviations, and I'm not a native speaker, and we have such a big diversity here, right? So OSPO is an open source programs office for anyone who is still interested and still listening. Actually, just for information for everyone, the official program is finished here in the main hall. We still have workshops on web development with Python and like open event setup and so on in the workshop room. Please go there if you're interested. And yeah, we just take the opportunity here to have a bit of a casual chat. So if you want to drop in, please feel free. And I think like Hongfuk also has some interest in this topic, as you're working a lot with open source, inner source in the different areas. Hongfuk, any question or anything that you would like to mention at this point here? Nice that you're joining.
Yes, I do want to say hello to Stephen. It's great to see you here. I just met him a few weeks ago. We were on a panel together talking about OSPO as well. And I think that it's really interesting to see that the universities also adopt open source on a like top-down level now. You know, if you look at a university around Asia, we see that open source movement like coming from bottom up. A lot of university student groups established themselves. They have in Singapore very famous the NUS Hacker Group, right? Coming from like student initiative, but now like something coming from the management level of the university. This is something that really exciting that open source got now adopted in the like academic sector. I actually one of the team members of the FOSSASIA Summit, Jing Chu, who works together, who works at the university at SUCD, Singapore. University of Design and Science. So in the university, they also established an open source program. So I think it's called open source department, something similar. So I don't know. It would be interesting to hear from Ching Chu, but I don't think that he's here today. He also like try to talk to different people and get exchange how to set up. The open source program in the university. Sorry.
So on the student side, we've been very active for a long time. We have a Linux users group that the students run, and we have my program that's been running for 12 years, and we teach classes, and we have an academic minor, which in New York State is 5 courses, a sequence of 5 courses in open source.
Cool. And I just like with the topic of abbreviations on folk, right? It's always like confusing. What is it? You know,
technology and design. Because I was just thinking about the science center where she have a talk with Kuchurika when she talked that she also tried to push science and open source for younger students.
Oh, I see Harish Pillay listed up on top of my screen.
Can we see you, Harish?
Several years.
We want to see Harish.
Yes, hi. Hi, Stephen. We last met at your campus many years ago. I'm good.
Yes. How's Red Hat?
Doing extremely well. All right. So what was the question? I'm sorry. Someone was asking a question just now, or what was that about? About OSPO, right?
OSPO. So what about Red Hat's OSPO?
Yeah, well, we do have an OSPO. We had to rename what we had before. We had called it OSAS, OSAS, Open Source and Standards Group. We renamed it only so that we can have some sense of consistency across other organizations. It's not that we need an OSPO. Honestly, we don't need one. But, it was a bit odd that we don't have one. So fine, we renamed it. But I think the bigger picture is that, what's the value of OSPO? For an organization like us, we are already by default open anyway. So we don't need any inner source kind of work that we do. It's all open anyway. So we go straight to the endpoint, which is, everything's open. So OSPO, in many sense, we try and help educate people. Not necessarily internal, but it could primarily be external entities like our customers and all that who need to understand how do you collaborate and contribute in open source projects. So that tends to be a lot more of the stuff that we do, but not exclusively in any sense. Whereas a lot of other organizations, when they have an OSPO, it's really trying getting the internal workflow and projects and so on to follow open source models and of collaboration, and eventually hoping that those things will become open source themselves. So we have a different focus, although the label is the same.
Yes, the Red Hat originally OSAS, now OSPO group is a very strong group. I still work with Ruth Seeley and with Harish many years ago to do a faculty training program on our campus. So they're great ambassadors and supporters of open source, helping other organizations learn what to do. Other organizations have how their OSPO works on their web pages to tell their staff how to do it. Red Hat does it to be kind of an example for people to follow.
It's actually a tough thing in many ways because we are not constrained by traditional copyright issues and traditional patent issues and so on. Yes, we do have software patents, but our patent promise has always been anybody can use it as long as it's used in an open source project, and you don't have to ask us for any permission. And everything that we do is on an open source license anyway. So that sometimes it's a challenge, and many times, why do we need to have an OSPO? But okay, we need to have one so that we are consistent across other organizations.
Yeah, so I have a question here. I mean, it's like if we generally talk about OSPO, everyone say, oh yeah, it's a good idea, right? Like supporting open source and so on. But what are the controversial topics here? There was recently a blog entry of Simon Phipps, what OSPO could do, or like what it shouldn't do, or like, I think you've read it, you're aware of it. So where are the controversial topics? I mean, it's not always visible from the outside what an OSPO does. I sometimes have the feeling that different OSPOs, they might have the same name or similar names, but they're doing completely different things. And where are the controversial questions? Because that we support open source and free software, free and open source, that's always good, right? But where's the controversy?
If I may add to that, to your question, perhaps we want to look at it from a perspective of organizations that have never done anything that is openly contributable, that is on an open source license, do not have the cultural background to that. And when that is the situation, they need guidance. And so that's really what OSPO can help offer. I'm sure most of you would know Jacob Green. Jacob has been championing an open OSPO initiative for governments, for universities, and so on. So his challenge has also been one of having the conversation. I think, Stephen, you mentioned something about universities, issues with, copyrights and what have you. So that conversation is where the biggest problem is, not understanding sufficiently.
So it's in a university setting. It's funny that I often have controversy on both ends, or need to educate on both ends, because the college professors who have always been involved in open source, I've always been doing this, and why would I need to follow these rules, or why should there be standards in how I set up my repos? Why should I have a README or this or that? Why do I follow your policy? And then the other people who don't understand what an OSPO is at all. So you're kind of in the middle. Part of what an OSPO does is set up processes and licenses. They'll specify a given license or a set of licenses. They'll say, well, you need these things in the repo to talk about what the policies of the university is. There's a code of conduct that you want to follow because you're representing the university or the corporation, depending on who you work for. There's contributor license agreements, which are very controversial. People who have been used to contributing to open source projects without signing any kind of agreement are now being asked to sign agreements, and it's mostly to keep people protected, right? You try not to do this as an individual, you try to do business as a legal corporation to protect yourself from liability and things like that. You also try to do that with an OSPO. You're putting something out there. You want to make sure that you're protected and that you're also working within a structure that protects you. Does that make sense?
I have a question here. So follow up on what Mario said about different scopes. So what exactly the OSPO of the university? Is it about define the policy and try to support the people? What are the initiatives? What exactly you are doing there?
Okay, so we have initiatives around policy. One policy around how to make your stuff open. A second policy for faculty for their tenure and promotion. Generally, historically, you want to publish something in a journal, right? You need a peer-reviewed journal to have it be validated. So trying to have open source work be looked at even level. Then we want to train faculty and staff and students who don't know how to do things in the open, or maybe somebody who has a proprietary piece of research they would now want to move in the open. How do they do that? How do they make that happen? We actually got a grant from the Sloan Foundation, so I now have a funded team for 2 years to work with faculty who want to put their work in the open. They can work with this team who will have a staff member and a rotating team of students who will help them around licensing, about setting up repos so that people can access things appropriately, to move them off of proprietary packages they may have been using onto open packages. So we really try to do a lot. It's not just policy, it's not just compliance, it's training, it's support, all those things.
So that is great to hear. So actually, you mentioned about the open source release process. So if the faculty work on a project or work on a software with the student, and if they want to release to open source, so this is the policies. I see it on the to-do group. I also release something with the company that I work with, as Zalando, right? I mentioned before we have the open source release process that I release on the website. So it also like a few simple step, but I think what would be more interesting for me is if we have, if the university work around to bring open source to education, to have the topic, you know, how students can contribute to open source project, or what are the latest technology, because normally what students learn in school is a few years behind. So it's great that we have the release process, but is there something involved like educate students, what is the benefits of open source, and engage them to contribute to open source, existing open source project, rather than getting a few group together, work on something and release it, and then you follow a process. And I also understand when you said that we need to make sure that it's a correct license if we want to release something, but there's also a lot of compliance software available these days. Yeah, so Microsoft also released clearly defined. There are also like many like software where you can do the scan, and they will tell you, okay, it's in the code, this and this license, it's not possible to release. So that's what we do here with in Europe. So all the tools out there are there. So I understand it, but for me, it would be more interesting to see this put in education in the classroom for the students somehow.
So I just put in the chat a link to the blog of my students who are taking my first open source class right now. So you can look at what they're doing in class. What we focus a lot on is community, and what the Sloan grant supports is community. It's not so much a faculty member wants to put a license on something and put it in a repo. It's that many people think you put a license on something, you put it in a repo, and you send one email, and then magically in the morning there is a whole community there ready to work with you. And that doesn't work that way. So the support is for things like, how do you prepare a repo so that faculty, so that open source people want to use it? How do you get yourself out there? How do you publish your documentation? How do you, what groups do you get in to try to bring more interest to your work? So the support isn't around programming or licensing, it's around building a community now that you have a project. Does that make sense?
Yeah, it makes sense. And I also want to include Neha a bit, like Neha has taken the time here to join us. And so, yes, so this is nice. Neha, what should OSPOs do? What should we do to support open source communities? What's the perspective from your side? No, you need to switch on the mic.
Yep, you're muted.
Hey, yeah. First, I would like to say hi to Harish. I have been part of Red Hat earlier for 4-5 years. So yeah. So as a part of OSPO, though I haven't exactly worked for OSPO, but I have been contributed to open source projects as a like when I was part of Red Hat organization. So from the open source perspective, as SJ mentioned, the code of conduct, like the consistency, because there will be lots of contributors who will be contributing to the open source project, and the consistency, because each one will have their own format or own pattern of writing code. So how we can maintain the consistency across all the contributors, that they will be like writing code and pushing the changes towards. So the first thing is that we should have a proposal or a format in the repo, just to let them aware that this is the pattern that we encourage them to follow. And and as a part of community open, so we should be actively looking towards the issues and they will be raising and actively raising and reviewing the code of the PRs, just to make sure that the code that will be pushing are tested, and it should not broke the other like who will be using that repo or the project. They should not be it should not be broken because of those PR changes.
Neha, wow, so many facts. I have a question to you. So is it which one do you agree more with? Should OSPOs mainly focus on projects within the company and projects related to the own business, or should they also connect and support the community in a wider area? I don't know. Like, what should be the specific goal, right? It could be more narrow, it could be bigger. And then, of course, how much resources should the OSPOs get? Like from a company, maybe we can pick a percentage, right? So how much resources in the company, percentage-wise? We know it's a figure, right? Like it's just like some imagination, but it would give us an idea. What's your opinion?
So I feel both are important to maintain the community as well as to drive the business for which we are working on. So it depends on like the priorities of the company basically. But yeah, maybe in terms of business, it sometimes becomes difficult, as in if there are not enough resources to maintain the community, the open source community, then it might get difficult for a person to contribute on the open source. But yeah, as from my perspective, both are equally important. As in, yeah, one from the company perspective and one from the open source perspective.
Yeah, so I have to say, like, actually, FOSSASIA is also a company. It wasn't a decision originally that we really wanted a company, but it was like very challenging NGOs in Asia, right? I mean, how you set it up, it's in different countries. So we registered as a company, and I don't know what's the percentage that we invest in the open source community, but I see there's not so much on the bank accounts. So I don't know, but like sometimes we see sponsorships and so on. But Hongfu, I think it's a large part, right? Is it 40%? Is it 50, 60, 70, or 30? I don't know. Do you have an idea?
Not our work. I will contribute to open source. We fully work for the open source. All the work what we do, we already released open source, and we also funding student program based on our limited resources. So I think that with the limited resources that we have, we already did the best that we can. So we run a program like over the years. The FOSSASIA Summit, only one thing that we do, we have released multiple open source projects that being showcased here at the FOSSASIA Summit. Our developers are giving workshop at the moment on the project, and I think that like Alex here, who he gave a demo, excellent demo earlier on the Rocket Science Lab. Rocket Science Lab is also a project of FOSSASIA. We also released it to open source, and
We lost you.
Yeah.
Affordable to the students, and I think this is something that we contribute already to the education sector. Yeah. So I don't know what else that you want me to.
Yeah, I would like to ask one question here. How do you make sure that there should be constant focus on the community from the open source community perspective? Because as like Mario asked this question, there should be because it's sometimes there is a priority from the company perspective as well, and from the open source community. How do you make sure that there should be enough contribution, or there should be someone looking at the open source community as well to maintain it properly in FOSSASIA organization?
Are you asking the question to FOSSASIA or in general to companies?
Yeah, if you were asking us, so you were answering, so maybe you can answer like how exactly you make sure in the across your organization.
How to make sure that organization contribute to open source?
Yeah, maintains just to keep a constant focus on the person who will be contributing open source to your repo. How do you make sure that you give constant or enough resource to have a glance at what exactly they are doing? If are there any questions that you should be looking towards or addressing it?
Well, I think that is an excellent question. How do we make sure that companies contribute back to open source, right? So I think I think there is a term that called a good open source citizen, and it become like a trend from the internet. So people look at companies, the way they behave, the way they act in the communities, and the most important resources for the companies are human, right? People also looking for developers. And to be honest, if you are running a company, right, so your main focus is doing the business. Of course, whatever decision they make need to align with their business strategy, but how to make sure that they can contribute is about the people who work for the company, about the community. Is there a pressure? Is there it's like they want to is there a good image to the community if you want to engage like good people that work for you? Yeah, so for some companies that I did the open source strategy, so for them it's a lot about giving the good images. They can attract more talents. Or if company heavily depends on open source, as you know that you can only influence the direction of a certain project if you also contribute back, right? So this is just a whole ecosystem. You use something from the open source community in order to sustain, because if it is a part of your platform, part of your business access, of course you want to have some staying in the direction of certain project, and therefore contribute back to open source is important, not only just because the company wants to do good work, but there is a business interest involved, I think.
Cool.
Yeah.
And now I see Neeraj is joining. Neeraj Chaudhary. Neeraj disappeared.
But I haven't finished my answer to the Neha.
I just want to try, because as an open source organization like FOSSASIA, how do you exactly make sure like this open source there is like as in the image that you carry on with the open source, it maintains throughout?
Well, this is something that we need your help actually. So you are here, you come to us, you see what we are doing, and if you can share the word and with other people and support us. So the more support we get, we also get the company to aware of the movement in Asia. And so I think it's the power of community. The more pressure we give out, the more concern we show to the companies, so we can trigger more action. Stephen, do you think that is, can I say that? So if we can raise awareness and raise more concern, we can also trigger more action.
Yes, so and that will be a big part of the university, I suppose, for a while now, is really raising awareness, especially for me, because I took the S out of my OSPO. We're an open programs office because I wanted people in open hardware and data and science and access and OERs to know that we work for them too. So we have so many different groups doing so many different things. It goes way beyond just software. It goes to all of those areas. Teaching them about that, how to use it. Mary likes Open Solutions Office. That should have been another choice. Yes, I went with Open Programs. Sorry, Mario.
Open Solutions Programs Office.
Open Solutions Program Office.
Well, nice chatting with you guys. I wish we could now head out and have some satay or.
But Harish can just go out.
Yeah, Harish can go out every day. It's a good life.
Next year, FOSSASIA will be in person, and perhaps I can go.
Well, I've almost gotten my vaccination, so we should be getting out very soon. No, actually, in Singapore we are relatively okay. So
number 2 tomorrow.
All right, good stuff. Yeah.
Yeah, my father got it already. My mom is gonna get it in 2 weeks, and I don't know when I will get it. And yeah, we'll see, right? But
I'm just curious, how are you notified when you are eligible? What is the process? Well, let me just quickly say how do it in Singapore. We get there is a website you go to, and you just put in your phone number and your name and your ID, and then it tells you whether you're ready or not. That's it. and the moment you're ready, they send you an info ping, and you're good to go. So you can keep checking.
We're not as efficient. It's tiered, right? You know, there's first people with at this age or with these medical conditions and so on and so forth. And then if you meet that criteria, you get online and you try to make an appointment. Unfortunately, because the U.S. is the U.S., it's done by state, right? The federal government can say, here's what we would like to see, but each state makes their own decision and puts up their own processes. So it's a mess. I wish it were like Singapore.
Well, we had unfortunately one person passed away today from that. So he's the 60th person to pass away in Singapore. So a year later, 60 people. So
that's that's sad. But I want to share how they do it in Germany. So maybe you have heard that Germany is doing amazingly, and it's kind of scaring. We're doing amazingly well with the economy. I'm not saying like everything, but with the economy, like China and Germany, they're doing well in the pandemic. And yeah, that's pretty scary. And I don't know why, but I'm seeing this, that everything is just an economics package. So instead of like, for example, giving everyone masks for free and just, you know, like people can pick it up, we have a list where people get like a letter from the government, and there are posters, and there are, you know, agencies advertising for it and so on. So the whole agencies and the whole thing costs more than giving every German 6 masks. Yeah. For free. So that's a kind of stimulus packages that you I don't know, like that's how they're doing it here. The same with the vaccination and so on. You get a letter. Yeah, and the post office is busy. Everyone's busy. That's how we do it. Yeah. Neha, UK is doing well. You live in London, and you are vaccinated. That's why you look so happy.
No, no, not yet. Yeah, but maybe probably soon, maybe in a couple of months. Here also they are like targeting age range wise. So 80 above 70 or so. Yeah, maybe 2-3 months. My time might come. So, but yeah, for the moment, yeah, but the situation is being better here, considering last 2 months because of the lockdown and everything. But yeah, it's been better. So yeah, now we can go outside. Yeah, but alone, yeah, but we can roam around and yeah, so that's good probably.
So it seems like people like to listen to us, but they don't want to join. People, yeah. So I thought
just one thing what to add. Well, Roland just showed up.
Yes, yeah, I'm looking.
And he's gone again. Hi. I miss Germany too, Mario. I teach game design courses from the US that go to visit German companies who do game design. I've done it 3 times in the past 6 years, and of course not this year, but next year perhaps.
Yes, hope so, right? And Roland, how are things going for you? How do you like do things now? I know you always went dancing, open source dancing, but like now you can't do it.
Yes, that's been probably the largest change in life, is that quite obviously any sort of partner dancing is out. The other one, of course, that affects everyone is that all tech events have gone online. So yeah, I'm missing that a bit, but otherwise life as usual. It happens that my company closed its Singapore office about 18 months ago. And so I was already working out of cafes anyway. And so apart from the circuit breaker period, that's more or less what I've been doing. And because of the very low rate of cases here, the community transfer is 0 cases most days. And consequently, apart from sort of dealing with hygiene measures, mask, hand washing, check-ins and so on, it's sort of life as usual. But yeah, no dancing. It'll come back one day, but yeah.
Well, we can go for a run, we can go for a cycling, we can go walking, we can do hiking. You know, that's fine. It works.
That that was clear right from the beginning, even through the circuit breaker. What in most places is called a lockdown. In Singapore, most restaurants retain the option to continue trading, but only for takeaway and delivery. We were sort of confined to our homes for 2.5 months, 3 months?
2 months, 2 months, I think. Is it 2 months?
Just after 2 weeks after FOSSASIA, and then up until end of June. But yeah, we were never unable to go out and exercise and that kind of stuff. So it's been
it was a funny thing because in May my younger son was enlisted for national service, but what happened was they called him at home, and the person at the other end said, okay, you are enlisted from today, but you stay at home, don't get out of the house. You have to inform us if you're going to step out of the house, because it was locked down anyway, right? I mean, or what you call circuit breaker. So for a month, essentially, he was at home.
When he was at home for the month, Harish, did you wake him up in the morning by yelling, drop it and give me 20 and
well, you know, the funny thing, I didn't have to do it. His phone rang because his sergeant kept calling to check whether he's at home. So I think it was 3 weeks or maybe 4 weeks, I don't know. But then eventually, you know, in June, as soon as it was opened up, he went into camp. So, but that 1 month is counted towards his 2 year service, so that's fine. And he gets paid to do nothing, so that's fine.
A specialized service for one's nation. Stay inside.
Exactly.
Watch
Stay
television.
inside. No, he doesn't know what TV is. He's on YouTube most of the time.
Even as I said it, I was like,
And now there's a question of Niraj here. I'm relaying questions from the chat. This is for what to talk about here?
Anything.
Please clarify. And there's Alexandre Vatrin, or Alexandre Vatrin, I don't know, Alexandre, maybe from France. You can also join the channel if you want. I have a question for Harish. What about the future of CentOS? Is there a future?
It's a future. It's called CentOS Stream. That's what it is. It is live. It is doable. It works today. It has been working for a while, and just go for it.
Okay, but hello.
I think this is kind of a closing thing for SJ and also for me. So
okay.
I will end it here, but like the channel is open. Anyone who wants to talk, also in the people here who are in the list who are just listening, please feel free. Good to see you, Roland, Harish, and I hope we can catch up soon. Anyway,
yeah,
a few more days to go. We have a nice program.
Okay, I think that there's just one lesson that we learned. Make sure you get the speakers to pre-record as much as possible.
I didn't want to get into this discussion, but now that
you okay, now you're busy. You go off now. No, so you CentOS record it. That's fine. You know.
Okay, so for example, I have several talks where the people like react directly to the chat and to the speakers. I think the challenge that we have here is that, for example, Hopin.2 or something works still more smoothly than what we have set up here. Yeah, and anyway,
that's
like
okay.
You know, this and that, we can still improve. But we can also, like, for example, they have this option where you can get into a room and then they click on it and you go to the public room. So you don't have to change your configuration, things like that, right? I mean, all that is not magic, but I think what we achieved to do here and like put together with the existing tools widely, it's already pretty nice. And I'm confident if we continue in the same speed that we can have a project that is competing with other proprietary solutions, and then it will not be such a big issue if people have like login issues. But like Hong Fook would be very sad if you keep such a very critical opinion, because Hong Fook spent I don't know how much time. I just saw on the screen all the time with speakers around the world, 160 people testing. So
yes, I know. I saw that test. I was there too. Yeah. So it's a lot of work. I mean, totally agree. But somehow for some individuals didn't work out well enough. So
yeah. And I just wanted to go now. Robert also coming here, joining us.
Hi, Robert.
Yeah. Hi. I've been listening in a bit, doing some work, but yeah, I wanted to say, I mean, I had problems earlier, but honestly, I've also seen a whole conference where hop-in was a big problem. So I think it's worked fairly well actually throughout. So the problems I think are more on the user side. In my case today, I think it was my system at the end. Yeah, used a different webcam, and that was just it. There's nothing you can do about that.
yeah. I mean, that's the value of pre-recording. At least that's you know it is done, and that's really what it is. So,
I think it worked well.
Good enough. We got another 6 days to go.
But do you think this is working out for now? Like, so one track mostly, yeah, and then like more like business topics during the week, where like, for example, people who work in the office could join in. But like on the weekend, a lot of people who were on the weekend, they said we only have time on the weekend. Yeah, otherwise I think we would have done maybe only one weekend or keep it shorter.
Well, the one comment I got from someone, I forget who it is, why is this it's almost eight days long? So I said, look, if you look at what it used to be, it was about 4 days, but you have multiple tracks. So now we just flattened it out and stretched it out. That's really what it is. So, they didn't know that it was 4 days previously and multiple tracks. So it's a trade-off. But I think the only challenge is the amount of time people can spend, even if you are interested for everything on a daily basis. It's going to be hard.
Yeah. Yeah, but like that's actually, we don't think, like, for example, like today and also a bit more tomorrow, we had hardware focus, and then tomorrow blockchain, and every day is a bit of different focus. Thursday is like entirely databases. So
yeah.
But anyway, like we would have done it shorter, but like we had so many submissions, more than in the past. Yeah, so do we want to say no if the people want to go? And you look at the speakers, right? Outstanding speakers. I mean,
outstanding.
Really,
yeah, outstanding. No, I'm actually very pleased. I'm very happy that it's day 2 already. So it is awesome stuff.
Folk, are you satisfied so far?
She's muted. You're muted. Okay.
I think that we can do better. So this is the first 2 days. I hope that we have like a smooth experience tomorrow. Yes, I'm not happy yet. I think that we can do better with the streaming. I hope that all the recordings worked out, because they're all about like sharing knowledge and information. So if they online, people can go back and look at it. Yeah, and so I think we, in terms of timing as well today, even though we have like people with different interests, it was a little bit too tight, like from one talk after another. Even though there's some space at some talks, right? But I think so we could leave a little bit more space just in case today. And I just yes, Harris said, and also Robert, right? Some speaker that I noticed that they were in the test call before and everything were working out at that time. So I did not know. And also today, I think Roland was in the support room supporting the speakers. Sometimes it worked out for them in the support room, and then they come in and there was an issue. So I also don't know.
Yeah, so I came in at the wrong time and everything seemed to work, and then I think I was switched off. I mean, I came in at the original right time, but the schedule had moved a little bit slower. But then I think when you switched me off, the problem was I was still on the same connection and I had to reconnect completely.
Okay.
We figured out. And apart from that, Robert, I didn't expect you to stay the whole day. Is it so interesting? Did we do so well in regards to the topics? Yeah.
Honestly, I hopped in and out of a few sessions, and I find it very interesting that now this event, which was more on open source software, is taking on these open hardware subjects more and more. So therefore, I think I'll be tuning in more in the future. I like this also, this orientation of the event.
We actually had open hardware also in the past, Robert. It's not the first time we have open hardware, Jack. We had open hardware before too.
But it's growing. There's more and more of it, which is great.
Yes,
Yeah.
it's more enjoying. Yeah, that is correct. But actually, it would be something interesting for Robert. We have the chip producer from China coming tomorrow, I think. Is it Lambda chip come tomorrow, Mario?
Yeah.
Yeah, I think
Lambda
Lambda chip. Yeah.
Yeah, sounds interesting. I'll have a look at it.
Guys, I'm going to bail out. Till see you all tomorrow.
Yeah.
See you tomorrow.
See you
Take care.
tomorrow. Good night.
Thank you, everyone. See you tomorrow.
Bye,
Good night.
Robert.
Cheers. Bye-bye.
Bye, everyone.
Ciao.
Thank you.